Hi everyone, welcome back. I am super excited to welcome you to this brand new course, Master Spring Boot 4. And the best part, this complete course is absolutely free on my YouTube channel. If you want to become a back-end developer or upgrade your Spring Boot skills to the latest version, then this course is going to be a game changer for you. We are not just going to learn theory, we are going to build real-world applications step by step. And most importantly, we are going to build 3 to 4 complete real-world projects from scratch. This course is designed in a simple, practical and beginner-friendly way so that anyone can follow along. You will learn how to build RESTful web services as well as web application. By the end of this course, you will have the confidence to build production-ready Spring Boot applications. Let's get started. What is Spring Boot and what are its main features? Spring Boot is a framework built on top of the Spring framework. Its main purpose is to make Java application development easier, faster, and far more productive. Before Spring Boot existed, developers wrote a lot of configuration manually. They created XML files, registered beans, configured servers, and managed dozens of setup steps themselves. Even small applications required too much effort and too much configuration. Spring Boot solves that problem completely. It removes heavy configuration, it provides sensible defaults, it auto-configures commonly used components, and it helps developers build production-ready applications with minimal effort. That is why companies love Spring Boot. That is why interviewers focus on it, and that is why it has become the standard for modern backend development. Now let's put this in interview style. If the interviewer asks, "What is Spring Boot?" your answer can begin like this. Spring Boot is an opinionated framework built on top of Spring that simplifies Java development. It provides auto-configuration, starter dependencies, and an embedded server, allowing developers to create standalone production-ready applications quickly with minimal setup. Let's break that down so you can speak it naturally. When we say Spring Boot is opinionated, it means Spring Boot makes smart decisions for you. It chooses sensible defaults. It configures the common things automatically. You don't worry about choosing the correct Jackson version. You don't manually configure the dispatcher servlet. You don't manually set up Hibernate or the server. Spring Boot handles all of that behind the scenes. The next major feature is auto configuration. This is the heart of Spring Boot. Auto configuration scans your class path, checks your dependencies, and configures the components your project needs. If you include Spring Web, Spring Boot sets up the dispatcher servlet, JSON handling, error handling, and the embedded Tomcat server automatically. If you include Spring Data JPA, it configures Hibernate, the entity manager, transaction management, and connection pooling. You start writing business logic immediately. Another key feature is starter dependencies. Spring Boot provides prepackaged sets of libraries. Instead of manually searching for compatible library versions, you add a single starter. Starter Web gives you everything for building REST APIs. Starter Data JPA gives you everything for JPA. Starter Security gives you everything for authentication and authorization. These starters eliminate version conflicts and make dependency management clean and simple. Now let's talk about the embedded server. Before Spring Boot, you deployed applications as WAR files into external servers like Tomcat or Jetty. With Spring Boot, the server is built in. When you run the application, Tomcat or Jetty or Niti starts automatically. No installation, no deployment, no manual configuration. This feature is one of the biggest reasons Spring Boot became the foundation for microservices. Each microservice runs independently, has its own server, and is very easy to deploy. Let's connect this directly to microservices. because interviewers always look for this point. Spring Boot is widely used to build microservices because it produces small, self-contained, standalone applications. When combined with Spring Cloud, you get service discovery, API gateway routing, distributed configuration, load balancing, and fault tolerance. Together, they form a complete microservices ecosystem. Another major feature is Actuator. Actuator gives you production-ready endpoints for monitoring your application. You can view health checks, metrics, environment details, and system information instantly. You don't write any extra code. Actuator provides everything out of the box. This is incredibly helpful for microservices, cloud deployments, and production monitoring. Spring Boot also improves the development experience with DevTools. DevTools automatically restarts your application when you change your code. It also supports live reload for templates. This saves time and makes your development workflow feel smooth and fast. Another important area is configuration management. Spring Boot supports externalized configuration using properties or YAML files. You can create multiple profiles for different environments like development, test, staging, and production. The same application behaves differently based on the active profile. This keeps your configuration clean and avoids hard coding values. Now let's put everything together into one strong, clean, interview-ready answer. Spring Boot is a modern, opinionated framework built on top of Spring that simplifies Java development. It removes boilerplate configuration and offers features like auto-configuration, starter dependencies, and an embedded server. These features help developers build standalone production-ready applications very quickly. Spring Boot provides Actuator for monitoring, DevTools for rapid development, and external configuration support for managing environments. Because it is lightweight, fast, and easy to deploy, Spring Boot is widely used to build microservices and cloud-native applications. Overall, Spring Boot reduces complexity, increases productivity, and helps teams deliver scalable applications faster. Hi everyone, welcome back. We are going to understand the difference between Spring and Spring Boot. Let's begin with the primary objective. Spring Framework is a comprehensive Java platform designed to give developers tools for building large-scale enterprise applications. It focuses on providing infrastructure, dependency injection, AOP, transaction management, template utilities, and many other lower-level features. But Spring Boot has a very different mission. Spring Boot is built on top of Spring, and its primary goal is to simplify Spring application development by giving you auto-configuration, sensible defaults, and runtime simplicity. In simple words, Spring provides the foundation, and Spring Boot makes that foundation easy to use. Now let's talk about configuration. With Spring Framework, you have to configure almost everything manually. You set up XML files, define beans, configure view resolvers, and integrate the tools yourself. It is powerful but requires a lot of effort. Spring Boot solves this by providing auto configuration and opinionated defaults. Instead of writing manual configuration, Spring Boot configures most things automatically based on the dependencies in your project. This dramatically reduces setup time and eliminates boilerplate. Next is project setup. Spring applications traditionally required a lot of initial work. You had to add many dependencies, choose compatible versions, and create a proper project structure. Spring Boot makes this extremely easy. It provides the Spring Boot initializer where you select your dependencies and instantly generate a ready-to-use project in seconds. This alone saves hours of manual setup. Let's move to web servers. Spring Framework relies on external servers like Tomcat or Jetty. You typically deploy your application as a WAR file into those servers. Spring Boot completely changes this experience by providing embedded servers. Tomcat, Jetty, and Undertow are built directly into your application. You simply run your Spring Boot application as a standalone jar, and the server starts automatically. This makes development faster and deployment much simpler. Now let's understand deployment differences. Spring Framework typically generates war or year files that are deployed to external servers manually. Spring Boot applications usually generate standalone jar files that already contain the embedded server. You run the jar file and your application starts instantly. No deployment steps, no external server installation. This is a huge advantage in microservices and cloud environments. Speaking of microservices, let's compare those next. Spring Framework requires manual setup and integration of several tools to build microservices. Spring Boot, on the other hand, works seamlessly with Spring Cloud and provides everything needed for microservices: service discovery, load balancing, API gateway, centralized configuration, tracing, and more. This makes microservice development straightforward and production ready. Let's also discuss production ready features. With Spring Framework, you need external tools or manual configurations for monitoring, health checks, logging, and application metrics. Spring Boot provides these out of the box using Actuator. You get health endpoints, metrics, environment details, and monitoring support without writing any additional code. This is especially valuable for real-world deployments. Next is properties and configuration. Spring Framework requires manual configuration of property sources and hierarchy. You decide where properties come from and how to manage them. Spring Boot simplifies this by giving you a unified configuration approach using application properties or YAML files. It also supports environment-specific configurations, making your application easy to deploy across dev, test, staging, and production. Let's move on to testing. In Spring Framework, testing often required additional configuration for mocks, integration tests, and loading context. Spring Boot improves this significantly. It provides built-in testing support using at Spring Boot test, at Mockito Bean, and auto-configured test context. This reduces complexity and makes testing far easier. Now let's put this into a clean interview-ready explanation you can speak confidently. Spring Framework is a comprehensive platform that provides low-level infrastructure for building Java applications, but it requires a lot of manual configuration. Spring Boot is built on top of Spring and focuses on simplifying development through auto-configuration, embedded servers, sensible defaults, and production-ready features like Actuator. Spring typically uses external servers and war deployment, while Spring Boot uses embedded servers and produces standalone jar files. Spring Boot also integrates more easily with microservices tools using Spring Cloud and provides a much easier learning experience. Hi everyone, welcome back. In this lecture, let's understand one of the most powerful features of Spring Boot, the auto-configuration feature. Well, one of the biggest goals of Spring Boot is to reduce configuration and make application development faster and easier. Before Spring Boot, developers had to manually configure almost everything. For example, creating beans for the data source, configuring the dispatchers, servlet, registering view resolvers, and even defining Jackson converters for JSON serialization. All of this was done through long XML configuration files or Java configuration classes. It was repetitive, time-consuming, and error-prone. To solve this problem, the Spring Boot team introduced auto-configuration, which automatically configures your application based on the dependencies that are present in the class path. Let me repeat that. Spring Boot auto-configuration automatically sets up the required Spring Beans depending on the libraries you have added to your project. So, if a dependency is available in your class path, Spring Boot will automatically configure related beans so that you can start coding immediately without writing any boilerplate configuration. Let's take a simple example. Suppose you have added the Spring Boot Starter web dependency in your pom.xml file. As soon as you include this dependency, Spring Boot automatically configures several key components for you, like the embedded Tomcat server, the dispatchers, servlet, JSON converters through Jackson, and many other internal beans that are required to handle web requests. You don't have to manually create or configure any of these. They are all auto-configured behind the scenes. That's why when we created our Hello World REST API earlier, we didn't have to do anything special. We simply created a controller class and started the application, and it just worked. All of this happens because of Spring Boot's auto-configuration mechanism. Now, the class that enables this feature is called @enableAutoConfiguration. In fact, when we use the @Spring Boot application annotation at the entry point of our application, it internally includes this @enableAutoConfiguration annotation. So even though we don't write it explicitly, it's already there, and that's what triggers the whole auto-configuration process. Let's understand what happens behind the scenes. When the application starts, Spring Boot scans a special file called meta-inif/spring/org.springframework.boot.autoconfigure. This file contains a list of all the auto-configuration classes that are part of Spring Boot's core modules. For example, WebMVC auto-configuration, data source auto-configuration, Jackson auto-configuration, security auto-configuration, and many others. Each of these classes is responsible for setting up the necessary beans for a specific feature of Spring Boot. So, Spring Boot detects what's available in your project and automatically configures it for you. This mechanism is made possible using conditional annotations like @conditional on class, @conditional on missing bean, and @conditional on property. These annotations tell Spring Boot to enable or disable certain configurations depending on whether a specific class, property, or bean exists. For example, the WebMVC auto-configuration class uses @conditional on class to make sure it only runs if classes like dispatcher, servlet, and servlet request are available. This means if you remove Spring Boot Starter WebMVC from your dependencies, Spring Boot will not configure the web layer because those classes won't be found in the class path. So everything is conditional and smart. Spring Boot only configures what's necessary for your application. Now, if you ever want to see which auto-configuration classes are getting applied, you can enable a special property called debug equals true inside your application.properties file. When you run your application again, Spring Boot will print a detailed report in the console showing which auto-configuration classes were activated and which ones were skipped and why. That's a great way to understand how auto-configuration works internally. To summarize, Spring Boot auto-configuration is all about reducing manual setup. It automatically creates and wires up beans based on the dependencies you have added in your class path. It uses conditional logic to decide which configurations to apply, and it saves you from writing large amounts of boilerplate code. So in short, you focus on writing your business logic, and Spring Boot takes care of the configuration for you. Alright, that's all about the auto configuration feature in theory. Hi everyone, welcome back. In this lecture, let's take a look at one of the most useful features of Spring Boot, the Spring Boot starters. Before we understand what starters are, let's first look at the problem that they were designed to solve. Well, before Spring Boot existed, if we wanted to create a Spring MVC application, we had to manually add a lot of dependencies. Things like Spring Web MVC, Jackson for JSON, a servlet API, and a web server dependency such as Tomcat. And then we had to carefully manage compatible versions for all of these. Let's say you also wanted to use Hibernate with Spring Data JPA. Again, you had to add each dependency, Hibernate Core, JPA API, Spring ORM, and make sure their versions worked perfectly together. And if you decided to secure your application with Spring Security, you would have to repeat the process, adding multiple security related dependencies and maintaining compatible versions. So maintaining all of these frameworks and version alignments was painful. It often led to class path conflicts and no such method error issues during runtime. This is where Spring Boot starters came in to solve that problem. Spring Boot starters are pre-configured dependency descriptors that bundle commonly used libraries for a particular functionality with the correct versions already managed for you. In simple terms, a starter is just a single dependency that automatically pulls in all the other libraries you need to get started with a specific feature. For example, if you want to build a web MVC application, you no longer need to add a dozen different dependencies manually. You can just add one dependency, the Spring Boot Starter Web MVC. Starting from Spring Boot 4, the traditional Spring Boot Starter Web dependency has been renamed to Spring Boot Starter Web MVC. This single starter dependency internally brings in Spring MVC, Jackson for JSON, the embedded Tomcat server, and the HTTP converter module, all with compatible versions. That means just by adding this one dependency, you automatically get everything you need to build a fully functional Spring MVC web application. Let's take another example, the Spring Boot Starter Data JPA dependency. When you add this starter, it automatically includes all the libraries required for working with the relational databases: Hibernate ORM, Spring Data JPA, the Jakarta Persistence API, and JDBC support, all pre-configured and version managed. This means you don't have to worry about which version of Hibernate works with which version of Spring Data JPA. Spring Boot takes care of that internally. Now let's say you want to add security. In that case, you just include the Spring Boot Starter Security dependency. This single dependency automatically includes all the Spring Security modules you need, such as core, web security, configuration support, and cryptography libraries. All of these come from the same compatible version family. Similarly, for testing, we have the Spring Boot Starter Test dependency. This starter includes JUnit 5, Mockito, Hamcrest, AssertJ, JSONPath, and other popular testing frameworks, so you don't have to add or manage them manually. Now behind the scenes, all of these starters rely on the Spring Boot dependencies BOM, that's the bill of materials file, which manages all the versions of these dependencies for you. So when you add a starter dependency, Spring Boot automatically aligns the correct versions of every library based on what's defined in the Spring Boot BOM. This ensures consistent, stable builds and prevents version conflicts between frameworks like Spring, Hibernate, and Jackson. There are many other starter dependencies that come with Spring Boot. Let's look at some of the most popular ones. For building web MVC applications, Spring Boot Starter Web MVC. For working with JPA and Hibernate, Spring Boot Starter Data JPA. For securing your apps, Spring Boot Starter Security. For building RESTful microservices that expose or consume JSON, you can use the Spring Boot Starter Web MVC, which already includes Jackson. For reactive applications, Spring Boot Starter WebFlux. For ThymeLeaf-based web UI applications, Spring Boot Starter ThymeLeaf. For testing, Spring Boot Starter Test. And for logging, Spring Boot automatically includes the Spring Boot Starter Logging, which brings in Logback and Self4j as the default logging framework. So you can see, the idea behind all these starters is to help developers get started quickly without having to manually add or manage multiple library versions. Now, let's see one complete example in action. Let's go to IntelliJ IDEA and open the pom.xml file. Inside the dependencies section, you will see something like this: group ID, org.springframework.boot, and artifact ID Spring Boot Starter WebM VC. Now this single dependency automatically brings all the required libraries to build a web application and RESTful web services. Let's take a quick look at what this dependency includes internally. If you open Spring Boot Starter Web MVC dependency, it internally provides the following dependencies: Spring Boot Starter, Spring Boot Starter Jackson, Spring Boot Starter Tomcat, Spring Boot HTTP converter, and Spring Boot Web MVC. And if you go one level deeper, the Spring Boot Web MVC module itself includes Spring Web and Spring Web MVC from the core, Spring Framework 7, as well as servlet and converter dependencies. So in short, when you add just one dependency, Spring Boot Starter Web MVC, Spring Boot automatically brings everything you need for building REST API and MVC based web applications. You don't have to manually configure Tomcat, Jackson or servlet mappings. Everything is auto-configured behind the scenes. Let's understand how this helps. When your application starts, Spring Boot's auto-configuration system automatically configures a dispatcher, servlet, a default embedded Tomcat server, and a JSON message converter using Jackson. So you can directly focus on writing your REST controllers and business logic instead of worrying about configuration or dependency management. Each starter internally manages all the necessary dependencies and versions for you. You just declare one dependency and Spring Boot takes care of the rest. That's the power of the Spring Boot starter concept. Let's quickly recap. Spring Boot starters solve the problem of dependency management and compatibility across different frameworks. Each starter is a single dependency that automatically brings in all required libraries and versions. With Spring Boot 4, the starter names have been modernized. For example, Spring Boot Starter Web MVC instead of the older Spring Boot Starter Web. These starters make Spring Boot projects lightweight, version safe, and easy to maintain, letting you focus on writing business logic instead of configuration. In the next lecture, we'll take a closer look at the Spring Boot Starter parent and understand how it manages dependency versions and Maven plugins behind the scenes. Alright, great, I'll see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to create and set up a Spring Boot project in IntelliJ IDEA. First, we'll create the project using Spring Initializer and then we'll import it into IntelliJ IDEA. Let's head over to the browser. In a new tab, type start.spring.io. This will open Spring Initializer. Spring Initializer is a web tool that we can use to quickly create and bootstrap Spring-based applications. Now let's go ahead and fill in the project details. Here we can choose the project type, either Maven or Gradle. We'll use Maven, so keep Maven selected. Next, choose the language. We have Java, Kotlin and Groovy. We'll use Java, so keep that selected. Now select the Spring Boot version. We'll choose Spring Boot 4.0.0 milestone 3, the latest version available as of now. We want to use Spring Boot 4, so here we are selecting this 4.0.0 milestone version 3. Avoid using snapshot version. While watching this video, you may see different Spring Boot version, but make sure to use the Spring Boot 4 and above. Next, let's fill in the project metadata. For the group, enter net.javaguides. You can give any group name you like. For the artifact, enter Spring Boot REST API. Next, for the project name, also enter Spring Boot REST API. Add a short description, demo project for Spring Boot REST API. For the package name, set net.java.spring.boot. Keep packaging as jar. Next, select Java version 25, which is the latest version and long-term support release as of now. Now let's select the dependencies. Click Add Dependencies. In the search box, type Web. You will see Spring Boot Starter Web. This dependency is used to develop RESTful web services. It also includes Apache Tomcat as the default embedded web server, so you can run your Spring Boot app directly without installing Tomcat separately. Select Spring Web, and for now we'll keep just this single dependency. If we need more dependencies, we'll add them in upcoming lectures. Now click on Generate. Spring Initializer will generate the project and download it as a zip file to your local machine. Once it's downloaded, open the folder and unzip the project. Perfect. Now we have our Spring Boot REST API project ready. Next, let's import this project into IntelliJ IDEA. Open IntelliJ IDEA. You will see a few options like new project, open and get from wishes. We'll choose open since we already have an existing project. Click open. Navigate to the folder where you unzipped your project. In my case, it's in the downloads folder. Select the project and click open again. Now IntelliJ will open and import the Spring Boot project. Great. Let's explore the project structure. Inside the project, you'll find a main folder. Within it, there are two subfolders, Java and Resources. Inside the Java folder, we keep all our application source code. Inside the Resources folder, we keep static files, templates, and the application.properties file where we define project configurations. You will also see a test folder. This is where we write all our unit test cases. Next, open the pom.xml file. This file contains all Maven dependencies and plugin configurations. Now let's look closer at the Spring Boot Starter Web dependency. Spring Boot Starter Web is a convenience dependency that brings together everything you need to build RESTful services and web apps. It includes essential modules like Spring Web, Spring Web MVC, and Spring Boot Starter JSON. It also includes Tomcat as the embedded server. So with just this one dependency, you get all the components needed to develop and run RESTful services directly from your IDE. No external setup required. This means we don't have to manually configure or install an external Tomcat server. Spring Boot will automatically use the embedded Tomcat to run the app in your local environment. Alright, now let's run the Spring Boot application and see it in action. Go to the main entry point class. This is your application's starting point. You'll see a main method inside it. Just like any standard Java program, Spring Boot applications also start execution from the main method. So go ahead and run this class. In the console, you will notice that our Spring Boot application starts successfully on an embedded Tomcat server running on port 8080. Perfect. Our Spring Boot setup is complete. Let's quickly recap what we've done in this lecture. We created and set up a new Spring Boot project in IntelliJ IDEA. We reviewed the project structure, explored the Spring Boot Starter Web dependency, and ran the application successfully on the embedded Tomcat server at port 8080. In the upcoming lectures, we'll start building our RESTful web services step by step. Alright, great. I'll see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create a simple Spring Boot Hello World REST API. Creating REST APIs using Spring Boot is very simple. Alright, so let's head over to IntelliJ IDEA and quickly create a simple Spring Boot REST API. Go to the main package, and within that, let's quickly create one more package and call it controller. Within the controller package, we keep all the Spring MVC controllers. Now let's go ahead and create a Spring MVC controller. Right click on the controller package, select new and then choose Java class. Let's give the class name as Hello World Controller. Notice the naming convention for this Java class. Hello World Controller. Whenever we create a Spring MVC controller, we always use controller as a suffix for this class name. Here, Hello World is the resource, followed by controller as the suffix for that resource. Some developers also use other naming conventions like Hello World Resource, but in typical Spring MVC projects, we use the naming convention Hello World Controller. We always use controller as the suffix for a controller name. Now we have our Hello World Controller class created. Let's make this Java class a Spring MVC controller by using the RT-controller annotation. Go ahead and annotate this class with @controller. Notice that the @controller annotation is a stereotype annotation from the package org.springframework.stereotype. Whenever we develop RESTful web services using Spring MVC, all the REST APIs return JSON to the client. To convert a Java object into JSON, we use the @response_body annotation. Let's go ahead and use the @response_body annotation here. Whenever we develop RESTful web services using Spring MVC, we always use these two annotations, @controller and @response_body. We use @controller to make this class a Spring MVC controller and @response_body to convert the response from a Java object to JSON and then write that JSON into the HTTP response. As we know, whenever we develop RESTful web services using Spring MVC, we have to create a controller class and annotate it with these two annotations. The Spring team thought, why not create a single shortcut annotation that internally uses both of these annotations? So the Spring team released the @REST_controller annotation. It internally uses both @controller and @response_body annotations. For example, let's remove these two annotations and instead use @REST_controller on top of the class. Spring version 4.0 introduced this @REST_controller annotation, and it's a combination of @controller and @response_body. If we look into the source code of the @REST_controller annotation, you can see that it is annotated with both @controller and @response_body. So @REST_controller is just a shortcut version of using these two annotations together. Instead of using both, we can simply use @REST_controller. Perfect. Let's go back to our Hello World controller class. Now we have annotated it with @REST_controller. Just remember, whenever you want to develop RESTful web services using Spring MVC, you have to annotate the class with @REST_controller. Now this class becomes a Spring MVC REST controller. Within this REST controller, we can create REST APIs. Creating a REST API is very simple. We just create a method and then use Spring annotations to make that method a REST API. So here type the method public with return type string and method name as hello world. Inside it, return a simple string like hello world. Now we have created a simple Java method. Let's make this Java method a REST API using a Spring annotation. This is going to be an HTTP GET request. So let's use the @getMapping annotation to handle the HTTP GET request. Basically, we use the @getMapping annotation to map incoming HTTP GET request to this method. Next, let's configure the URL for this REST API. Inside parentheses, pass the URI hello world. So whenever a client wants to access this REST API, they have to use the URL http://localhost:8080/hello world. Perfect. Let's copy this URL. Now let's run the Spring Boot application and test it. Stop the existing server and start the Spring Boot application again. Wait to complete the deployment. Look at the console. Our Spring Boot application is up and running on the embedded Tomcat server at port 8080. Since this is a GET REST API, we can access it directly using the browser. Open a new browser tab, paste the URL http://localhost:8080/hello-world and hit enter. And there we go. You can see the client got the response from the REST API. The REST API returned the string hello world and you can see it displayed in the browser. It means we have successfully developed a Spring Boot Hello World REST API and it's working as expected. Creating REST APIs using Spring Boot is very simple. We just have to create a Spring MVC controller, annotate it with @REST_controller, and within the controller, create Java methods annotated with the appropriate HTTP annotations. For example, @getMapping for GET requests, @postMapping for POST requests, @putMapping for PUT requests, and @deleteMapping for DELETE requests. Hey there everyone, Ramesh here back again with another video. In this video, I want to build crude REST API with Java, Spring Boot 4, Spring Data JPA, MySQL database. Well, Spring Boot 4 has released and we are going to explore how we can use Spring Boot 4 to build crude REST APIs. And we're going to use Spring Data REST API, which internally uses Hibernate to communicate with the database, and we're going to use MySQL database as a database. Okay, so we're going to implement this tutorial step by step. In the first step, we're going to create and set up Spring Boot project in IntelliJ IDEA. In second step, we'll configure MySQL database in Spring Boot project. In third step, we'll create a user JPA entity. In a fourth step, we'll create a Spring Data JPA repository like user repository that will communicate with the database and handle all the database related logic. In fifth step, we'll create user DTO and user mapper classes. So we use user DTO to transfer the data between client and server, and we use user mapper to map the entity to DTO and vice versa. In the sixth step, we'll create user REST API. In next step, we'll build get user by ID REST API, and then we'll build get all users REST API, and then we'll build update user REST API, and finally we'll build delete user REST API. Okay, so I'm going to basically create these 5 REST APIs using Spring Boot 4, which is the latest version of Spring Boot. Alright, so let us head over to the browser and let us create a Spring Boot project using Spring Initializer, and then we'll import that project in IntelliJ IDEA. So here I have opened Chrome browser, but you can use any browser that you want. In a new tab, just search for Spring Initializer and then hit enter. And here just click on the Spring Initializer link over here. Alright, and here you can see the project section. So here you can see different types of projects. We're going to create a Maven project. So let us keep Maven as selected over here. And then here we have different JVM languages like Java, Kotlin, Groovy. We're going to use Java. So let us keep Java as selected. And then Spring Boot version. So here Spring Boot is suggesting to use 3.5.6, but we are going to explore Spring Boot 4. So let us select 4.0.0 M3. Okay, don't select snapshot, just choose this one. And then go to the project metadata over here. So here let us give group com.springboot. You can give any group that you want, but make sure that the group is unique for your projects. And then artifact. Let us give artifact name as Spring Boot -user management. The artifact is same as the project name. Let us keep as it is. And then description, demo project for Spring Boot user management. And then package name com.springboot.user management. Next, packaging jar, and then Java version. Either you can use Java 25, 21, 17 as per your requirement. Next, go to the dependency section, and here let us search for Spring Data JPA. Well, we are going to connect our Spring Boot application with a MySQL database. For that, we are going to use Spring Data JPA, and Spring Data JPA internally uses Hibernate as a ORM framework. Just choose Spring Data JPA over here. Next, let us search for Spring Web Dependency. Well, we are going to use Spring Web Dependency to develop the RESTful web services. And the Spring Web Dependency internally provides Apache Tomcat as a default embedded container. Just select this Spring Web Dependency over here. And then here let us search for MySQL driver. In order to connect our Spring Boot application with the MySQL database, we have to use JDBC driver. In our case, we are going to use MySQL driver. Perfect. Next, go ahead and click on generate button to generate this project as a zip file. If you want to explore, you can just click on explore, and then here you can just see the details like version of the Spring Boot project and then the dependencies. Okay, just close it and then click on generate button, and here you can see Spring Boot application is downloaded as a zip file. Next, let us open this zip file in a folder and then extract this folder. Right click and then extract all. Select the location where you want to extract and then click on extract. Perfect, I have extracted in a downloads folder. Next, let us launch the IntelliJ IDEA and import the existing Spring Boot project. So in order to import the existing Spring Boot project, click on the open button over here and then go to the location where your Spring Boot application is present. In my case, it is in a downloads folder. And here, just select this Spring Boot project and click on select folder and then maximize this ID. Let us wait a couple of seconds because IntelliJ IDEA will automatically resolve all the Maven dependencies. Alright, now let us go through the project structure quickly. Here we have src folder. Within that we have a Java and then package, and this is the main entry point of our Spring Boot application. Next, within src folder you can see application.properties file. Here we can keep all the application level properties, and then here we have pom.xml file, and here you can see the Spring Boot version and then Java version 25. So here I'm going to use Java version 23 because I have already installed Java 23 in my machine. You can use Java 25 or you can use Java 21 as per your requirement. Let me give Java version 23 over here and then click on this sync my and changes icon over here. Alright, perfect. Now we have successfully created and set up our Spring Boot 4 project in IntelliJ IDEA. In next lecture, we will configure MySQL database in our Spring Boot project. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will configure MySQL database in our Spring Boot application so that our Spring Boot application can communicate with MySQL database. So go to our project in IntelliJ IDEA over here and go to the application.properties file, and here let us configure the MySQL database related properties. So here just type spring.datasource.url. So this is a property we use to configure the JDBC URL to connect to the MySQL database. Next, let us type the JDBC URL over here, jdbc:/mysql:/localhost. Well, our MySQL server is running on local machine, that's why I have given localhost over here. If your MySQL server is running on any other remote server, then you can specify the domain name or the IP address over here, and then followed by 3306 is the default port for MySQL server, and then followed by the database name. So let us give the database name as user_management. So here we have given a database name as user_management. So let us go ahead and create this database in our MySQL server. So just copy this database name and open the MySQL workbench over here, and here just type the SQL statement create database followed by the database name user_management. Next, select this statement and just execute it and refresh the schemas, and here you can see user_management database. Now we have created a user_management database. Next, let us go back to our project in IntelliJ IDEA over here. Next, let us configure the MySQL database username and password. For that, just type the property spring.datasource.username equal to root, and next let us configure the password as well. Just type the property spring.datasource.password. So here make sure to replace the MySQL database username and password as per your MySQL database installation on your machine. Next, let us configure one more property spring.jpa.hibernate.ddl-auto equal to update. Well, this property is pretty useful because this property tells Hibernate to automatically create the tables in a database as per the JPA entities that we create in our project. And if we do any changes in the JPA entities, then this property will update the database tables accordingly. Okay, so it will basically sync the JPA entities and their respective table columns. Next, let us configure one more property spring.jpa.show-sql equal to true. Well, this property is also pretty useful because this property prints all the SQL queries that is generated by Hibernate. Okay, now we have configured MySQL database details in our Spring Boot application. Next, let us quickly run the Spring Boot application just to make sure that there are no errors while connecting our Spring Boot application with the MySQL database. So go to the main endpoint class over here, and from here let us run the Spring Boot application. I notice here our Spring Boot application is up and running on embedded Tomcat server on port 8080. It means there are no errors in the console. You can see here. It means our Spring Boot application is successfully connected with MySQL database. And if you can see few details in the console logs over here. By default, Spring Boot uses Hikari data source. And here you can see database driver. Well, we don't have to configure the database driver class in our Spring Boot application. Spring Boot will automatically detect the database driver and it will configure accordingly. And again, we no need to configure the Hibernate dilate as well. Spring Boot will automatically detect the dilate and it will automatically configure the Hibernate dilate as per the database that we use in our project. In next lecture, we will create a JP entity. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create a user JP entity in our Spring Boot application. Well, before creating a user JP entity, let us quickly create a standard packaging structure for our Spring Boot application. So here, go to the base package over here, right click on it, new, and then choose package. Let us give package name as entity. Within entity package, we keep all the JP entities. Next, let us create one more package and let us give name as DTO. Within a DTO package, we keep all the DTO classes. Well, we use DTO classes to transfer the data between client and server. Next, let us create one more package and let us give name as repository. Well, within a repository package, we keep all the Spring Data JP repositories. Next, let us create a new package and let us give name as service. Within a service package, we keep all the service classes which holds the business logic. Next, let us create one more new package and let us call it as controller. Within a controller package, we keep all the Spring REST controllers. Next, let us create one more new package and let us call it as mapper. Well, within a mapper package, we keep all the mapper classes, and mapper classes basically holds the logic to map JP entity into DTO and vice versa. Next, let us create one more new package and let us call it as exception. So within an exception package, we keep all the custom exceptions. Now we have created a standard packaging structure for our Spring Boot application. Next, let us go ahead and create a JP entity. So go to the entity package over here, right click on it, new, and then choose Java class. And here let us give class name as user. And here let me expand this. Next, within a user class, let us go ahead and create the instance variables. So just type private and then long ID and then type private string first name, private string last name, private string email. To keep it simple, let us have these 4 fields in a user class. Next, let us go ahead and create a constructor and getter setter methods. Right click, generate constructor, and select all these fields, click on OK. Now we have created a parameterized constructor for this user class. Next, let us also create a default constructor. So right click, generate constructor, and don't select any fields over here, click on OK. Now we have created a default constructor or a no argument constructor for this user class. Next, let us also create a getter setter methods. So right click, generate getter setter, and select all these fields, click on OK. Now we have created a user class. Let us make this user class as a JP entity by using JP annotations. So here, in order to mark this class as a JP entity, let us annotate this class with @entity annotation. So make sure to import entity annotation from jakarta.persistence package. So this @entity annotation mark this class as a JP entity which mapped with a database table. Next, let us use @table annotation to configure the table name for this user JP entity. So here let us annotate this class with @table annotation from jakarta.persistence package, and this table annotation has name attribute, and here let us give the table name as users. Well, if you don't annotate this user class with @table annotation, then by default JP will give the table name as class name, and typically we give the table naming convention like this. That's why here we are using @table annotation to configure the table name for this user JP entity. Next, let us annotate this ID field with @id annotation to make this ID as a primary key for this JP entity, and make sure to import ID annotation from jakarta.persistence package. Next, we need to configure the primary key generation strategy for this primary key. So in order to do that, we can use add generated value annotation from jakarta.persistence package. And this generated value annotation has strategy attribute, and here let us configure the value generation type identity. So this identity generation type will automatically create the primary key for this ID field. It means it internally uses database feature, that is auto increment, to automatically create and increment the value for the ID field. Okay, perfect. Next, let us annotate this first name field with add column annotation to map a column name with this field, and make sure to import column annotation from jakarta.persistence package. This column annotation has name attribute, and let us give column name as first underscore name. And apart from giving the column name, you can also specify the constants. For example, here let us type null label false. It means this first name column does not allow the null values. If you give null label equal to true, then this column basically allows the null values. Okay, so let us give null label false. So by default the null label is false, so let us remove this. Okay, and one more important point here is, if you don't annotate a field with add column annotation, then JPA is smart enough to map a default column name with this field, and the naming convention for default column name is first underscore name, like this, because here you can see this field contains two words, first and name. So by default GPA will give the column naming convention like this, first underscore name, if there are two words in the field. Okay, and this column name makes sense for this field, so we can also omit using add column annotation over here. If you want to specify the constants, then you can annotate a field with add column annotation, but here we are just mapping a column name with a field, so you can also ignore this column name annotation from here. Okay, next, same for last name field. We no need to annotate last name field with add column annotation, because JPA will automatically give the column name, that is last underscore name, for this field, so last underscore name makes sense. Next, go to the email field. So we have to make this email as a unique. For that, let us annotate this email field with add column annotation, and let us configure the constants unique true. So we are going to keep unique email IDs in the email column, that's why we have to configure the constants unique equal to true over here. Okay, perfect. Now we have created user JP entity. Next, let us go ahead and run our Spring Boot application, and let us confirm that Hibernate will automatically generate a users table for this entity in a database or not. So here, let us stop the existing running server and go ahead and start the Spring Boot application again from here. Well, look at here the console logs. Hibernate has created create table statement to create a users table in a database. And if you look at this SQL statement here, to create the users table in a database. Okay, next let us confirm this users table in a MySQL workbench. So go to the MySQL workbench over here and refresh the schemas and expand this user underscore management database, expand user tables over here, and here you can see users table, select rows, and here you can see column names, ID, email, first name, last name. Well, notice the column name over here, first underscore name, last underscore name. So we haven't used at column annotation for first name and last name fields over here, but JPA has given the column name for these two fields like this. So this is the naming convention that JPA uses to give the column name, first underscore name, last underscore name. Okay, so this column name makes sense, that's why we haven't used add column annotation over here. Next, you can see here for email field we have annotated with add column annotation, and we have configured the column as a unique. So let us confirm this in the MySQL database. So go to MySQL workbench over here, go to users table, right click and click on this copy to clipboard and click on this create statement over here. So we have copied the create statement SQL to the clipboard and just paste it over here, and here you can see unique key. So email is configured with unique key constant over here. Alright, it means that we have successfully created user JP entity in our Spring Boot application. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create a Spring Data JP repository for this user JP entity. Well, Spring Data JP simplifies a lot of boilerplate code that is required to develop the repository layer or the DAO layer. So let us go ahead and use Spring Data JP in our Spring Boot project. So let us create a Spring Data JP repository for this user JP entity so that we can get the inbuilt CRUD operations for this user JP entity. So go to the repository package over here, right click on it, new, and then choose Java class, and here select the interface and let us give the interface name as user repository and hit enter. Now we have created a user repository interface. Next, let us extend this user repository interface from JPA repository interface from org springframework.data.jpa.repository package, and this JPA repository is a generic interface and we have to pass the parameters. The first parameter is the type of the entity, in our case user JPA entity. Second parameter is type of the primary key, in our case long is the type of the primary key. For example, if you go to the user JPA entity over here, we have given long as a type for this ID field. So this long type we have passed over here as a second parameter to this JPA repository. Okay. Well, by extending JPA repository, user repository automatically inherits methods to perform database operations without writing SQL or implementation logic. Spring Data JPA will automatically create the implementation at a runtime. So some of the advantages of using JPA repository, like no boilerplate code required. So we no need to write the SQL queries or implement the methods manually. Automatic implementation. Spring Data JPA automatically creates an implementation of this repository at a runtime. We don't have to create a class that implements this user repository. Spring Data JPA will automatically create the implementation for this user repository at a runtime. Built-in pagination and sorting. So by extending this user repository, it gives the additional capabilities like sorting and pagination as well. Well, one more important point here is we no need to annotate this user repository with add repository annotation over here, because Spring Data JPA already annotated JPA repository implementation class with add repository annotation. For example, here go to the JPA repository source code. This JPA repository is an interface. It has an implementation class that is simple JPA repository. And notice here this simple JPA repository is already annotated with add repository annotation. Hence, we don't have to again annotate this user repository with add repository annotation. So just remove it. So this is the important. Okay. And again, by default, all the methods in all the public methods in a JPA repository are by default transactional. We don't have to use add transactional annotation in a service class methods. Okay. For example, if you go to simple JPA repository class again, you can see here this class is annotated with add transactional annotation, and at a public method levels also you can see add transactional annotation. It means all the public methods in a simple JPA repository are by default transactional, so we don't have to use add transactional annotation in a service class. Alright, so just remember these two important points. We no need to annotate a user repository with add repository annotation because Spring Data JPA already annotated this simple JPA repository with add repository annotation. And by default, all the public methods in a simple JPA repository are transactional, so we don't have to use add transactional annotation in a service class. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll create a DTO class and a mapper class to map entity into DTO and vice versa. So we are going to use a Java record feature to create the DTO class. Well, Java record is a special class in Java that holds a immutable data. And most of the time we create a DTO class to hold the immutable data and transfer that data between client and server, right? And this Java record is a good candidate for DTO. So in this project we are going to use Java record to create the DTO class. So here go to the DTO package in our application, right click on the DTO package, new, and choose Java class, and here select record over here. Next, let us give the record name as user DTO and hit enter. Next, let us go ahead and define the fields within this class. So this is the record, so we have to pass the fields as a parameter to this user DTO. So here long ID and then string first name, string last name, string email. And again, the main purpose of Java record is that it significantly reduces the boilerplate code such as creating constructor, getter methods, toString, hash code equal methods. So here we no need to create the constructor, getters, equal hash code and toString methods over here. Java compiler will automatically create a constructor for this user DTO record. Java compiler will also create a getter methods, hash code equals and toString methods as well. So in this way, the Java record basically, reduce the significant boilerplate code. Next, let us create a mapper class to map JP entity into DTO and vice versa. So here in our project, we have user JP entity and user DTO. So user DTO we use in a REST APIs to transfer the data between client and server, and we use user JP entity to map with the database table. That's why we need a conversion between these two classes. So in order to keep the conversion logic, we will create a mapper. So mapper basically we use to map JP entity into DTO and vice versa. Okay, so go to the mapper package over here, right click on it, new, and then choose Java class. So let us give a class name as user mapper. Next, let us annotate this class with add component annotation from org.springframework.stereotype package. So this add component annotation mark this class as a Spring Bean, and Spring IOC container will automatically create the Spring Bean for this class because we have annotated this class with add component annotation. Next, within this class, let us create a method public, and then let us give return type as user DTO, method name to DTO, and then pass parameter as a user entity class. So here we are using toDTO method to convert user entity into user DTO. Alright. Next, within this method, let us have a return statement and then new user DTO, and let us pass values to the constructor user dot get ID. Next, user dot get first name, user dot get last name, user dot get email. Perfect. Now we have written a code to convert user entity into user DTO. Similarly, let us create one more method that will convert user DTO to user entity. So here just type public and then give user JP entity as a return type. Next, let us give method name as toEntity, and let us pass parameter to this method as user DTO. Perfect. Within this method, let us have a return statement and then new user JP entity, and let us pass values to the constructor. So here user DTO dot ID, user DTO dot first name, user DTO dot last name, user DTO dot email. So these are the basically getter methods from user DTO. So user DTO is a record, and by default compiler will give the getter name as field name. You can see here ID, first name, last name, email. Okay, now we have created toEntity method to map user DTO to user JP entity. Okay, perfect. Now we have created a user mapper class to map user entity into DTO and DTO into user JP entity. And again, notice here we have annotated this user mapper with add component annotation. So Spring IOC container will automatically create a Spring Bean for this class. Next, we can use add attword annotation to inject this user mapper Spring Bean in our project. Okay, perfect. So in this lecture, we have created user DTO as well as user mapper. Alright, great. In next lecture, we will create a REST APIs. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build create user REST API, and we will test create user REST API using Postman client. So here, go to our project. So I want to first implement the service layer and then implement the controller layer, because the controller layer is depends on service layer, right? So go to the service package over here, right click on it, new, and then choose Java class, select interface, and here let us give interface name as user service. So within a user service interface, let us define a method. So here let us give return type of method as user DTO, and let us give method name as create user, and just pass user DTO as a parameter to this method. Alright, now we have defined create user method in a user service interface. Next, let us create a user service IMPL class that implements this user service interface and its create user method. So go to the service package over here. Within this package, let's create one more new package and let us call it as IMPL. So within the IMPL package, we keep all the implementation classes. So right click on IMPL package, new, and then choose Java class. Let us give a class name as user service IMPL. Next, this class implements user service interface. Next, mouse over on this user service class and just click on this implement methods. Select the method that you want to implement and just click on OK. Perfect. Next, let us make this user service class as a Spring Bean by annotating this class with add service annotation. So just annotate this class with add service annotation from org spring framework.stereotype annotation. So this add service annotation mark this user service IMPL class as a service component so that we can keep the business logic in the service class. And this add service annotation tells Spring Container to automatically create a Spring Bean for this user service IMPL class so that we can inject this Spring Bean by using add attribute annotation. Okay, perfect. Next, within this user service IMPL class, let us inject user repository. So here, just create a field private user repository. Well, we can also make this user repository as a final field over here. So once we make this user repository field as a final, we have to initialize this user repository using constructor. And once we assign it, we cannot change it later because this user field is final. Okay. Next, let us go ahead and use constructor based dependency injection to inject this user repository. So here just type public and then user service IMPL and then pass user repository and then this dot user repository equal to user repository. Now we have used constructor based dependency injection to inject this user repository. Well, here we can also annotate this constructor with add attribute annotation like this. But Spring 4.3 onwards, if the class has a single constructor, then we can omit using add attribute annotation. Alright, but if the class has a multiple constructors, then we have to annotate one of the constructor with add attribute annotation so that Spring Container can use that constructor to inject the dependency. Well, in our case, the user service IMPL class has a single constructor, so we can omit the add attribute annotation from here because Spring IOC Container will automatically inject this dependency using this constructor. Okay, perfect. Next, let us implement this create user method over here. So this create user method takes user DTO as a parameter. So let us convert this user DTO into user JP entity first. So again, notice here we have a user mapper and we have made this user mapper as a Spring Bean by using add component annotation. So let us inject this user mapper in a user service IMPL and let us call its methods. So go to user service IMPL over here and here let us use constructor based dependency injection to inject the user mapper. So just type private and then final user mapper, and here we have already a constructor. So let us pass one more parameter to this constructor, user mapper, and here this dot user mapper equal to user mapper. Now we have injected user mapper using constructor based dependency injection. Next, go to the create user method and here let us call user mapper. It has two entity method and then pass user DTO. Next, this two entity method returns user JP entity. So here let us have a user JP entity object. Now we have a user JP entity object. Next, let us save this user JP entity object into database by using user repository.save method. So here just call user repository. It has a save method and then pass user JP entity object. So this save method basically save the user JP entity object into a database table, and this save method returns a saved user JP entity object. So for that, here let us have a user and let us give the variable name saved user. Okay, so this save method basically return the saved user JP entity object, and that we are storing in this saved user object. Next, let us convert this saved user object into user DTO. So here go to the return statement, just remove this null and then call user mapper. It has toDTO method and then pass this saved user. So here we are using toDTO method to convert this user JP entity into user DTO. Alright, now we have implemented create user method to convert user DTO into user entity and save that user entity into database, and again convert that saved user entity into user DTO and just return that user DTO. Okay, next let us create a REST API that will internally call this create user method of this user service IMPL class. So here go to the controller package, right click on it, new, and then choose Java class. Let us give class name as user controller. Next, let us make this user controller as a Spring REST controller by annotating it with @REST controller annotation. Next, let us use @request mapping annotation to define the base URL for all the REST endpoints within this controller class. So here let us annotate this class with @request mapping annotation, and here let us specify the base URL /API/users. Alright, now we have used @request mapping annotation to define the base URL for all the REST endpoints within this user controller class. Next, within a user controller class, let us inject user service dependency, and again we are going to use the constructor based dependency injection to inject the dependency. So here just create the field first, private final user service. Well, notice here we are injecting the dependency using user service interface. So this is not a class, that is user service IMPL class. We are using user service interface to inject the dependency. Well, Spring team recommend to use interfaces to inject the dependencies, because injecting interface as a dependency gives a lot of advantages, like you can swap the implementations of interface, and also you can mock the implementation whenever you write the unit testing. Now we have made this user service field as a final, so we have to initialize this user service in a constructor. So let us use constructor based dependency injection to inject this user service. So just right click, generate constructor, select the field, click on OK. And again we don't have to use @avoid annotation to inject the dependency, because this class has a single constructor. So Spring IOC container will automatically inject the dependency by using this single constructor. If you have multiple constructors within this class, then you have to annotate one of the constructor with @avoid annotation, so that Spring IOC container will inject the dependency by using that constructor. But in our case we have only one constructor, so we can omit using @avoid annotation over here. Okay, perfect. Next, let us go ahead and build create user REST API. So here let me write the comment, build create user REST API. Well, creating a REST APIs with Spring Boot is very simple. We just have to create a method and we can make that method as a REST API by using Spring annotations. Alright, so here just type public. Let us give return type as response entity. Well, we are going to use response entity class from org springframework.html package to create the complete response for the REST API. So this response entity is a generic. So let us pass user DTO as a type to this generic class, and let us give a method name as create user. Next, let us pass user DTO as a parameter to this method. Within a create user method, let us call user service. It has create user method and then pass user DTO object. Perfect. Next, this create user method returns a saved user object in a user DTO. So here let us introduce a local variable of type user DTO and let us call it as saved user. Okay. Next, let us have a return statement, and then here you can see create user has a return type response entity. So here just type response entity. So response entity has a OK method. So this OK is a static method and it returns a HTTP status 200 OK. So here just call OK method, and look at here, there are two overloaded OK methods, and we have to use the OK method that takes content in the body. So just call this OK method that takes saved user object in the body. Now we have created a create user method. Next, let us make this method as a REST API by using Spring annotations. And notice here, this create user method basically create a new user object, that is save the new user object into database. That's why we can make this method as a post REST API. So here let us annotate this method with add post mapping annotation. So we use add post mapping annotation to map HTTP post request to this method. Next, the post request basically contains a JSON object, and we need to bind that JSON object into this Java object. So in order to do that, we can use add request body annotation. That's it. We have successfully built create user REST API. Next, let us go ahead and use Postman client to test this create user REST API. So here, stop the server and start the server again. And notice here our Spring Boot application is up and running and an embedded Tomcat server on port 8080. Next, let us open the Postman client over here, and here let us create a new request, and here let us choose HTTP post method. Let us enter the URL HTTP localhost 8080/API/users. Well, if you go to the project again, and if you go to the user controller, so this is the base URL for this create user REST API, right? So this is the URL we are specifying in the Postman client over here. Okay, next, this is the post request, so we have to pass a JSON in the body. So go to body, go to raw, choose content type JSON over here, and within a body let us create a JSON. So here just type ID. So we don't have to give the ID because Hibernate will automatically create the primary key. So here just give first name, let us say Ramesh, last name, so let us say Padtari. You can give any values for these fields. Next, email ramesh@gmail.com. Perfect. Now we have a JSON object in the body. Next, go ahead and click on send button to send the request, and there we go. You can see the response over here, ID1, first name, last name, email. It means the create user REST API is working as expected. Next, let us confirm this user is saved into database or not. So just go to the MySQL workbench over here and go to the users table, right click, select rows, and you can see here Ramesh user is saved into users table. It means the create user REST API is working as expected. Next, let us go back to the Postman client and let us insert one more user, first name Ram, last name Jadhav, ram@gmail.com. Click on send button and look at here the response, ID2, first name, last name, email. So let us confirm this. Go to the MySQL workbench, select rows from users table, and you can see here Ram user is also inserted into users table. Well, notice here we did a small mistake over here. So this create user REST API is returning HTTP status 200 OK, but ideally the create REST API should return the HTTP status 201 created. Okay, so this create user REST API basically create a new user and save in the database. That's why this REST API have to return the HTTP status 201 created. So let us change this REST API and return the status 201 created. So let us head over to the IntelliJ IDEA and here go to the create user REST API, and here you can see the REST API returns the HTTP status 200 OK. Now let us change it. So here response entity dot status and then HTTP status. So you can see here HTTP status is a enum, so just import it. It has a created, so just call this created, and then next pass this saved user object in the body. For that, just call body method over here and then pass saved user. That's it. Now this create user HTTP returns the HTTP status 201 created. If you go inside this created status, you can see status 201. Okay. Next, let us stop and run the Spring Boot application and let us quickly test this. Well, our Spring Boot application is up and running. Next, let us go to the Postman client over here, and here let us give first name Pramod, last name Pawar, and then email pawar@gmail.com. Click on send button, and there we go. You can see the status over here, 201 created. This is correct status. Okay. So whenever you create REST API, then make sure that the create REST API should return a 201 status, because the create REST API basically create a new resource at a server side. Alright, now we have successfully built create user REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build get user by ID REST API, and we are going to test this REST API using Postman client. So let us head over to our project in IntelliJ IDEA over here. So first we're going to implement the service layer, and then we'll implement the controller layer, because the controller layer depends on service layer, right? So go to the service package over here. Within that we have a user service interface. Within a user service interface, let us define a get user by ID method. So here let us give return type of the method as user DTO, and let us give method name as get user by ID, and let us pass long ID as a parameter to the method. Now we have declared get user by ID method in a user service. Next, let us implement this method in a user service IMPL class. So just click on this icon to navigate to the user service IMPL class, and here just mouse over on this class, click on implement methods, select the method that you want to implement, click on OK. Now we got get user by ID method over here. Next, let us implement this method. So before implementing this method, let us create one custom exception, that is resource not found exception. Well, if user with a given ID is not exist in database, then we will throw resource not found exception with a custom error message. For that we need a custom exception, right? Alright, so let us create a custom exception. So go to the exception package, right click on it, new, and then choose Java class. Let us give class name as resource not found exception. Next, this class extends a runtime exception. Next, within this class, let us create a constructor public resource not found exception, and then pass string message as a parameter. Next, within this constructor, let us call super keyword over here to just pass this message field to the super class constructor. So here we use super to call the super class constructor and pass this message. Now we have created resource not found exception. Next, let us go back to user service IMPL class over here. Go to get user by ID method. Within this get user by ID method, let us call user repository. It has find by ID method, and notice here find by ID method returns optional of type user. So just call find by ID method over here to get the user by ID and just pass the ID. Next, find by ID method returns optional. So here we can call or else throw method over here. So we use or else throw method to throw the exception if a user with a given ID is not existing in database. And notice here or else throw method takes supplier as a functional interface, and we have to use the lambda expression to implement this supplier functional interface. So let us call or else throw method over here and then pass the lambda expression. So this is the lambda syntax, followed by just throw resource not found exception over here, and then pass the custom exception message user not found with ID, and then pass ID over here. Alright, next let me align this properly. Alright, and here let us take the result of this method into local variable of type user. Let us call it as user. Now we have written a code to get the user by ID, and if a user with a given ID is not exist, then we throw resource not found exception like this. Okay, perfect. So now we got the user GP entity. Next, let us convert this user JP entity object into user DTO. So here, go to the return statement, just remove this null and then call user mapper. It has two DTO method and then pass user object. Perfect. Now we have created get user by ID method to retrieve the user by ID. Next, let us build the REST API that will internally call this method. Go to the user controller over here, and here let us build get user REST API. So just type public. Let us give a return type as response entity. Response entity is a generic class. So let us pass user DTO as a type, and let us give method name as get user by ID, and then pass ID as a parameter to this method. And within this method, let us call user service. It has get user by ID method and then pass ID. So this get user by ID returns user DTO. So let us introduce a local variable of type user DTO here. Next, let us have a return statement, and look at here, this get user by ID method returns response entity. So here just call response entity, and then it has a OK method and then pass user DTO in the body. Now we have created a get user by ID method that returns a user by ID. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @getMapping annotation. Well, we use @getMapping annotation to handle HTTP GET request. Next, let us pass ID to this getMapping annotation. So here within a double quote slash within a curly braces, just pass ID. So this ID is basically a template variable, and we have to bind the value of this template variable to this method argument. So in order to do that, we can use add path variable annotation over here. Well, notice here the method argument field name ID and the template URI variable name ID. So both are same, so we don't have to manually specify the name within a path variable annotation. But if the method argument name is different, for example, let us say user ID, then here we have to specify the URI template variable name over here. For example, ID like this. Then only add path variable annotation will map the value of this URI template variable to this method argument. Okay, so here let me undo it. So just keep both the variable names same so that there will not be any confusion. Now we have built get user by ID REST API. Next, let us run the Spring Boot application and let us test this REST API using Postman client. So here let me stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let us head over to the Postman client over here, and here let's create a new request, and let us keep the HTTP GET method over here, and here let us enter the URL localhost 8080/API/users. Next, let us say we want to fetch the user with ID 1, then we can specify the ID in the URL. So if you go to MySQL Workbench and go to the users table over here, here you can see Ramesh is the user who has ID 1. So if you want to fetch the user Ramesh, you have to specify the ID 1 in the URL. So go back to the Postman client, and here let's specify the ID 1 over here. Next, click on send button, and there we go. In a response, you can see the user details who has the ID 1. So this is how we can fetch the user object by ID by using this REST API. Next, let us say you want to get the user with ID 2, then you can just specify the user ID 2 in the URL, click on send button, and there we go. You can see the user with ID 2 details over here. Next, let us test the different scenario, like if user with a given ID is not existing in database, then the REST API have to throw the resource not found exception and send the default error response back to the client, right? So here let us say we pass the user with a ID 3. So user with ID 3 is not existing in database. So let us send the request and let us see how the REST API will give the response. And look at here the response, status 500 error, internal server error. So ideally the REST API should return the status 404, but you can see the status 500 over here. So let us quickly change the REST API so that the REST API can return the status 404 whenever the resource, that is user with a given ID, is not existing in database. So let us go to the project, and here let us stop the server, go to resource not found exception, and here let us annotate this exception with at response status annotation, and just specify the HTTP status not found. Okay, next let us run the Spring Boot application again. Well, our Spring Boot application is up and running. Next let us go to the Postman client. Now let us call this REST API again, and notice here we have specified the user ID 3 which is not existing database. Click on send button, and now you can see the response over here, status 404, error not found. Now the response looks good, isn't it? So this is how we can create the custom exception, and we can annotate with at response status annotation with the status code. Now we have tested both positive and negative use cases. It means the get user by ID REST API is working as expected. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build get all users REST API, and we will test this REST API using Postman client. So let us go to our project in IntelliJ IDEA over here, and here let us first stop the server over here. Next, let us implement the service layer first, and then we'll implement the controller layer, because the controller layer is depends on service layer, isn't it? So go to the user service interface over here, and within the user service interface let us declare a method. So here let us give return type of the method as a list of type user DTO. Let us give method name as get all users. Next let us go ahead and implement this get all users method in user service IMPL class. So just click on this icon, it will head over to user service IMPL class. Just mouse over in this class, click on implement methods, select the method that you want to implement, click on OK. Now go to the get all users method over here, and here let us implement this method. Within this method let us call user repository. It has find all method. So notice here there are overloaded find all methods, and we have to choose the appropriate one. So in our case we are going to choose the find all method that doesn't take any parameter. And notice here find all method returns a list of type user. So just call this find all method over here. As this find all method returns a list of user, so just take the result into local variable of type list as a generic. So just pass user as a type and then call it as users. Perfect. Next we need to convert this list of user JP entities into list of user DTOs, because this get all users method returns list of user DTOs, right? So here in order to convert this we can use the stream. So list has a stream, so here just call users is a list, it has a stream method, so just call stream method. Stream has a map method, so let us call this map method to map user JP entity into user DTO. Next, in order to map we can use user mapper class, it has to DTO method. That's it. So here we are using method reference to call to DTO method over here, and this internally will basically convert each user entity object into user DTO. And finally we need to collect the result. For that just call toList method over here, and notice here toList method returns a list of user DTO. That's it. Next let us remove this return statement, and here just put the return statement. Perfect. Now we have implemented get all users method that returns a list of user DTOs. Next let us build the REST API that will internally call this method. So go to the user controller, and here let me first write the comment build get all users REST API. So just type public, let us give response entity as a type. Response entity is generic, so let us pass type list. Again list is generic, let us pass a type user DTO. Next let us give method name as get all users. Within this method let us call user service, it has get all users method. Get all users method returns a list of user DTOs. Let us call it as users. Next let us have a return statement over here, and then response entity, it has a OK method, and just pass users in the body of the OK method. Perfect. Next, let us make this method as a REST API by annotating this method with @getMapping annotation. This getMapping annotation basically handles HTTP GET request. Perfect. Now we have built getAllUsers REST API. Next, let us run the Spring Boot application and let us test this REST API using Postman client. So here, let me start the Spring Boot application. Well, notice here, the Spring Boot application is running on embedded Tomcat server on port 8080. Next, let us go to the Postman client over here, and here let us create a new request and choose HTTP GET method and just enter the URL localhost 8080/API/users. Alright. Next, if you go to the MySQL workbench over here, within a users table, we have 2 users, right? So let us go back to Postman client and just click on send button, and in a response you can see a list of users. So there are 2 users. So as you can see in a users table in a database, 2 users, and in a response you can see there are 2 users. It means the get all users REST API is working as expected. Okay, great. In next lecture we will build update user REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to build update user REST API and we will test this REST API using Postman client. So let us head over to our project in IntelliJ IDEA over here. First we're going to implement the service layer and then we'll implement the controller layer, because the controller layer depends on service layer. So go to user service interface over here, and here let us declare a method. So let us give the return type of the method as user DTO, and let us give method name as update user, and let us pass parameters to the method long ID, this is the user ID, and then user DTO. So this user DTO basically holds the updated user details. Now we have created update user method in user service interface. Next, let us provide the implementation for this method in a user service IMPL class. So go to user service IMPL class, just mouse over on this class and click on implement methods and click on OK. Next, go to update user method over here and let us provide the implementation. So here within this method, let us first get the user object by ID from the database, and if the user with a given ID is not exist in database, then we have to throw the resource not found exception, isn't it? So we have already written that logic in get user by ID method over here, you can see here, and you can see here we are calling user repository dot find by ID method. If the user with a given ID is not exist in database, then we throw the resource not found exception over here by using this or else throw method. If the user with a given ID is exist in database, then this method returns a user JP entity object over here. Okay, so just copy this piece of code and go to the update user method over here and just paste it. Okay, now we got the user JP entity object from a database. Next, let us update this user JP entity object and let us save into database again. Okay, so here user JP entity object, it has set first name method, so we can get the updated details from this user DTO, right? So here user DTO dot first name, next user entity object dot set last name, and then user DTO dot last name, user dot set email, user DTO dot email. Okay, so basically here we are just setting the data from user DTO into user JP entity. Now we have updated first name, last name, email into user JP entity object. Next, let us save this user JP entity into database table. So for that, let us call user repository. It has a save method and then pass user JP entity object. Well, this save method basically performs 2 operations. First is like if the user entity object don't have ID, then it will perform the insert operation. If the user entity object has ID, then it will perform the update operation. Okay, so in this case the user entity object has ID, so it will perform the update operation. Okay, and again the save method returns the updated user object. So here let us take that object into local variable of type user, and let us give variable name as updated user. Perfect. Next, let us convert this updated user JP entity object into user DTO, because this update user returns user DTO, right? So here just remove this null and just call user mapper. It has toDTO method and then pass updated user object. Perfect. Now we have implemented update user method to update the user details into a database. Next, let us build the update user REST API that will internally call this update user method. So go to update controller over here. Within that, let us build the update user REST API. So here let me write the comment build update user REST API. So here let us create a method public. Let us give return type as response entity. Response entity class is a generic, so let us pass type as a user DTO. Next, let us give method name as update user, and let us pass parameters to the method over here, long ID and then user DTO. So this user DTO holds the updated user details. Next, within this method, let us call user service. It has update user method and then pass ID and then user DTO. Next, this update user method returns updated user object. So here let us introduce a local variable of type user DTO, and let us give the variable name as updated user. Perfect. Next, let us have a return statement over here and then call response entity. It has a OK method and then pass updated user. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @putMapping annotation. So this putMapping annotation will basically map the incoming HTTP put request to this method. Next, let us pass the ID, that is URI template variable. Next, in order to bind the value of this URI template variable to this method argument, we have to use @path variable annotation over here. Next, in order to bind the JSON from the request into this J object, we have to use @requestBody annotation. Okay, perfect. Next, let me maximize this. Now we have built update user REST API. Next, let us rerun our Spring Boot application and let us test this REST API. So from here, I am going to stop and rerun the Spring Boot application. You'll notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let us head over to the Postman client over here, and here let's create a new request, and here let us choose HTTP put method over here, and let us enter the URL localhost 8080/API/users, and let us pass the user ID that we want to update. For example, let us say we want to update the user with ID 1, then pass user ID 1 in the URL like this. Next, go to the body, and here go to the raw, choose content type JSON. So here in a request we need to pass the JSON that contains the updated user details. So here let us create a JSON. So let me maximize this. Let us say first name. So if you go to MySQL Workbench over here, and here go to the users table, and you can see user with ID 1. So first name is Ramesh, last name Padatare, and this is the email. Now let us say we want to update the first name, last name, email, these three fields. Then that information we can put in this JSON over here. So first name, let us update from Ramesh to Umesh. Last name, let us change from Padatare to Pawar. And then email, let us change from ramesh@gmail.com to umesh@gmail.com. That's it. Next, let us send the request and let us see how this REST API works. So go ahead and click on send button, and there we go. In a response, you can see the user with ID 1. The first name is updated, last name is updated, email also updated. If you want to verify this, go to the MySQL Workbench and just select rows from users table, and here you can see the user with ID 1. the first name is changed from Ramesh to Umesh, last name and email as well. So this is how we can use update user HTTP to update the particular user. Next, let us test the other use case, like if user with a given ID is not existing in database, then this update user HTTP have to return the error response with the status 404, right? So here let us pass the user ID 3. So user with ID 3 is not existing in database, isn't it? So click on send button and there we go. You can see the response, the error response, status 404, error not found. It means the update user HTTP is working as expected. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build delete user REST API and we will test this REST API using Postman client. So let us head over to our project in IntelliJ IDEA over here, and here let us stop the server first. Well, first we're going to implement the service layer and then we'll implement the controller layer, because the controller layer is depends on service layer. So go to user service interface and here let us declare a method. Let us give a return type of the method as a void and let us give method name as delete user and let us pass a parameter that is user ID, long ID. Perfect. Next, let us implement this method in a user service IMPL class. So go to user service IMPL class, just mouse over on this class, click on implement methods, click on OK and go to delete user method over here and let us provide the implementation. So within this delete user method, let us write a logic to check if a user with a given ID is existing in database or not. If a user with a given ID is not existing in database, then we'll throw the resource not found exception. Well, if you go to update user method over here, so here we have already written that logic. So let us copy this line of code and go to delete user over here and here just paste it. Okay. So here we are just checking like if a user with a given ID is existing in database or not. If a user with a given ID is not existing in database, then we simply throw the resource not found exception with a custom error message. Next, if a user with a given ID is existing in database, then this find by ID method returns a user object. Next, we can delete this user object from the database. So for that, just call user repository. It has a delete method and then pass user. So you can also use one more delete method, that is user repository dot delete by ID method. So both will do the same. So you can use either delete method or delete by ID method. So let us say we use delete method over here. Okay. Now we have implemented delete user method to delete a particular user. Next, let us build delete user HTTP that will internally call this delete user method of user service IMPL class. So go to the user controller over here and go at the end and here let me write the comment build delete user REST API. So just type public and then response entity. Next, let us pass string as a type. So this delete user HTTP basically returns the success message. For that, we can pass string as a type to this response entity over here. And let us give the method name as delete user. And let us pass parameter to this method, that is long ID. Next, within this method, let us have a return statement and then response entity and then call OK method. And then here just pass the success message user deleted successfully. Okay, perfect. Next, let us annotate this method with @delete mapping annotation and then pass the ID / within a curly braces ID. Next, in order to bind the value of this URI template variable to method argument, we use @path variable annotation. Well, notice here within this delete user method, we haven't called the user service delete user method. So here just call user service, it has delete user method and then pass ID. Now this delete user method will delete the user object by this ID. Okay, perfect. And one more important to note here is that some of the developers don't return any response for this delete REST API, but here we are simply returning the success message to the client. Now we have built the delete user REST API. Next, let us run the Spring Boot application and let us test this REST API. So from here, I am going to run the Spring Boot application. Our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let us head over to the Postman client over here, and here let us create a new request, and here let us choose HTTP delete method and just enter the URL localhost 800/API/users, and here let's specify the user ID that we want to delete. Let us say we want to delete a user with ID 1, so let us specify ID 1 over here. Next, click on send button, and there we go. You can see the response, user deleted successfully. And if you want to confirm this, go to MySQL Workbench and here select rows from users table, and you can see here the user with ID 1 is successfully deleted. Next, go to the Postman client, and next let us pass user ID 2 over here and just click on send button, and notice here user deleted successfully, and just confirm from database, and there we go. You can see user with ID 2 is successfully deleted. Next, let us verify the other use case, like if a user with a given ID is not existing in database, then the REST API have to return the error response with the status 404, right? So here just pass the user ID 3, click on send button, and notice here the error response status 404 not found. It means the delete REST API is working as expected. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this video, we are going to build a REST API for a simple banking application using Java 25, Spring Boot 4, Spring Data JPA, and a MySQL database. Well, we're not creating a huge production level banking system. Instead, we'll start with a clean, simple version, something perfect for learning how real-world applications work. We will build the RESTful web services for banking operations like creating accounts, fetching account details, delete accounts, deposit the amount, withdraw the amount, and more. You will see how to use Java record as DTO class to transfer the data between client and server. You will also learn how to handle exceptions in the Spring Boot banking application. We'll use Spring Data JPA to handle all the database interactions, so we can focus on writing clean business logic without worrying about SQL queries. And for our database, we'll connect it to MySQL, one of the most popular databases used in modern web applications. Alright, let's get started. We'll use Spring Initializer to create the project and then import it into IntelliJ IDEA. Let's open the browser. I'm using Chrome. In a new tab, type start.spring.io. This will open Spring Initializer. Spring Initializer is a web tool that helps us quickly create a new Spring Boot application. Next, let's fill in the Spring Boot project information. Here we have different types of projects like Gradle Groovy, Gradle Kotlin, and Maven. Since we want to use Maven, keep Maven selected as it is. Next, under language, keep Java selected. Now select the Spring Boot version. By default, Spring Initializer will select the latest stable version of Spring Boot. We want to use Spring Boot 4, so here select 4.0.0. At the time of recording, you might see a different version, but make sure to use Spring Boot 4 or above. Next, let's fill in the project metadata. For group, type net.javaguides. You can use any group name you prefer. For artifact, enter banking app. The project name will automatically match the artifact name. For description, type demo project for Spring Boot banking app. For package name, type net.javaguides.banking. Keep packaging as jar and select Java version 25. Since we are using Spring Boot 4, we can use the latest version of Java. As of now, Java 25 is the latest long-term support release. Now let's add the dependencies. In the dependency search box, type web. Spring Web helps us build web applications and RESTful services. It automatically includes an embedded Tomcat server, so you don't need to add Tomcat separately. Next, add Spring Data JPA. This dependency helps us interact with databases using JPA and Hibernate and removes a lot of boilerplate code needed for the data access layer. Then add the MySQL driver to connect our Spring Boot application to a MySQL database. For now, we'll keep just these dependencies. Next, click the Generate button. This will download the Spring Boot project as a zip file to your computer. Locate the zip file, right-click and extract it. Perfect. Now let's open IntelliJ IDEA and import the project. Open IntelliJ IDEA and on the welcome screen, click the Open button. Navigate to the location where your Spring Boot project was extracted. In my case, it's in the Downloads folder. Select the project and click OK. IntelliJ will open the project and download all the necessary dependencies automatically. Once it's loaded, open the pom.xml file to review the dependencies. You'll see Spring Boot Starter Web MVC, Spring Boot Starter Data JPA and MySQL driver. Well, we are going to use the Lombok library to reduce the boilerplate code such as getter and setter methods, constructors, toString method, equals and hash code methods and more. Let's open a new tab in the browser, then enter Lombok Maven dependency and hit enter. Click on the first link. Select the latest version. Click on the dependency and it will be copied to the clipboard. Go to the project. Open pom.xml file. Go to the dependency section. At the end, paste the dependency. Perfect. Click on the Sync Maven changes. Next, enable annotation processing in IntelliJ IDEA. If annotation processing is disabled in IntelliJ IDEA, Lombok won't work. Go to the Preferences. In the search bar, just type annotation. Under the compiler, click Annotation Processors. Tick mark this. Enable annotation processing. Click on OK. Next, let's install the Lombok plugin. Go to the Plugins section. Look for Lombok. Click on the Install button. There we go. The Lombok plugin is successfully installed. Well, Lombok is now an optional dependency in Spring Boot 3, meaning it is not automatically included. Hence, we have added Lombok manually. Now let's exclude the Lombok dependency from the Spring Boot plugin. Go to the plugin. Add the configuration tag. Add the excludes tag. Add an exclude tag. Copy the Lombok dependency details including the group ID, artifact ID and version. Paste here. Finally, click the Load Maven Changes icon. Perfect. Now our project setup is done. In the next lecture, we'll configure the MySQL database details in our banking application to connect to the MySQL database. Alright, great. I will see you in the next lecture. Next step is we will configure the MySQL database in our Spring Boot application so that our Spring Boot application can able to connect to the MySQL database. So go to the SRC folder and go to main folder, go to resources, go to application.properties file. So here inside application.properties file we are going to configure the MySQL database details. Okay. So before configuring MySQL database details in the application.properties file, let us first create the database in a MySQL server. So in our case, we are going to use MySQL Workbench to interact with the MySQL server. So here, let me quickly create the new database. So here, let us write the SQL statement, create database followed by the database name. So let us give database name as banking app. Next, let us select this, click on execute, and next refresh schemas. And here you can see banking app database is successfully created. Next, we can make this schema or database as a default so that we can only focus on this database. Next, let's go back to IntelliJ IDEA over here and go to application.properties file, and here let us configure the MySQL database properties. So just type spring.datasource.url equal to jdbc and then MySQL and then localhost and then port 3306, and then followed by the database name banking_app. So this is the JDBC URL that our Spring Boot application will use to connect with the MySQL database. And here we are using localhost because our MySQL server is running in a local machine. That's why the host name is localhost, and this is the default port for a MySQL server, and this is the database name. Next, let us configure the MySQL database username and password. So here spring.dataSource.username. In my case, the username is root. Next, let us configure the password. Spring.dataSource.password. Well, in my case, this is the password, but make sure that whatever the database username and password that you have given while installing the MySQL database, that you have to provide over here. Next, let us tell Hibernate to automatically create the tables using JP entities. For that, let's configure the property spring.jp.hibernate.dtl-auto equal to update. Alright, so this property basically ensures that the Hibernate should create the database tables automatically based on the JP entities that we will create in the Spring Boot application. Next, we no need to add Hibernate delete for a MySQL database because Spring Boot 3 internally uses Hibernate 6, and Hibernate 6 will automatically configure the Hibernate delete for a database based on the JDBC driver dependency that we add in the Spring Boot application. In our case, we have added MySQL JDBC driver, so Hibernate 6 will automatically configure the Hibernate delete for a MySQL database. Okay, perfect. Next, let us run the Spring Boot application so that we can make sure that our Spring Boot application can able to connect to this banking app database. So go to our main entry point class over here, and from here, and notice here there are no errors in a console logs. It means our Spring Boot application is successfully connected with the MySQL database. Next step is we will create a JPA entity. So before that, let's quickly create the packaging structure for our Spring Boot application. So right click on the base package, new, and then choose package. Let's give name as entity. Next, let's create one more package. Right click, new, and then choose package. Let's give package name as controller. Next, right click, new, and then choose package. Let's give package name as service. Next, let's create one more package. Let's call it as repository. Perfect. Next, go to entity package, right click on it, new, and then choose Java class. Let's give class name as account. Next, let us define the fields for this account class. Private long ID, and then private string. Let's give name as account holder name, and then private double balance. Well, to keep it simple, let us have these three fields for our account class. Next, let us make this class as a JP entity by using JP annotations. So let us annotate this class with add entity annotation to make this class as a JP entity. Next, let us configure the table details by using add table annotation. So here let's use name attribute to give a name to the table. Let us say accounts. Perfect. Next, let us use Lombok annotations to automatically create a getter setter methods for this account class. So here let us use add getter Lombok annotation, and next let us use add setter Lombok annotation. Next, let us also use the constructor related annotations. For example, no argument constructor and all argument constructor annotation. Next, let us use few more JP annotations over here. So go to the ID field and let us annotate this ID field with add ID annotation to make this ID field as a primary key in a database. Next, let us use add generated value annotation to configure primary key generation strategy. So this annotation has a strategy attribute, and let us give the generation type as an identity. So this will basically automatically increment the primary key. Next, here let us use add column annotation to configure the column name for this field. So here let us use name attribute and let's give column name as account underscore holder underscore name. Okay, perfect. Now we have created account JP entity. Next, let us run this Spring Boot application and let us see whether the Hibernate will automatically create a table for this account JP entity or not. Okay, so go to main entry point class over here. From here, let us run the Spring Boot application. And notice here there are no errors in the console. Let's go to database and go to banking app database, refresh the schemas, go to tables, and there we go. Accounts table is created and the columns like ID, account holder name and balance. It means the table is successfully created and the columns are also looks good. Okay, so let's go back to IntelliJ IDEA. Next step is let us create Spring Data JP repository for this account entity. Okay, so go to a repository package, right click on it, new, and then choose Java class, choose interface, and here let us give the interface name as account repository. Perfect. Next, let us extend this interface from JPA repository interface. And notice here JPA repository interface is a generic, so we have to pass two parameters. First is the entity name, in our case account. Second is the type of the primary key, in our case long. Okay, so if you go to account JP entity, so we have given the long type to this ID field, right? So this long we are passing as a second parameter to this JPA repository interface. Okay, great. Well, once we create account repository interface that extends JPA repository interface, then this account repository will get a CRUD database methods to perform CRUD database operations on this account JPA entity. Alright, perfect. Next step is create add account REST API. So before creating the REST API, let us first create the service layer. Well, the controller layer depends on service layer. So let us first create add account method in a service layer, and then we'll create the REST API, and that REST API will internally call the service method. So here go to service package, right click on it, new, and then choose Java class, and let us select interface and let us give interface name as account service. Okay, next let us define the method over here. So let us say account and then create account, and let us pass account. Well, we can also use a DTO to transfer the data between client and server. Okay, so what we will do, we'll use the DTO. So let's create a new package for it, and let's give package name as DTO, and here let us create a class and let us give class name as account DTO, and here let us type the field private long ID and then private string account holder name and then private string, let us go double, and then balance. Alright, and here let us use at data lambda connotation to automatically generate constructors, getter, setter methods. Next, let's go back to account service interface, and here instead of account JP entity, let us use account DTO. So here also let us pass account DTO. Okay, perfect, and let's view the name as account DTO, and let's remove this unused import. Okay, perfect. Next, go to service package and let's create one new package, and let's call it as IMPL. IMPL stands for implementation, so all the implementation classes we keep under this IMPL package. So right click on this package, new, and then choose Java class. Let's give class name as account service IMPL. So this is the naming convention. Next, this class implements account service interface and implement its methods. So here just mouse on this class, click on this implement methods, select the method that you want to implement, click on OK. Perfect. Next, let us annotate this class with add service annotation to automatically create a Spring Bean for this class. Next, let us inject the dependency. So here, let us first declare the field private account repository. Next, let us use a constructor based dependency injection to inject this account repository dependency. So here, right click and then generate and then constructor and select the dependency, click on OK. Alright, next here we can annotate this constructor with @attribute annotation to automatically inject the dependency, but Spring 4.3 onwards we can ignore this @attribute annotation, because whenever Spring will find the single constructor in a Spring Bean, then Spring will automatically inject the dependency. Okay, perfect. Next, go to create account method over here, and within this method we need to convert account DTO into account JP entity, and then we'll save that account JP entity into a database. So this is the conversion logic, right? So let us create one mapper class and let us write the common logic, like we can convert a DTO into JP entity and JP entity into DTO. So here go to DTO package, or else let's create one more package and let's call it as mapper. Next, within a mapper package, let's create a new class. Let's call it as account mapper. So within account mapper class, let's create static method public static, and let us give the return type account, and let us give method name as map to account, and let us pass account DTO as a parameter. Perfect. Next, let us convert this account DTO into account. So here let us create the object account and then account equal to new account. Next, let us pass the details to the constructor account DTO dot get ID, and then account DTO dot get account holder name, and then account DTO dot get balance, and then finally I return the account object. Now we have converted account DTO into account JP entity. Similarly, let us write one more static method to convert account JP entity into account DTO. So here just type public and then static and then return type as account DTO. Let's give method name as map to account DTO, and let us pass account JP entity. Perfect. Next, let us create account DTO object over here. Alright, and let us pass values to the constructor like account dot get ID, and then account dot get account holder name, and then account dot get balance, and then finally return this account DTO. Well, let us see what is the compilation error over here. It says the parameterized constructor is not available in the account DTO. So go to account DTO over here. So this add data annotation don't provide the constructor. So here let us use add argument constructor annotation. Okay, let's go back to mapper class, and there we go. Alright, now we have created a mapper class to map DTO into entity and vice versa. Next, let us use this account mapper class in a service classes. So go to account service impl class over here and go to create account method, and here let's create object of account and then account, and then let us call account mapper over here, account mapper, and then it has map to account method and then pass account DTO. Next, let us call account repository over here, and then it has a save method. So let us call save method to save the account JP entity, and then pass account JP entity object to this save method. So this save method basically return the saved entity. So here let us introduce a local variable of type account, and let's give variable name as saved account. Okay, perfect. And if you look at the create account method return type account DTO. So let us convert saved account into account DTO. So here let us remove this null and then call account mapper and then map to account DTO and then pass saved account. Okay, perfect. Now we have created create account method. It will call the account repository to save the account into the database. Next, let us create the REST API and then that REST API will internally call this method. So go to controller package over here, right click on it, new, and then choose Java class. Let us give class name as account controller. Let us annotate this account controller class with @REST controller annotation. So this @REST controller annotation will make this class as a Spring MVC REST controller class. Next, let us annotate this class with @request mapping annotation, and let us pass the base URL over here. Let us say /API/accounts. Okay, so this is basically a base URL for all the REST APIs that we are going to define within this account controller class. Okay, great. Next, let us inject the dependency. For that, let us first define the field, that is private account service. Next, let us use a constructor based dependency injection to inject this account service dependency. So here right click, generate, and then constructor, and then click on OK. Now we have injected account service using constructor based dependency injection, and here again we don't have to use @word annotation because this class has only one constructor, so Spring will automatically inject the dependency. Next, here let's create a add account REST API. Well, creating a REST API using Spring Boot is very simple. First we need to create a method and then we'll make that method as a REST API by using Spring annotation. Okay, alright, so just type public and then let us use response entity as a return type, and this is generic, so we can pass account DTO as a type. Let's give method name as add account and then pass account DTO as a parameter to this method. Alright, perfect. Next, let us have a return statement over here. Return new response entity and then call account service dot create account and then pass account DTO. Next, let us pass the HTTP status, that is created. HTTP status created. Perfect. Now we have created add account method. It will call account service dot create account method, and this create account method basically return the saved account. So this is the first argument. Second argument is HTTP status. Okay, perfect. Next, let us make this method as a REST API by using Spring annotation. So in this case, this method have to handle the HTTP post request. For that, let us use @post mapping annotation. Next, here let us use one more annotation, that is @request body annotation. So this @request body annotation will map the request body to this Java object. So request body basically contains JSON, so this @request body will automatically convert that JSON into this Java object. Okay, perfect. Next, let us go ahead and let us run our Spring Boot application and let us test this add account REST API. So from here I am going to stop the running application first and I am going to run the application again. And notice here our Spring Boot application is up and running in a embedded Tomcat server on port 8080. Next, let us open the Postman REST client, and here let's create one new request, and here let us choose HTTP post method and just type the request URL http localhost 8080/API/accounts. Okay, so if you go to project again and if you go to account controller, the URL is /API/accounts. So this is the URL we are using over here, /API/accounts. Okay, next go to body and then select raw, select content type as a JSON and here we need to pass JSON in the request body. So let us quickly create the JSON object. So if you go to project again, and if you go to account detail, so this account detail has field account holder name and balance. So these fields we have to use in a JSON. So let me copy this field name and let me paste it over here, and then let's give holder name, in my case Ramesh. Next, balance, let us say 10,000. Okay, next go ahead and click on send button, and there we go, we got the response from the server. And if you look at the ID here, 1, so this ID we are getting from the database. And look at the status, 201 created. Let us verify in the database. So go to MySQL Workbench, go to accounts table, select rows, and you can see the account is successfully stored in a accounts table. Okay, perfect. Now we have successfully built add account REST API. Next, let us build get account REST API. So let's go back to our IntelliJ IDEA. So here let's first change the service layer. So go to account service interface and let us define the method. So here let's give method name as account DTO. Let's give method name as get account by ID, and then pass ID as a parameter. Perfect. Now we have defined get account by ID method in a account service interface. Next, let us implement this method in a account service IMPL class. So go to account service IMPL class over here, just mouse over on this class, click on implement methods, select the method that you want to implement, click on OK. Next, let us implement this get account by ID method over here. So here just call account repository, it has find by ID method, and notice here find by ID method returns optional of type account. Okay, so just call find by ID and then pass ID over here, and then call or else throw method over here. Well, let us say the account with a given ID is not existing in database, then we have to throw the exception. For that we can use or else throw method over here. So just call this or else throw method, and then here let us pass the lambda expression implementation. Well, this or else method takes supplier functional interface, and we have to provide the lambda expression implementation for this supplier functional interface. So here is the lambda expression to create a new exception and throw that exception. New, let us throw the runtime exception over here. You can create your own custom exception and you can throw that exception from here. So let us say account does not exist. Okay, perfect. Next, here let us take the return return value from this method. Let us say account. Next, this get account by ID method returns account DTO. So let us convert this account JP entity object into account DTO. For that, let us call account mapper, and then it has map to account DTO, and then pass account. Perfect. And here let me align this properly. Perfect. Now we have created get account by ID method in a account service IMPL class. Next, let us create get account REST API that will internally call this method. So go to controller layer and go to account controller class, and here let's create get account REST API. So here let me first write the comment get account REST API. Let us type the method public and then response entity, and then pass account DTO as a type. Let's give method name as account get account by ID, and then pass ID as a parameter to this method. Next, let's call account DTO and then call account service dot get account by ID and then pass ID. Perfect. Next, let us have a return statement, return and then response entity dot OK, and then pass account DTO in a body. Perfect. Now we have created a get account by ID method. So let's refactor this. Now we have created get account by ID method. It returns the account object, and look at the OK method. So this OK method internally returns the HTTP status 200 OK. Alright, perfect. Next, let us make this method as a REST API by using Spring annotations. So this method have to handle HTTP GET request. For that, let us use add get mapping annotation. Okay. So this add get mapping annotation will map the incoming HTTP GET request to this particular method. Next, let us pass ID to this annotation. Within a double quote slash within a curly braces, just pass ID. So this ID is nothing but a template, variable. Next, we need to bind the value from this template path variable to this method argument. For that, we can use add path variable annotation over here. Alright, perfect. Now we have built get account REST API. Next, let us rerun our Spring Boot application and let us test this get account REST API. So from here, let us stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's head over to the Postman client over here, and here let's create a new request. Let us enter the URL http :localhost 8080/API/accounts, and then pass account ID 1. Next, click on send button, and there we go. We got the response from the server. And look at here the ID 1, account holder name Ramesh, balance 10,000, and the HTTP status 200 OK. Now we have developed a get account REST API. Next, let us build deposit REST API. Well, basically we are going to develop the REST API that will deposit amount into a account holder name. For example, here the account holder is Ramesh. He has a balance 10,000. Next, we are going to deposit some amount into this, Ramesh account holder. Alright, so basically we are going to add some amount to the existing balance. Okay, it's pretty simple. So let us go to IntelliJ IDEA over here, and let us first develop the service layer. So go to account service interface, and here let's give account detail as a return type. Let's give method name as deposit, and let's pass first parameter as ID. Next, let us pass second parameter as a amount that we want to deposit into account. Now we have defined deposit method in account service interface. Next, let us provide the implementation for this deposit method in a account service sample class. So let us jump into account service sample class. Mouse over on this class, click on implement methods over here, and then click on OK. Next, let us implement this deposit method. Well, within a deposit method, first we'll check whether the account with a given ID exists in a database or not. If the account with a given ID is not exist in database, then we'll throw the runtime exception, right? So here we have already written a piece of code. So let me copy this piece of code and let me paste in a deposit method. Now we got the account for this particular account ID. Next, let us call its get balance method, and then add this amount to existing balance. Okay. Next, here let us introduce a local variable double. Let's call it as total equal to. Perfect. Next, let us call account, and then let's call it set balance method, and then pass total. Okay, perfect. Next, we need to save this object into a database. For that, let us call account repository, and then call save method, and then pass account object. Perfect. Next, this save method returns saved account object. So here let us introduce a local variable account, and then saved account. Next, this deposit method returns account DTO. So let us convert this account JP entity into account DTO. So here let us remove this null, and then call account mapper. It has map to account DTO, and then pass saved account. Okay, perfect. Now we have implemented deposit method. It will deposit amount into a account. And the logic is pretty simple. We'll get the existing balance from the account and we'll add the amount to the balance, and then we'll get the total amount, and then we'll add that total amount as a balance to the account, and then we'll save that account into a database. Okay, it's pretty simple. Next, let us build the deposit REST API that will internally call this method. So go to account controller and here deposit REST API. Alright, so here let's type public. Let's give return type as a response entity, and here let's give the type as account DTO, and let's give method name as deposit, and then let us pass two parameters to this method, long ID, and then second parameter as map. It takes key as a string, value as type double. So basically we'll pass amount in a request body. For that we'll use a map. Okay, next let us call it as request. Perfect. Next, within this deposit method, let us call account service. It has deposit method, and then let's pass ID as a first parameter. Second parameter we need to pass the amount, so we can get that amount from the request object. So here request dot get, and then we can pass key as a amount. Okay, next let us introduce a local variable amount account DTO. Okay, next let us have a return statement, return response entity dot OK, and then pass account DTO in a body. Now we have created a deposit method, and then internally we'll call account service dot deposit method, and then we'll pass ID and then amount. So we can extract this as a separate variable as well. So here what we'll do, we'll store in a local variable, let us say double, and then amount equal to request dot get, and then pass this amount over here. Okay, so this will basically improve the readability. Next, let us annotate this deposit method with @put mapping annotation. Well, we use @put mapping annotation to map incoming HTTP put request to this method. Next, within a double quote slash, and then pass ID. Next, slash deposit. So this is the URL for this REST API. Next, let us store the value of this ID into a method argument using @path variable annotation. So here let us use @path variable annotation to bind value of this template URI variable to this method argument. Next, here let us use one more annotation, that is @request body annotation. Well, this @request body annotation will map the request JSON body into this map Java object. Okay, perfect. Now we have developed the deposit REST API. Next, let us go ahead and let us rerun our Spring Boot application, and let us test this deposit REST API. So here let me stop and rerun the Spring Boot application. Alright, our Spring Boot application is up and running. Next, let us head over to the Postman client over here, and here let's create a new request, and here let us choose HTTP put method, and here let us enter the request URL. So let me copy this and let me paste it over here. Next, let's go to body and then choose raw, and then choose content type JSON, and here let us pass the JSON and the key as amount and the value. Let us say we want to deposit 5,000. Okay, that's it. Next, click on send button. So this says method not allowed. Well, here we need to give the correct URL. So let's go to IntelliJ IDEA, and let's see the URL that we have given to the REST API. We have given the URL ID/deposit. So we need to append this deposit in the URL as well. So here's /1/deposit, and then click on send button, and there we go. In a response, you can see the JSON account 1, account holder name Ramesh, and the balance is 15,000. Earlier it was 10,000. Now you can see the balance 15,000. Okay, it means we have successfully deposited 5,000 into account Ramesh. Next, let us say we want to deposit 10,000. Next, click on send button and you can see the response. The total balance 25,000. It means the deposit REST API is working as expected. Next, you can see the same change in the database table as well. So go to accounts table, right click, select rows, and you can see the balance 25,000. Okay, it means we have successfully built deposit REST API. Okay, great. Next, let us build withdraw REST API. So let us go to IntelliJ IDEA and let's create the withdraw REST API. So let us first change the service layer and then we'll change the controller layer. So go to account service interface and here let's define the method. Let's give return type as account DTO. Let's give method name as withdraw and let's pass parameter as long ID. Let's also pass the second parameter, that is amount. Perfect. Now we have defined withdraw method in a account service interface. Next, let us provide the implementation for this method in a account service IMPL class. So let us jump into account service IMPL class. Just mouse over on this class, click on implement methods, select the method that you want to implement, click on OK. Perfect. Next, let us implement this withdraw method over here. So here, first we'll check whether the account with a given ID is exist in a database or not. If the account with a given ID is not exist in database, then we'll throw the exceptions like account does not exist. Okay, so that piece of code we have already written in a existing methods. So we can copy that piece of code from here. So go to deposit method and copy this piece of code. Okay, and again go to withdraw method and here simply paste it. Okay, perfect. Next, let us add one more condition, like if the withdraw amount is greater than the balance, then we'll throw the exception like insufficient amount. Okay, so here let's add the if condition and then account dot get balance. So if the account balance is less than the withdraw amount, then we'll throw the runtime exception. So here throw new runtime exception and let us pass the message insufficient amount. Perfect. Next, here let us write the logic double total equal to, so here just call account dot get balance minus amount. So in this case we are withdrawing the amount from the balance, that's why we are using a subtraction. Okay, next let's call account dot set balance and then pass total. Okay, perfect. Next, let us call account repository and then call save method and then pass this account object. Next, this save method return the account saved account object. So let us introduce a local variable of type account. Let's call it as saved account. Perfect. Next, if you can look at the withdraw method over here, it returns the account DTO. So let us convert account entity into account DTO. So here let us remove this null and let's call account mapper and then it has map to account DTO and then pass saved account. Okay, perfect. Now we have implemented withdraw method. Internally it will call account repository dot find by ID method. Let us say if the account with a given ID is not exist in database, then we will throw the runtime exception. Next, we have added one more condition, like if the withdraw amount is greater than the balance, then we'll throw the runtime exception like insufficient amount. Next, let us say the balance is greater than the withdraw amount, then we'll write the logic like we'll withdraw some amount from the existing account balance and then we'll add that total to the account and then we'll save that account into the database and then we'll return the updated information. Okay, the logic is pretty simple. Next, let us build the withdraw REST API that will internally call this method. So go to account controller. So here let me first write the comment withdraw REST API. So just type public and then response entity and then pass account DTO. Let's give method name as withdraw and then pass two parameters. First parameter as ID, second parameter as a map. The key type is string, the value type is double, and let's call it as request. Perfect. Next, let us get the amount from the request. So here double and then amount equal to request dot get and then pass amount. Alright, next account DTO equal to account service dot withdraw and then pass ID and then amount. Next, let us have a return statement, return response entity dot OK and then pass account DTO in a body. Perfect. Now we have created withdraw method. It will internally call account service dot withdraw method and it will pass account ID and the withdraw amount. Okay, next let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add put mapping annotation. Well, this put mapping annotation will map incoming HTTP put request to this method. And then let us pass the ID and then withdraw. Perfect. Next, let us bind the value of this ID to this method argument by using at path variable annotation. Next, let us use one more annotation, that is at request body annotation. Now we have built withdraw REST API. Next, let us rerun our Spring Boot application and let us test this REST API. So from here, let us stop and run the Spring Boot application. Alright, our Spring Boot application is up and running. Let's go to Postman client over here and here let's create a new request. So let me copy the request URL from the existing REST API request. So here let us select HTTP put method and then pass request URL localhost 8080/API/accounts/ the account ID and then withdraw. Alright, so here we are going to basically withdraw some amount from the account with ID 1. Next, let us go to body, select raw, choose content type JSON, and here let us pass the withdraw amount. Let us say I want to withdraw 5,000. Next, click on send button and there we go. In a response you can see the account holder name and the balance. Earlier the balance was 25,000. Now you can see the balance 20,000 because we have withdrawn the amount 5,000. Okay, next let us say I want to withdraw 5 more thousand. Then what I can do is I can click on send button and you can see the response. The balance is 15,000. Next let us say I want to withdraw 10,000. Then the balance should be 5,000, right? So let's click on send button and you can see the balance 5,000. It means the withdraw REST API is working as expected. Next, let us build get all accounts REST API. Well, first we'll change the service layer and then we'll change the controller layer because controller layer is depends on service layer. So let us head over to account service interface over here and within this interface let us declare a method. So let's give the method return type as list. List is a generic, so let us pass account DTO as a type. Let's give method name as get all accounts. Perfect. Next, let us go and let's implement this method in a account service IMPL class. So let us jump into account service IMPL class over here. Just mouse over on this class and here you will get a link to implement the methods. Click on this implement methods, select the method that you want to implement, and click on OK. Next, let us write the logic to implement get all accounts method over here. So within a get all accounts method, let us call account repository. It has find all method, and notice here find all method returns a list of account. So just call this find all method over here. Next, let us get the result of this find all method in a list. So list and then account, let's call it as accounts. Okay, now we got a list of accounts. Next, let us convert this list of account into list of account DTO. So here let us call accounts. So accounts is a list and list has a stream method. So here just call stream method, and the stream has a map method. So let us use map method to map entity into DTO. And look at here, map method takes function as a functional interface. We need to provide the lambda expression implementation of this function functional interface. So let us call this map method over here, and let us pass the lambda expression implementation. Well, here let us pass account entity object as a parameter to the lambda expression, and then this is the lambda symbol, and then call account mapper. It has map to account DTO method, right? And then pass account entity object. Next, let us call collect collectors dot to list method. Okay, perfect. Well, here we are using account mapper dot map to account DTO method to map account entity object into account DTO. And finally, we are returning the list from the stream, and this list basically contains the list of account DTO. Okay, so here let us have a return statement and remove this return null. Okay, now we have implemented get all accounts method. It will return the list of account DTOs. Next, let us create get all accounts REST API that will internally call this method. So let us head over to account controller over here, and here let me write the comment get all accounts REST API. Perfect. So here let us first create the method, and then we will make that method into REST API. So just type public and then response entity. Response entity is a generic. Let us pass type as a list, and again list is a generic. So let us pass account DTO as a type. Let's do method name as get all accounts. Okay. Next, within this method, let us call account service and then call get all accounts method. So this get all accounts method return list of account DTO. So here let us have list and then account DTO. Let's call it as accounts. Perfect. Next, let us have return statement and then response entity. It has OK method and then pass accounts in a body. Perfect. Now we have created a method called get all accounts. It returns a list of account DTOs. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add get mapping annotation. Okay, that's it. Next, let us go and let us rerun our Spring Boot application and let us test this get all accounts REST API. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us head over to the personal client over here and let's create a new request, and let us choose HTTP get method over here and let us enter the request URL. Well, let us copy from the previous REST API and just paste it over here, and here let us remove these parameters and just keep localhost 8080/API/accounts. Next, go ahead and click on send button, and there we go. In a response, you can see a list of accounts. So as of now, there is only one account. Now what we'll do, we'll add a few more accounts. Okay, so go to the add account REST API over here, and here go to the body and just change the account holder name from Ramesh to John, and then balance, let us have 20,000. Click on send button. Now the John account is created. Next, let's create one more account. Let us say Sanjay, and then let's say balance 30,000. Click on send button, and there we go, Sanjay account is created. Next let's go to get all accounts REST API, and next send the request, and there we go. In a response you can see a list of accounts, and there are total 3 accounts in the list. Alright, it means the get all accounts REST API is working as expected. Alright, great. Next let us go ahead and let us build delete account REST API. Well, first we'll change the service layer and then we'll change the controller layer. So go to account service interface over here, and here let's define the method. So let's give return type of the method as a void, and let's give a method name as delete account, and then pass account ID as a parameter. Now we have defined delete account method in account service interface. Next let us implement this method in account service IMPL class. So let us jump into account service IMPL class over here, and just mouse over on this class, click on implement methods, select the method, click on OK. Alright, next let us implement this delete account method over here. Well, first we'll add the condition like if the account is not exist for a given ID, then we will throw the runtime exception. Okay, so that logic we have already written in a withdraw method and deposit method and get account by ID method, right? So let us copy this piece of code from the get account by ID method, and then let's go back to delete account method over here, and within this method let us paste this logic. So here basically we are adding the condition like if the account with a given ID does not exist in database, then we will simply throw the runtime exception like this. Okay, great. If the account with a given ID exists in database, then we'll delete that account. So for that, let's call the account repository. It has a delete by ID method, and then pass account ID. All right, perfect. So this delete by ID method returns a void, so we no need to return anything. Now we have implemented delete account method. It will delete a account by given ID. Next let us build the delete account REST API that will internally call this delete account method. So let's go to account controller over here, and here let's write the comment first, delete account REST API. Just type the method public, and then response entity, let us pass string as a type. Let's give method name as delete account, and then pass account ID. Perfect. Next, within delete account method, let us call account service. It has delete account method, and then pass account ID. So this will basically delete the account by ID. Next, let us have a return statement, return response entity dot OK, and then pass the success message here. Let us say account is deleted successfully, something like that. Perfect. Now we have created delete account method. It will delete the account by using account service dot delete account method and return the success message. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @delete mapping annotation. Well, we use @delete mapping annotation to map incoming HTTP delete request to this particular method. Next, let us pass the URI template variable over here. So here braces within a double quote slash within a curly braces ID. So this ID is nothing but a UI template variable, and this ID basically contains the account ID. So we need to bind the value of this ID into the method argument. For that, let us use @path variable annotation. Okay, perfect. Now we have implemented delete account REST API. Next, let us rerun our Spring Boot application and let us test this delete account REST API. So from here, I'm going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running. Next, let us head over to the Postman client, and here let's create a new request. Let us choose HTTP delete method over here, and here let us enter the request URL. So let me copy this and let me paste it over here, localhost 8080/API/accounts. So let us say we want to delete the account with ID 1. So just pass ID 1 in the URL. Next, click on the send button over here, And there we go. You can see the response. Account is deleted successfully with HTTP status 200. Okay. Next, let us verify in the database. So let's go to MySQL Workbench over here and go to accounts table, select rows, and notice here the account with ID 1 is deleted from the accounts table. Next, let us delete the account with ID 2 as well. So let's go to Postman client, and here let us pass the account ID 2 in the URL and click on send button, and there we go, we got the success message. Next, let's verify in the database. So here let us refresh the table, that is select rows from the table, and there we go, the account with ID 2 is successfully deleted. It means the delete account REST API is working as expected. Alright, great. Hi everyone, welcome back. In this lecture, let us see how to use a Java record class as a DTO class in our banking application. Well, if you look at the banking application code here, we have used a normal class as a DTO class to transfer the data between client and server. Now, we are using Java 17 plus, so we can utilize the latest feature of Java, right? So record class is a special type of class which is introduced in Java 16. So we can use record class to transfer the data between client and server. And the record class basically is a special kind of class that helps you to encapsulate a related data without the need for boilerplate code. It means once we create a record class, then Java compiler will automatically generate a getter methods, setter methods, constructors, equals, hash code, and toString methods. So in normal Java class, we have to manually create all these boilerplate code, right? But this Java record class tells Java compiler to automatically generate all this boilerplate code. Using record class as a DTO in a Spring Boot application is a modern and efficient approach to encapsulating data transfer between application layers. So basically, record class holds the immutable data, and it is a good candidate as a DTO to transfer the data between different layers. Next, records are good fit for DTOs because they are concise, immutable, and automatically provide the implementations of getter methods, constructors, equals, hash code, and toString methods, which are essential for DTOs. So let us go ahead and let us see how to use a record class as a DTO in our banking application. So let's go to our project in IntelliJ IDEA and go to account DTO class over here, and here let us go ahead and comment out this code. So here just type public and then record keyword, and let us give record name as account DTO, and next define the fields long ID and then string account holder name and then double balance. Perfect. So basically these fields are implicitly final. So once we create this account DTO object, we cannot modify it because records are immutable. Alright, perfect. Next, let us go to account mapper class over here, and here we have to change these getter methods because record basically provides a getter method name as a field name. For example, here let us remove this get ID method and then call ID. Next, let us remove this and then call account holder name. Next, let us remove this get balance and then call balance. That's it. Now what we have done, we have created a record account DTO and then we have changed in an account mapper. Okay, that's it. Next, let us rerun the Spring Boot application and let us test couple of REST APIs. So from here, I'm going to start the Spring Boot application. So notice here our Spring Boot application is up and running. Next, let's go to the Postman client and let us test couple of REST APIs. So here first let us test create account REST API. So here I'm going to create a new account with a holder name Ramesh. So before that, let us go to the database table over here and let us select the rows from the accounts table. So there is only one account holder, that is Sanjay. Next, let us insert one more account. So here let us give account holder name as Ramesh and the balance 10,000. Click on send button and there we go. The record is successfully created. Let us verify in the database table and you can see here Ramesh record is inserted. Okay, it means the create account REST API is working as expected. Next, let us test get account by ID REST API. So here let us select HTTP get method and here let us pass account ID 6 and then click on send and there we go. we got the response of the REST API. Next, let us test withdraw REST API. Okay, so here let us pass the account ID 6 and then click on send button. So basically look at here, the amount 10,000 we want to withdraw, and look at here the response. And if you go to database table, the Ramesh user has a balance 10,000 and we have just withdrawn that 10,000 and balance remains 0. Okay, it means withdraw amount REST API is working as expected. Next, let us test the deposit REST API as well. Let us deposit 20,000 to the Ramesh account. So click on send button and there we go, the balance 20,000. And let us verify the database table and look at here, Ramesh has a balance 20,000. Next, let us test get all accounts REST API. So here let us remove the ID from the URL, click on send button and there we go, there are 2 accounts in the database table and same we can see in the response of the REST API. Next, let us test the delete account REST API. So here let us pass account ID 3 and click on send button and there we go, account is deleted successfully. It means we have successfully used record class as a DTO class to transfer the data between client and server. Alright, great. Hi everyone, welcome back. In this lecture onwards, we'll start implementing exception handling in a banking application. Let us quickly take a look into how we are going to handle the exceptions in a Spring Boot REST API project. Well, whenever client sends a request, the controller will handle that request and it will send that request to the service. In a service, we basically write the logic to validate the request. Like first we'll check whether the account with a given ID is exist in database or not. If it is not exist, then we throw account exception. Once we throw the account exception, then we have to handle that exception and we need to prepare the error response for that exception and we need to send that error response back to the client, right? So for that, what we'll do, we'll create a global exception handler class. Within that, we will write a logic to handle specific exceptions as well as generic exceptions in a single place. So instead of writing the exception handling logic in each and every controller, we'll create a separate class as a common class and we'll call it as global exception handler. And within this class, we keep all the exception handling related logic. Okay, so this is basically a flow. Whenever client sends a request, the controller will process that request and it will forward that request to the service. Service will validate the request. If there are any issues, then it will throw the exception and then global exception handler will catch that exception. It will prefer the error response and it will send that error response back to the client. So this is the simple flow. Next, let us take a look into few key points about exception handling in a Spring Boot application. Well, handling exceptions in a Spring Boot REST APIs is typically done by using @controller_advice and @exception_handler annotations. Next, @controller_advice annotation enables global exception handling for controllers. So instead of writing the exception handling logic for each and every controller, we will create a separate class and we will annotate that class with @controller_advice annotation. And within that class, we'll write all the exception handling logic for all the controllers. So we'll basically keep all the exception handling logic in a single place. Next, @exception handler annotation defines the methods to handle specific exceptions within a controller or globally with @controller_advice class. So basically we use @exception handler annotation to handle the specific exceptions. So we'll see in a coding section how we can use these two annotations to handle the exceptions in a Spring Boot REST APIs. Alright, in next lecture we'll start implementing exception handling in our banking application. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we had a quick overview about how to handle the exceptions in a Spring Boot application. Well, before handling exceptions in a Spring Boot application, let us understand Spring Boot default exception handling. Well, if you go to our project in IntelliJ IDEA and go to account service sample class, within that go to get account by ID method. So within this method, here we have written a logic like if the account ID is not exist in database, then we throw the runtime exception, right? And if you test this REST API here, well, here I'm going to test get account by ID REST API and look at here, we got the response. It says internal server error. Well, if you again go to the database first and here let us select the rows from the accounts table and here you can see the account ID 3 is not exist in the table, and here in a REST API URL we have passed the account ID 3. Well, the account with the ID 3 is not exist in database, then we got the response like this. But this is the not a correct response, right? So we have to get the error message properly. So here internal server error. So this is not a meaningful error message, right? So this is basically a technical term. And again, look at here the HTTP status 500 internal server error. So the status should be 404 not found, right? Because the account with ID 3 is not found, that's why the status should be 404 not found, but we are getting 500 internal server error. So this is the default Spring Boot exception handling. Now let us go ahead and let us implement exception handling in our banking application as per our requirement. So basically our requirement is like we need to send the status as a 404 in the response, and we need to also send the error message, that is meaningful error message, and we also need to send the error code in the response. Okay, so let us go ahead and let us see how to implement the exception handling in the banking application as per our requirement. So let us head over to the development steps. First step is create a custom exception named account exception. Second step is use account exception. Well, instead of using runtime exception, we will use account exception. Next step is create error details class to hold the error response. Next step is create a global exception handler to handle the specific exceptions as well as generic exception. Alright, so first step is create a custom exception named account exception. Let's go to our project in IntelliJ IDEA and let's first create a new package. So go to base package, right click new and then choose package. Let's give package name as exception, and within an exception package let's create a custom exception. For that choose Java class and let us give class name as account exception. Perfect. Next extend this exception from runtime exception, and within this class let us create a constructor with the name account exception, and then here just pass the message. So this message basically holds the error message, and let us pass this message to the super class constructor by using super method call over here. Perfect. Next let us take a look into next step. Next step is using account exception. Now we have created account exception. Next let us use this account exception in a account service IMPL class. So go to account service IMPL class, go to get account by ID method over here, and here instead of runtime exception, so let us use account exception. Okay, perfect. Next go to deposit method over here, and here also we have used runtime exception, so just remove this runtime exception and then use account exception. Similarly go to withdraw method, and here also runtime exception, so just remove it and then use account exception. Next go to delete account method, and here also we have used runtime exception, so instead of this let's use account exception. Okay, now we have removed the generic exception, that is runtime exception, and we have used our custom exception, that is account exception, in a required places. Okay, perfect. Next let us take a look into next step. Next step is create a error details class that holds the error response. So let us go back to our project, go to exception package over here, right click on it, new, and then choose Java class, and here select record. Let's give record name as error details and hit enter. Next let us define the fields for this record. So here just type local date time and let's give field name as timestamp. Well, this is the timestamp when the exception occurred. And next string message, so this field holds the error message. Next string details, if the user or the client want more information about the exception, then we can store this in a details field. Next string error code, so we can also send the specific error code about the exception by using this error code field. Okay, perfect. Next we don't have to create a getter methods or the constructor to string equals hash code, because this is the record, so Java compiler will automatically provide all these boilerplate code. Next let us take a look into next step. Next step is create a global exception handler to handle the specific exceptions as well as generic exceptions. Well, we will implement this step in the next lecture. Hi everyone, welcome back. In this lecture, we'll implement create global exception handler to handle the specific exceptions as well as generic exceptions. So let us go to our project again, and here go to exceptions package. Within that, right click, new, and then choose Java class. Let's give class name as global exception handler. Hit enter. Next, let us go ahead and let us annotate this class with @controller advice annotation. Well, once we annotate this class with @controller advice annotation, then this class becomes a global exception handler class, and within this class we can define the specific exceptions as well as generic exceptions. So basically, instead of writing the exception handling code for each and every controller, we basically create a single class and we annotate this class with @controller advice annotation, and within this class we keep all the exception handling related code in a single place. Okay, perfect. Next, within this class, let us first handle the specific exceptions. So here let me write the comment handle specific exception. So in this case, account exception. So this account exception is a specific exception that we are going to handle over here. So here just type public and let us give return type as response entity. Response entity is a generic class. We have to pass a type. So in this case, let us pass error details as a type, and let's give method name as handle account exception, and then let us pass post parameter to this exception as a account exception. Let me maximize this. Next, let us pass web request as a second parameter to this method. Well, we'll get some request data from this object. Next, within this method, let us create an instance of error details class over here, new error details, and we can pass a data to the constructor. So first value is timestamp. For that, let's call local date time, and then it has now method. So this will basically return the current date time. Next is error message. So we can get the error message from this exception object. So here just call exception dot get message, and then third value, if you go to error details, you can see third value we can pass as a details to the constructor. So let's go back to global exception handler class, and here we can get the details from this web request. So just call web request dot get description. So instead of passing the entire description, we just need to pass the URL. For that, just pass false as a value to this get description method. Next, we need to pass the error code. So here let us give the error code as account underscore not found. Okay, perfect. Now we have created error details class with the proper error response. Next, let us have a return statement, return, and then new response entity, and then pass error details object in the body as a post parameter. Second parameter is the HTTP status. So here just call HTTP status dot not found. Perfect. Now we have created a method. Next, let us annotate this method with @exception handler annotation, and then pass the exception that we are going to handle, that is account exception. Perfect. Now we have written the exception handling logic that handles this specific exception, that is account exception. Let's go ahead and let's write the logic to handle generic exceptions. So here let me write the comment handle generic exception. Well, if we get any exceptions other from these specific exceptions in our Spring Boot application, that should be handled by using this generic exception. Okay, so here just type public and then response entity, and then pass error details as a type. Next, give method name as handle generic exception. Alright, next let us pass exception as a post argument, and then web request as a second argument. So within this method, let's create an object of error details record class over here, and then pass values to the constructor. So first value is timestamp. For that, call local datetime dot now method, and then we need to pass error message. So we can get error message from exception object. So here exception dot get message, and then we need to pass the details. So we can get the details from web request object. So web request dot get description method, and then pass false as a value to the get description method. Next we need to send the error code as well. For that, here just pass the error code internal server error. So if there are any exceptions other than the specific exceptions, we can tell the client that there is some internal server error. Next, here let us have return statement, return new response entity, and here just pass error details object in a body, and then http status dot internal server error. Okay, perfect. Next, let us annotate this method with add exception handler annotation, and then pass the generic exception, that is exception dot class. Alright, so if there are any exceptions occurred other than the specific exception, that will be handled by this generic exception logic. Okay, perfect. Next, let us go ahead and let us rerun our Spring Boot application, and let us test this change. So from here, let us stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let's go to the Postman client over here, and here let us call get account by ID REST API. Well, before that, if you go to database table, and here you can see the account with ID 6 is exist in the database table, and in the Postman client we are calling the get account by ID REST API with the account ID 3. Okay, now go ahead and click on send button, and there we go. In a response, you can see the details, timestamp, the message, account does not exist, details, the URL, and the error code account not found, and look at here the HTTP status 404 not found. This response looks good, right? So this is how we can implement the exception handling in a Spring Boot application as per our requirement. Okay, so similarly, let us test the positive scenario, that is if the account ID is exist in database, then we should get the correct response. So here click on send button, and there we go, we got the correct response, right? Next, let us also test the deposit and withdraw REST API as well. So here click on send button, and look at here the account with ID 6 is exist in database, that's why we are getting the valid response. And if I pass the invalid account ID, that is 3, then this REST API return the error response. Okay, this response looks good. Alright, next let us test the withdraw REST API, and look at here the account with ID 3 is not exist in database, that's why we got the error response like this, and this is the correct error response as per our requirement. Next, if I pass the correct account ID in the URL, and if I click on send button, we got the success error response. Next, let us also test the delete account REST API. So here let us select http delete method over here, and then pass account ID 3 in the URL. Well, the account with ID 3 is not exist in database, we should get the error response, right? So click on send button, and there we go. Next, the account ID 6 is exist in database, so this should delete the account from the database, and there we go. This is the success response. It means we have successfully implemented exception handling in our banking Spring Boot application. Alright, great. Hi everyone, welcome back. In this section of the lectures, we are going to build a simple student management web application. Well, this student management system web application allows users to add a new student, list out all the students, update the existing student, delete the student, and view the student details. So this is a simple student management system web application that we are going to build, and this web application allows the users to add a student, update the student, delete the student, list out all the students and view the student details. Now let us take a look into what are the features that we are going to develop in this student management system project. First, we'll develop list of students feature. In this feature, the user can able to list all the students and user can view all the students from the database. Next, we'll implement add new student feature. Well, user can use this feature to add a new student. Next, we'll add a validation to the create student form as well. So user can use the validation and accordingly user can create the student. Next, we'll implement edit or update student feature. Well, user can use this feature to edit the existing student. Next, we'll implement delete student feature. Well, user can use this delete student feature to delete the specific student by using delete button. Next, we'll implement view student feature. Well, user can use this view student feature to view the particular student details. So these are the features that we are going to implement in this section of the lectures. Hi everyone, welcome back. In this lecture, we'll create and set up Spring Boot project in IntelliJ IDEA. Well, we're going to use Spring Initializer to quickly create and bootstrap Spring Boot project, and then we'll import that project in IntelliJ IDEA. Well, let's head over to the browser. In a new tab, just type start.spring.io, hit enter. This will open the Spring Initializer. Well, Spring Initializer is a web tool that we can use to quickly create Spring-based applications. Project information over here. So here, go to the project section. Here you can see different types of projects: Gradle Groovy, Gradle Kotlin, Maven. Since we are going to use Maven, so let us keep Maven is selected over here. And here we have different JVM languages like Java, Kotlin, Groovy. Let us keep Java selected as it is. Next here, let us select the Spring Boot version. Well, as we are going to use Spring Boot 4, let us select 4.0.0 RC1. Don't select snapshot. Next, go ahead and fill up the project metadata over here. So here let us give group as net.javaguides. Next, let us give artifact as student management system. Well, project name is same as artifact, so let us keep project name as student management system, and then description demo project for student management system. Next, package name net.javaguides.sms. SMS stands for student management system. Next, keep packaging jar, and then configuration, keep properties as selected. If you want to use YML, you can select YML. And here we are going to use latest version of Java, that is Java 25. So as of now, Java 25 is the latest long-term support release. So we are going to use Java 25 over here. Next, go to the add dependencies, click on it, and here let us type Spring Web. Well, in order to develop the Spring Boot web applications or RESTful web services, we are going to use Spring Web dependency. And this dependency internally provides Apache Tomcat server as a default embedded container to quickly run our Spring Boot application. Okay, so let us select Spring Web dependency over here. Next, let us go ahead and use Spring Data GPA dependency. Well, Spring Data GPA dependency we use to reduce a lot of boilerplate code that is required to develop the DAO layer or a repository layer. And the Spring Data GPA by default internal uses Hibernate for the database communication. So let us select Spring Data GPA dependency. Next, we are going to use MySQL database. For that, we are going to use MySQL JDBC driver to connect our Spring Boot application with the MySQL database. Next, we are going to add a validation to the TimeLeap, HTML pages. For that, we are going to use validation dependency. Next, we are going to use TimeLeap to develop the web pages. So let us go ahead and select TimeLeap dependency over here. So TimeLeap is a modern server-side Java template engine for both web and standalone environments. It allows HTML to be correctly displayed in browsers and as a static prototypes. So let us go ahead and select TimeLeap dependency over here. Perfect. So as of now, let us keep this dependency as it is. Next, if you want to explore this project, you can go ahead and click on explore over here. And here go to pom.xml file, and here you can see the Spring Boot version. You can see the Java version over here. And then here you can see the dependencies like Spring Data Starter GPA, Spring Boot Starter TimeLeap, Spring Boot Starter Validation, Spring Boot Starter WebMVC, and then MySQL JDBC driver. Okay. Next, if you expand this SRC folder, you can see the standard Maven project structure. Alright, next go ahead and click on this close button over here. Next, click on the generate button to generate this Spring Boot project as a zip file. So click on generate and you can see the project is downloaded as zip file. Next, let us open this zip file in the folder and then right click and then extract. Now we have extracted student management system project. So let us open the IntelliJ IDEA and let us import the project. So here click on the open button and then go to the folder where your Spring Boot application is present. In my case, it is in a downloads folder. And here go ahead and select the student management system folder. Click on select folder. So IntelliJ IDEA will take a couple of seconds to download all the Maven dependencies and store in the local Maven repository. So in our Spring Boot application, we are going to use the Lombok library to reduce the boilerplate code, such as getter setter methods, constructors, toString, equals method, etc. So instead of creating all these things manually, we can use Lombok library to reduce the lot of boilerplate code. So here let us go ahead and add the Lombok dependency and let us configure the Lombok in our IntelliJ IDEA. So let us go to the browser. In a new tab, just type Lombok Maven dependency and hit enter. Go ahead and click on this first link and select the latest version and then just click on this dependency. It will copy to the clipboard and then go to the project, go to the pom.xml file and here go to the dependency section and at the end just paste this dependency. Next, this Spring Boot Maven plugin internally provides a older version of Lombok. So let us exclude the Lombok dependency from this Maven plugin. So here let us add the configuration tag and then let us add the excludes tag over here and then add the exclude and then go to the Lombok dependency and just copy these attributes like group ID, artifact ID and version and here paste it. Okay, that's it. Next, go ahead and click on the sync Maven changes icon to sync all the Maven changes. Okay, perfect. Now we have successfully added Lombok dependency to our pom.xml file. In order to use Lombok in an IntelliJ IDEA, we need to do a couple of settings. So go to the file and go to the settings and here just search for annotation and here go to the compiler section, go to the annotation processors. So we are going to use the Lombok annotations and IntelliJ IDEA should recognize the Lombok annotations. For that, we are going to enable the annotation processing over here and then click on apply and then click on OK. Next, we will also install the Lombok plugin in IntelliJ IDEA. So go to the file again, go to the settings and here just search for plugins and then here just search for Lombok. So here I have already installed the Lombok plugin. If the Lombok plugin is not installed in your IDE, then make sure to install it. Just click on the install button, it will install. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll configure MySQL database in our Spring Boot project. Well, let's head over to the IntelliJ IDEA. And in previous lecture, we have generated Spring Boot project using Spring Initializer and we have imported in a IntelliJ IDEA. In this lecture, we'll configure MySQL database in our Spring Boot project. Well, if you go to pom.xml file, we have added Spring Boot Starter Data JPA dependency. Well, this Spring Boot Starter Data JPA dependency internally configure a data source. We don't have to manually write a configuration to create a data source. Alright, so Spring Boot will automatically configure a data source whenever it will find Spring Boot Starter Data JPA dependency in a pom.xml file. Well, Spring Boot Starter Data JPA dependency, it wrapper application.properties file to get MySQL database configuration details. Hence, we need to configure all the MySQL database configurations in the application.properties file. Alright, so before configuring MySQL database details in our Spring Boot project, let's first create a database. So head over to the MySQL workbench and here let's create a database. So just type the statement create database followed by database name. So let's give database name as SMS. SMS stands for Student Management System and go ahead and execute this SQL statement and just refresh the schema and there we go. SMS database is created and let's set this database as a default schema. Okay, now we have created a SMS database in our MySQL workbench. Next, let's go to IntelliJ IDEA and go to application.properties file, and here we will configure MySQL database details so that our Spring Boot application will connect to the MySQL database. So just type the property spring.datasource.url. So let's configure JDBC URL to connect to the MySQL database. So JDBC :MySQL and then localhost. Well, our MySQL database is located in our local machine, hence we need to provide a localhost. But if your MySQL database is located in other remote machines, then you need to configure that remote machine IP address or host name over here, and then followed by the port, that is 3306 is the default port for MySQL server, and then followed by the database name, that is SMS. Okay, next let's configure MySQL username and password. So just type the property spring.datasource.username equal to root. Well, in my case, my MySQL database username is root, but make sure that whatever the database user that you have to provide that username over here. Next, let's configure spring.datasource.password. Well, in my case, my database password is mysql@123, but make sure that whatever the database password that you provide, you have to give over here. Alright, now we have configured MySQL database username and password. Next, let's configure couple of Hibernate properties. Let's type the properties spring.jpa.properties.hibernate.dilate. Alright, so this is the property that we use to configure Hibernate dilate for MySQL database. And here is the value org.hibernate.dilate and then just type MySQL. And if you can see here, MySQL 8, dilate 5, 7. So all these dilates are deprecated. So let's choose MySQL dilate. Okay, class. Alright, now we have configured MySQL Hibernate dilate. Well, we need to configure this MySQL dilate because Hibernate will refer this MySQL dilate and it will create appropriate SQL statements with respect to the database vendor. Alright, next let's configure one more Hibernate property, that is spring.jpa.hibernate.ddl-auto equal to update. Well, this property is pretty useful because this property will automatically create the database table in a database, and if tables are already present in database, then it will simply alter the table. It don't drop the table and create the new tables. Okay, now we have configured MySQL database in our Spring Boot project. Next, let's run our Spring Boot application and let's see whether our Spring Boot application will connect to the MySQL database or not. So let me go to main endpoint class over here, and from here I want to run the Spring Boot application. And here you will get an option like Lombok requires enable annotation processing. So go ahead and click on enable. Alright, and if you look at the console over here, Spring Boot application is up and running in an embedded Tomcat server on port 8080. And if you can observe here, there are no exceptions or errors. It means that our Spring Boot application is successfully connected to the MySQL database. Well, look at here few important log statements in a console. We have configured MySQL dilate in application.properties file, this one, and Hibernate is using MySQL dilate. Okay, next you can see Hikari data source. Well, Spring Boot by default uses Hikari data source to connect our Spring Boot application with the MySQL database, and Spring Boot by default uses Hikari connection pool to make a connection to the database. Alright, so just remember these few things. In order to connect our Spring Boot application with the MySQL database, we need to configure all these details like JDBC URL, username and password, and we need to provide database dilate to the Hibernate so that Hibernate will create appropriate SQL statements with respect to database vendor, and Spring Boot will automatically configure a data source for us. We don't have to manually create the data source, and by default Spring Boot will use Hikari data source, and by default Spring Boot will use Hikari connection pool. Alright, so these are the few important things you need to remember whenever you connect your Spring Boot application with the MySQL database. Alright, so in this lecture we have successfully made a connection between Spring Boot application and MySQL database. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll create a student JPA entity. Well, let's go to IntelliJ IDEA, and in previous lecture, we have configured MySQL database in our Spring Boot application, and we have also seen that our Spring Boot application is successfully connected with the MySQL database. Alright, now let's go ahead and let's create a student JPA entity. Before that, let's quickly create a packaging structure for our Spring Boot project. So go to the main package, right click, new, and then choose package, and let's give package name as controller. Well, we'll keep all the Spring MVC controllers within a controller package. Let's create a one more package, right click, new, and then choose package, and let's give package name as service. Well, all the service related interfaces and classes will keep within a service package. Similarly, let's create a one more package and let's call it as entity. Well, we'll keep all the JPA entities within this entity package. Next, let's create a one more package and let's call it as DTO. Well, DTO stands for data transfer object, and we keep all the model classes within a DTO package. Next, let's create a one more package, right click, new, and then choose package, and let's give package name as repository. Well, we'll keep all the Spring Data JPA repositories within a repository package. Next, let's create a one more package and let's call it as mapper. Within a mapper package, we'll keep all the mapper related classes. Alright, now we have created a standard packaging structure for our Spring Boot project. Next, let's go ahead and let's create a student JPA entity. We'll go to entity package, right click on it, new, and then choose Java class, and let's give a class name as student. Alright. Next, let's define the instance variables for this student class. Let's have private long ID, and then private string first name. Alright, and then private string last name, and then private string email. Perfect. So to keep it simple, let's have these fields in a student class. Next, let's use a Lombok annotation to reduce the boilerplate code. So let's use add getter Lombok annotation to generate getters for these instance variables. Next, let's use add setter Lombok annotation to generate setter methods for these fields. Let's also use no argument constructor as well as all argument constructor. Alright, now we have created a student Pojo class. Next, let's go ahead and let's make this student class as a JPA entity by using JPA annotations. So let's use add entity annotation from jakarta.persistence package to make this class as a JPA entity. Next, let's use add table annotation from jakarta.persistence package to configure the table details. For example, let's use name attribute of this annotation to give a name to the table. For example, let's give table name as a students. Alright, next, let's configure the primary key for this entity. In order to do that, let's use add ID annotation from jakarta.persistence package. Next, we need to configure primary key generation strategy. For that, let's use add generated value annotation from jakarta.persistence package. And we need to pass a primary key generation strategy. For that, let's use strategy attribute, and then let's use primary key generation strategy as a identity. Well, look at here, we have four types of primary key generation strategy, and we're going to use identity as a primary key generation strategy. So let's choose identity as a primary key generation strategy. Next, we can use add column annotation to configure mapping between database table column and entity field. For example, here we can use add column annotation from jakarta.persistence package to define the column name. For example, let's say name equal to first underscore name. Okay, but by default JPA will give a column name to this field with this name. Okay, we can simply ignore this add column annotation over here. Well, if you don't provide add column annotation, then JPA will by default provide a column name as a field name. And here you can see here email. Well, let's make this email column as a not null and also make this email column as a unique. So here we can use add column annotation to configure column details. For example, let's use add column annotation from jakarta.persistence package, and let's use its attribute, that is null label equal to false. In order to make a column as a not null, we can use null label equal to false. Next, we need to make this email column as a unique. For that, let's use unique equal to 2. Okay, now we have configured this email column as a not null as well as unique. Okay, great. Now we have created student JP entity. Next, let's run our Spring Boot application and let's see how Hibernate will create this students table automatically in a database. Now let me stop the Spring Boot application and let me run the Spring Boot application again. And there we go. Our Spring Boot application is up and running. Alright, now let's go to MySQL Workbench and here go to our SMS database, and before that let me refresh the schemas, and under tables you can see students table is successfully created, and just right click, select rows, and you can verify the columns ID, email, first name, last name. Alright, and if you look at the column name here, first underscore name, last underscore name. Alright, we haven't configured a column name in a field by using @column annotation. Alright, by default JP will give column name as like this. It means that the student JP entity that we have created in this lecture is working as expected. Alright, great. In next lecture, we will create a Spring Data JP repository for this student JP entity. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll create a Spring Data JP repository for student JP entity. Well, let's head over to the IntelliJ IDEA, and in previous lecture, we have created student JP entity, and we have seen that Hibernate automatically created a students table for the student JP entity in a database. In this lecture, we'll create a Spring Data JP repository for this student JP entity. We'll go to repository package, right click on it, new, and then choose Java class and select interface, and let's give interface name as student repository. Well, this is the typical naming convention developers follow to create a repository. Student is the JP entity name followed by a repository. Alright, let's hit enter, and next let's extend this student repository from JPA repository. So just type extends and then JPA repository. Well, notice here JPA repository is from org.springframework.data.jpa.repository package, and JPA repository is a generic interface, and we need to pass two parameters. First parameter is the type of the entity, second parameter is the type of the ID. Alright, let's choose JPA repository interface and then pass first parameter as a entity name. So in our case, student is the entity name, and second parameter is the type of the ID. For example, if you go to student JP entity, here we have given long data type as a type for this ID, right? So this long data type we are passing as a second parameter to JPA repository interface. Alright, once we define student repository, it extends JPA repository, then this student repository will get a CRUD methods to perform CRUD database operations for this student JPA entity. Alright, we don't have to write an implementation class to implement this student repository interface. Spring Data JPA by default provides implementation class that implements this JPA repository interface and its methods. Well, if you dive inside JPA repository interface internally extends CRUD repository interface as well as paging and sorting repository interface. It means that JPA repository will leverage all the methods from these two interfaces. Okay, so JPA repository will get all the CRUD methods from this CRUD repository interface and all the paging and sorting related methods from paging and sorting repository interface. Alright, we just have to extend this one interface. It will internally provide all the methods from CRUD repository as well as paging and sorting repository interfaces. Okay, now let's take a look into the implementation class of this JPA repository interface. Well, go ahead and click on here and just scroll down, and here you can see simple JPA repository. Well, simple JPA repository is a default implementation class of JPA repository interface. Well, if you look at here, simple JPA repository implements JPA repository implementation interface, and if you go inside JPA repository implementation interface, it extends a JPA repository interface. Okay, so this is basically inheritance, right? It means that simple JPA repository class, it internally implements JPA repository interface, and it will implement all its methods. Okay, for example, delete by ID, delete all by ID, get by ID, exist by ID, find all by ID. Alright, so it means that simple JPA repository class, it implements all the methods of JPA repository interface. Next, notice here simple JPA repository class, it internally annotated with at repository annotation. Hence, we don't have to again use at repository annotation in our student repository interface. For example, some of the developers annotate repository interface with at repository annotation, but actually we don't have to use this repository annotation over here, because if you can notice here, simple JPA repository class, it is already annotated with at repository annotation, right? Hence we don't have to again annotate our repository interface with at repository annotation. Okay, well, if you can observe one more important point in a simple JPA repository, simple JPA repository class, it internally annotated with at transactional annotation. It means that all the methods in a simple JPA repository class are by default transactional. Okay, if you check the methods, for example, delete method is annotated with at transactional annotation, delete by ID method. Okay, and if you can notice, save and flush method, save all. Okay, so all the public methods in a simple JPA repository class are by default transactional. Alright, again we don't have to use at transactional annotation in a service layer to make these methods transactional. Now we have discussed three important points. First point is JPA repository interface has an implementation class named simple JPA repository. Well, if you just go inside JPA repository, you can get its implementation class, that is simple JPA repository. Okay, so simple JPA repository is a default implementation class of JPA repository interface. Okay, just remember this class name. Next important point is simple JPA repository class, it already annotated with at repository annotation. Hence, we don't have to annotate our repository interface with at repository annotation. And third important point is simple JPA repository by default provides transaction for its methods. Okay, if you can notice here, all the public methods in a simple JPA repository class are annotated with at transactional annotation. Alright, hence by default all the methods in a JPA repository interface are by default transactional. Okay, we don't have to use again at transactional annotation in a service layer to make repository methods transactional. Okay, if you have a requirement to make your methods explicitly transactional, then only you can use at transactional annotation. Alright, so these are three important points you have to keep in mind whenever you use Spring Data JPA in our Spring Boot project. Alright, so in this lecture we have created student repository interface. It extends JPA repository interface from the Spring Data JPA library, and we have provided student and long as a parameters to JPA repository interface. Now this student repository will get a CRUD methods to perform CRUD database operations for this student JPA entity. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll create a student DTO class as well as student mapper class. Well, let's understand why do we need a student DTO class. Well, if you look at our Spring Boot web MVC architecture over here, we have a controller and view, but we need to also have a model, right? So in typical Spring MVC architecture, we should have a model, view and controller. Alright, and if you look at our architecture, we have controller, view. We also need to create a model, right? For that, we'll create a student DTO class, and this student DTO class acts as a model. Alright, so typically we create a student DTO class to transfer data between controller layer and view layer. Alright, so let's go and let's create a student DTO class as a model class to transfer the data between controller layer and view layer. Well, we'll also create a student mapper class to convert student DTO object to student JPA entity object and student JPA entity object to student DTO object. Alright, so let's go to IntelliJ IDEA and let's go to DTO package, right click on it, new, and then choose Java class, and let's give class name as student DTO, and let's define instance variables for this class. So let's say private and then long ID and then private string first name. Alright, and then private string last name and then private string email. Alright, perfect. Now we have defined the instance variables for this student DTO class. Next, let's use Lombok connotations to reduce the boilerplate code. Let's use @getter lombo connotation to generate a getter methods for these instance variables. Next, let's use @setter lombo connotation to generate a setter methods for these instance variables. Next, let's use @noArgument constructor as well as @allArguments constructor. Okay, great. Now we have created student DTO class. Well, you might be wondering, we have already a student JP entity class. It contains the same fields. And why again we are creating student DTO class with same fields? Well, if you look at our Spring Boot Web MVC architecture, we need to have a student DTO class as a model class to transfer the data between controller layer and web layer. And we use student JP entity to store the data in a database. Okay, in real-time project, we keep a JP entities with respect to database and DTO class with respect to transferring the data between controller layer and web layer. Alright, so let's keep student JP entity with respect to the database and student DTO class as a model class to transfer the data between controller layer and web layer. Alright, so let's go back to our IntelliJ IDEA, and next let's create a student mapper class to map student DTO class to student JP entity and vice versa. So go to mapper package, right click on it, new, and then choose Java class, and let's give a class name as student mapper. Well, we basically use a mapper classes to keep a common logic. Well, in our Spring Boot project, we frequently convert student DTO to student JP entity and student JP entity to student DTO, right? So in student mapper class, we'll keep a mapping common logic, so that whenever there is a requirement to convert student DTO to student JP entity and vice versa, then we can simply use this student mapper class. Alright, so within a student mapper class, let's create a static method and let's give a return type as student DTO, and let's give method name as map to student DTO, and let's pass student JP entity as a parameter. Alright, perfect. Now let's have an instance of student DTO, and let's use constructor to pass the values to student DTO object. So here let's have student.getID, and then student.getFirstName, student.getLastName, and then student.getEmail. Okay, and then put the semicolon and then return student DTO object. Perfect. We have created a student DTO object and we have passed a ID, first name, last name, email from the student JP entity. Okay, next let's create one more static method, public static, and then let's have return type as a student JP entity, and let's give method name as map to student, and then pass student DTO object as a parameter. Perfect. So in this case, we need to create a student JP entity object and we need to return. So let's have a student JP object and then new student, and let's pass values in a constructor. So student DTO.getID, student DTO.getFirstName, student DTO.getLastName, and then student DTO.getEmail. Perfect. Next, let's return student JP entity object. Well, let me recap what we have done in this lecture. We have created student DTO class as a model class to transfer the data between controller layer and view layer. Next, we have created student mapper class to map student JP entity to student DTO and vice versa. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll implement a backend for list students feature. Well, if you look at our screenshot, we're going to basically develop a list students feature, something like this. We'll create a web page and then we'll display a list of students in a table. Alright, in this lecture, we'll create a backend for this list students feature, and in next lecture, we'll create a web page using ThimeLib template, and then we'll display a list of students in a table like this. Okay, and if you can notice here, the URL localhost :8080/students. Well, whenever user hit this link in the browser, then we have to create a handler method to handle this request, and then we need to return the view, right? So in this lecture, we'll create a handler method to handle this request, and in next lecture, we'll create a template HTML view which displays a list of students in a table like this. Alright, so let's head over to the IntelliJ IDEA and let's create a handler method. We'll go to controller. Let's first create a controller and let's call it as student controller. Alright, perfect. Let's annotate this student controller with add controller annotation from org.springframework.stereotype. Well, once we annotate this class with add controller annotation, then this controller becomes a Spring MVC controller and it is capable to handle HTTP request. Within this student controller, we are going to write a handler method to handle list students request. Alright. Well, before creating a handler method in a student controller, let's first create a service layer. Well, if you look at our Spring Boot web MVC architecture over here, a controller layer depends on service layer. Hence, let's first create a service layer and then we'll come back to developing controller layer. So let's go to IntelliJ IDEA and let's create a service layer for student. So go to service package over here, right click, new, and then choose Java class, select interface. Let's give interface name as student service. Within a student service interface, let's create a method and let's give method return type as list of type student DTO and let's give method name as get all students. Perfect. Now we have created a get all students method in a student service interface. Let's create a class. It implements student service interface. So go to service package, right click on it, new, and then choose package and let's give package name as IMPL. IMPL stands for implementation. Alright, so go to IMPL package, right click, new, and then choose Java class and let's give class name as student service IMPL. Alright, next we need to implement student service interface. So here let's type implements and then call student service interface and then go ahead and mouse over on this student service IMPL class. You will get option to implement the methods. So go ahead and click on this implement methods and just choose the methods that you want to implement and then go ahead and click on OK. Next, let's annotate this student service IMPL class with add service annotation from org.springframework.stereotype package. Well, whenever you create a service class in your Spring Boot project, make sure that you annotate this service class with add service annotation. Next, let's inject the dependency that is student repository. Just create a instance variable of student repository over here. And next, let's use a dependency injection to inject the student repository dependency. For that, let's create a constructor for this student repository field. Now we have injected student repository dependency in a student service IMPL class by using dependency injection approach. Well, here we don't have to use @add annotation. Well, typically we use @add annotation to inject the dependency, right? But whenever the Spring Bean has only one parameterized constructor, then we can omit adding this @add annotation because Spring 4.3 onwards, Spring will automatically inject the dependency whenever it will find a Spring Bean. It has only one parameterized constructor. Hence, we can omit using @add annotation. Perfect. Next, let's go ahead and let's implement get all students method. Well, here let's get a list of student DTO objects from the student repository. So here let me declare students object and then call student repository. It has a find all method and look at here, find all method returns a list of students, right? And this student is a JPA entity. Well, notice here get all students method returns a list of DTOs, but we have a list of student JPA entities, right? So now let's convert list of student JPA entities to list of student DTOs. Next, let's have a list of type student DTO and then let's call it as student DTOs and then let's call students. So this is the list, so we can call its stream method and then stream has a map, so let's call map method. And if you look at here, map method takes function as a functional interface and we can use a lambda expression to implement this function interface. Alright, so let's call map method over here, and then let's have a lambda expression. So let's pass a parameter, that is student. Well, student is basically JPA entity object, and then let's have a lambda symbol. And in order to convert student JPA entity to student DTO, we can use student mapper, right? So let's call a student mapper, and then it has a method that is map to student DTO, and then pass this student JPA object. Perfect. Finally, we need to collect the result. For that, let's call collect method, and then it has a collectors.toList method. So this will basically return a list of student DTO, right? So let's call this method. Okay, perfect. Now we have converted list of student JPA entities to list of student DTOs. Next, we need to simply return student DTOs. Perfect. Now we have implemented get all students method. It returns a list of student DTOs. Now we have implemented service layer for list students feature. Next, we need to develop the controller layer. So go to student controller, and within that we need to write a handler method. So before that, we need to inject the student service dependency. So here let's have a instance variable of student service. Well, notice here we are injecting student service interface as a dependency. We are not injecting class as a dependency. Well, Spring team suggests to inject interface as a dependency to maintain the loose coupling. That's why developers prefer to inject the dependency by using interface. Now we have created an instance variable of student service. Let's create a constructor. Right click generate and constructor, and select the variables, and then click on OK. Now we have created a constructor. It means we are basically injecting this student service dependency in a student controller class using constructor based dependency injection. Now let's go ahead and let's write the handler method. Let's type public and then string as the return type, and let's give method name as list students, and then let's annotate this method with @getMapping annotation, and let's pass the URL, that is /students. Well, here we are using @getMapping annotation to handle HTTP GET request with the URL /students. Alright, perfect. Now let's go and let's pass a model as a parameter to this method. So let's have a model, and make sure that you select model from org.springframework.ui package. Alright, perfect. Now within the model, basically we store a list of student object. For that, let's post retrieve a list of student object from the service layer. So let's have a list of type student DTO, and let's call it as students, and then call student service, and then it has a method that is get all students. Perfect. Now we got a list of students. Next, we need to store this list of students in a model. For that, let's have a model object, and then it has a add attribute method. Well, here we have multiple overloaded add attribute methods. For example, this first add attribute method takes 2 parameters. Second add attribute method takes 1 parameter. So we're going to use post one, that is this add attribute method. It takes 2 parameters. Okay, so just select this one and then pass post parameter as a students. So this is basically a key, and then value as a actual students object. And in a Thymlip HTML template, we use this key to refer to this students object. Okay, great. Once we store the data in a model, next we need to return the view. For that, let's have a return statement over here. Return and then students. Well, this students is HTML Thymlip template view. In next lecture, we'll create a students Thymlip template view, and we'll display a model data in a students Thymlip template. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll implement front end for list students feature. Well, in previous lecture, we have created a handler method to handle list students request. And this handler method retrieves a list of students object from the database, and then it will add a list of student objects to the model, and it returns a view. In this lecture, we'll create a students Thymlip template view, and we'll display this model data. Alright, at the end of this lecture, we'll be able to see this screen. Okay, so we are going to create a Thymlip HTML view, and we'll display a list of students in a table, something like this. Alright, so let's go ahead and let's implement front end for list students feature. So let's go to IntelliJ IDEA and let's go to templates folder. Well, by default, Spring Boot will find all the ThemeLib templates under templates folder. Hence, we need to create all the ThemeLib templates within this templates folder. Alright, so let's right click on this templates folder, new, and then choose HTML file, and let's give a students as a HTML file name. Well, look at here, we are returning the view that is students, right? So this students view is same as this students.html. Okay. Next, let's give a title as a student management system. Alright, and next we need to define a XML namespace for ThemeLib. Well, in order to use ThemeLib syntax in this HTML page, we have to provide XML namespace for ThemeLib. Okay, so let's type XML namespace, that is :th, and then http www.themelib.org. Okay, so in order to use ThemeLib syntax in this HTML page, we have to mention the XML namespace for this ThemeLib at the beginning of this HTML page. Next, let's use Bootstrap CSS framework to style our HTML elements. Well, I'm going to use Bootstrap 5. It is the latest version. Okay, so let's go ahead and let's get a Bootstrap CSS CDN link, and then we'll add that link in the header. We'll go to browser, and here let's type Bootstrap CSS CDN 5, something like this, and hit enter and click on this Bootstrap version 5. So this is the official documentation link, and just scroll down, and here you can see copy paste the style sheet into header. So this is basically a CDN link to use a Bootstrap CSS library. Okay, so you can also download this Bootstrap CSS from the official website, and you can add to the project, and you can provide the link in the HTML file. But to quickly set up the Bootstrap in our project, we can use CDN links. Okay, now let me copy this Bootstrap CSS CDN link. So you can click on this copy button to copy to clipboard, and let's go to IntelliJ IDEA and go to students.html file, and in header just below title paste it. Okay, let me quickly align this one. Perfect. Now we have added Bootstrap CSS CDN link to this HTML file. Next, we can use Bootstrap CSS classes to style the HTML elements. Okay, great. Next, we need to add a header to our HTML page. Well, if you look at our screenshot, we need to add a header something like this, and we need to add a project name in a header. Alright, and the header should be in a dark color. Okay, let's go to browser, and in a new tab just type Bootstrap CSS navbar 5 and hit enter, and go ahead and click on this post link, and then just scroll down, and here you can see this is the navbar standard template that Bootstrap provides. So we can use this navbar standard template to create a header in our project. So let's copy this navbar, and let's go to our project and go to the body. Within a body just paste it, and let's remove the unnecessary code. So here we have a navbar, so let's replace navbar with the project name, that is student management system, and just scroll down, and here we have a div. Within that we have an unordered list. Okay, within that we have a list. So let's keep this list, and let's remove other list elements. Alright, and after that we have form, so let's remove this form as well. Perfect. Now let's save the file, and let's stop the server, and let's run Spring Boot application again. Okay, let's go to browser, and in a new tab just type localhost :8080/students and hit enter, and there we go. We have added a header to our HTML page, but this header should be a dark, right? We have to add a black color as a background for this header. So let's go to navbar page again, and just scroll down, and let's find the Bootstrap CSS class to make header as a dark. Just scroll down, and look at here, this navbar is in a dark color, right? So if you look at its Bootstrap CSS class, here we have navbar dark, background dark. So let's copy these two Bootstrap CSS classes and let's go to our project and go to navbar over here, and here we are using light as a background color. So let's replace these two Bootstrap CSS classes with dark Bootstrap CSS classes. Okay, now let's save the file and stop the server and restart the Spring Boot application, and let's go back to browser and let's go to our application, refresh, and there we go. Now the header looks good, right? Next, let's go and let's design the table, and within a table we'll display list of student objects. After navbar, let's add some break elements to give some space between header and table. So let's add a couple of break HTML elements over here in order to give the spaces. Next, let's have a div, and then let's give a Bootstrap CSS class that is container. Well, Bootstrap basically provides three types of containers. One is container, another is container hyphen flood, and third is container hyphen custom. Instead of custom, we can specify the size for the container, for example 200 pixel, 500 pixel, something like that. But let's use a container, a Bootstrap CSS class for this page. Within a container, let's create a row. For that, let's have a div, and then let's use a Bootstrap CSS class that is row. Within a row, let's display the page heading. For that, let's use h1 tag, and then let's use page heading as list of students. Perfect. Next, we need to design the HTML table and we'll display list of students. So before that, let's have one break element to give a space between heading and table, and then let's have a HTML table. Alright, and let's use a standard Bootstrap CSS class to style this table element. So let's say table and then table hyphen stripped. Alright, and then table hyphen h word, and then let's also have a border for this table. For that, let's use table hyphen bordered. Perfect. So these are the standard Bootstrap CSS class we can use in order to style the table. Within a table, let's have a table header, and then within a table header, let's have a table row, and then within a table row, let's have a table columns. So let's say th, and let's give post column name as student first name, and similarly let's give second column name as student last name, and let's give third column name student email. Okay, next let's give fourth column name as actions. Perfect. Now we have created 4 columns for this table. Next, we need to display a data in the table. So here, after this closing table heading, let's have a table body, and then within a table body, let's have a table row. Well, within a table row, we basically iterate over a list of students and will display each student. So in time loop, in order to iterate or loop over a list of elements, we can use th colon each attribute. For example, here let's have a th colon each attribute, and then let's define the variable student, and then colon, and here we're going to use a variable expression that is dollar within a curly braces. Let's pass students. Okay, so here we are using th colon each attribute to iterate over a list of students, and this students object we are referring from a Spring MVC controller. Well, if you go to student controller, within student controller we have a handler method, right? And we have added students as a key and students object as a value, and we are using this students key to retrieve this students value. Okay, so basically we are using this students variable to retrieve the value in a th colon each attribute. Okay, and this is dollar within a curly braces we are passing this variable, and this dollar curly braces, so this is basically a variable expression. So we use a time-leap variable expression in order to refer to the variable. Next, we have a student object. Well, this student object is a local variable, and the scope of this variable is up to this tr element. We cannot access this student local variable outside this tr element. Okay, So in Java, we use for each loop to iterate over a list of elements, right? So similarly, Thymely provides th:(each attribute to iterate over a list of elements. And in this case, we are iterating over a list of students. Alright, it's pretty simple. And within this table row, let's have a table data. Alright, next, here we're going to use th:(text attribute to display the text. We need to use a variable expression in order to access the student model object attribute. For example, here student dot first name. Well, if you look at the student DTO class here, so this student DTO class is nothing but a model class. It has first name, last name, email attributes, right? So these attributes we are reapplying here. Okay, so this student is nothing but a model object. Okay, student DTO model object, and we are using its attribute over here in order to get the value. So this th:(text attribute, so this attribute will evaluate this expression and display the result. For example, let's say post name contains Ramesh, then this th:(text attribute will evaluate this expression and it will display Ramesh as a text. Similarly, let's go ahead and let's populate last name and email values. So let's have a table data, and then let's use th:(text attribute, and let's pass the expression using variable expression, and then student dot last name. Okay, so this th:(text attribute evaluate this expression and print the result. Next, populate student email ID data. So for that, let's have a td and then th:(text attribute, and then let's have a expression using variable expression student dot email. Now we have displayed student email as well. Okay, next we need to have one more table data element for action. Well, as of now, let's keep table data element body as an empty. In upcoming lectures, we'll add actions like edit, delete, view. As of now, let's keep this td element body as a empty. Okay, now let's go ahead and let's run the Spring Boot application and let's see how this table looks in a browser. So let me stop the server and let me start the Spring Boot application again. Alright, our Spring Boot application is up and running. Let's go to browser and let's refresh our Spring Boot application, and there we go. We got a list students page over here, but if you look at the table, there is no data present in this table, right? So we'll insert a couple of students record in a students database table a bit later. Let's first make this table heading in a dark color. So let's go to IntelliJ IDEA and let's go to table header element over here, and let's add a bootstrap CSS class that is table-dark. Okay, now let's stop and start the Spring Boot application, and let's go to browser and let's refresh, and there we go. Now the table heading looks good, right? Now let's head over to the database and let's insert a couple of records in a database table so that a data will be populated in this web page. So let's go to MySQL Workbench and go to our database, that is SMS, and go to students table, and here we have to manually insert the records. So let me quickly insert few records over here. Let's say ID 1 and email, let's say ramesh@gmail.com, and let's give post name as Ramesh, last name as Padtare. Alright, and let's insert one more record with ID 2, and let's give email as john@gmail.com, and let's give post name as John, second name as Sina. Alright, next let's insert one more record with ID 3, and then let's give email as sanjay@gmail.com, and let's give post name as Sanjay and last name as Jadhav. Perfect. Let's go and let's apply these changes. So click on this apply and then apply and then close. Okay, and then select star from sms.students, and there we go. Now we have 3 records in our students table. Next, head over to the browser and let's refresh our application, and there we go. You can able to see 3 students are populated in a list students table. It means that we have successfully implemented list students feature. In next couple of lectures, we'll implement create student feature. Alright, great. I will see you in next lecture. Hi everyone, welcome back. In previous couple of lectures, we have implemented list students feature. Now we need to implement create student feature. In this lecture, we will add a new student link in the header, and then we will create a handler method to handle new student request. Well, if you look at the screenshot over here, we are going to add a new student link in the header like this. And whenever user click on this new student link, then we'll create a handler method to handle this new student request. Okay, so let's go to IntelliJ IDEA and let's quickly add a link. So go to students.html file and here go to navbar, and then here we have home. So let's replace this home with new student. Alright, let's add a link to this anchor tag. Well, just replace this with the TimeLeap attribute. So in order to define a link for this anchor tag, we can use a TimeLeap expression, that is th:/href, and then we can use a link expression to define a link for this anchor tag. So here is syntax: @ within a curly braces, just pass the link. Let's have a link as students/new. Okay, now we have added new student link in the header. Once user click on this new student, then we need to create a handler method to handle this new student request, right? So let's create a handler method to handle new student request. Before that, let's run the Spring Boot application and let's see how this new student link looks in a header. So let's go to browser and let's refresh, and there we go. New student link is visible in a header. Now let's go and let's create a handler method to handle this new student request. So let's go to IntelliJ IDEA and let's go to student controller, and here we are going to write the handler method. So let me write the comment handler method to handle new student request. Perfect. So let's type public, and then return type of the method is string, and let's give method name as new student. Alright, and let's go and let's use @get mapping annotation to handle HTTP GET request with the URL /students/new. Well, if you can notice here, this URL we have provided in a link. For example, if you go to students.html file, here we have added this link, right? /students/new. So this link we are handling by using this handler method. Alright, perfect. Now go to our method and let's pass model object as a parameter. Next, we need to create a student model object here to store student form data. So in our case, the model object is student DTO, right? So let's have a student DTO object over here, new, and then student. Perfect. Next, let's add this student object to the model. So let's have a model, and then let's call its method, that is add attribute, and then pass student as a key, and then student DTO object as a value. Well, once we store a data in a model, next we need to return a view. For that, let's have a return statement, and then let's pass the view name, that is create student. Well, we haven't created create_student view yet. In next lecture, we'll create a create_student TimeLeap template HTML view, and then we'll design the HTML form to create a new student, and then we'll store that student form data in this student model object. Alright, great. In next lecture, let's create a create_student TimeLeap template HTML view. Alright, I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have added new student link in the header, and whenever user click on this new student link, then we need to create a handler method to handle new student request, right? So if you go to student controller, we have written a handler method to handle new student request in the previous lecture. In this lecture, we will create a create_student TimeLeap HTML view, and then we design create student form. So go to templates folder. Within that, let's create a HTML file and let's give name as create_student. Perfect. And next, go to students.html file and let's copy this header, and let's go back to create underscore student.html file and let's remove this header and let's paste it. Well, we need this bootstrap, CSS CDN link to style the HTML elements in this page as well. That's why we have added this header. Next, let's go back to students.html file. We need a navbar as well. So let's copy this navbar. Okay, and let's go back to create underscore student.html file and go to body. Within body, just paste it. Okay, perfect. So if you can notice here, th:/href. Well, this is basically a TimeLeap attribute, right? And in order to use TimeLeap syntax in this HTML page, we have to define an XML namespace for TimeLeap at the beginning of this web page, right? So go to HTML element, and here we need to define an XML namespace for TimeLeap. So just type XML namespace th and then http www.timeleap.org and just save it. And now you can see the TimeLeap attributes are available. Okay, so in order to use TimeLeap syntax in this HTML page, we have to add XML namespace at the beginning of this web page. Okay, great. Next, after navbar, we need to design the form. So here, let's add some of the break elements to give a space. So let me add a couple of break elements over here. Next, let's create a div, and then let's use bootstrap CSS class, that is container. Alright, perfect. Well, if you look at the screenshot over here, we'll design the HTML form something like this. And first we create a border by using card, and then we'll keep this form within this card. Okay, so let's go to div, that is container. Within that, let's create one more div, and let's give bootstrap CSS class as a card. Okay, and then let's create a card header. For that, let's create a div, and then let's give bootstrap CSS class, that is card hyphen header. Within a card header, let's use h2 header element, and then just pass create student as a heading. Next, we need to create a card body. For that, let's have a div, and then let's give a bootstrap CSS class, that is card hyphen body. Within a card body, let's create a form, and let's pass the attribute for this form. Let's have a method, that is http post method, and then next let's use a role for this form, that is form, and then next use th:/action TimeLeap attribute to define a action link for this form. So here let's use link expression to define a link for this action, that is @ within a curly braces, just pass the URL, that is students. Perfect. Next, let's use th:/object TimeLeap attribute to point to the model object that comes from the Spring MVC controller. Well, if you go to student controller, within that we have written this handler method in previous lecture, right? And we have added the student DTO object as a model to this model object using add attribute method. And if you look at here, first parameter is a student and second parameter is actual student DTO model object. And we need to refer this student DTO model object by using this variable, right? Hence, we need to pass this variable to the th:/object attribute. Okay, in order to refer, we can use variable expression and then pass student as a variable name. So th:/object attribute, it points to the model object that comes from the Spring MVC controller, in our case student controller. Okay, great. Next, within a form, let's go and let's create a form input page. For that, let's use a div here. Let's have a div, and then let's use bootstrap CSS class, that is form hyphen group, and then bottom margin 3. Within a div, let's create a label, and let's use bootstrap CSS class, that is form hyphen label, and then let's give label name as student first name. Okay, after label, we need to define the input field. For example, if you go to screenshot, we have a student first name as a label. Next, we have a input text field. So let's go ahead and let's define the input field over here. Input, and then close it, and then let's define the attributes for this input field. So let's have a Bootstrap CSS class post, that is form hyphen control. So this is the standard Bootstrap CSS class that we can use to style the input element. Next, let's use ID, and let's give ID as a first name, and then name first name. Alright, next let's give placeholder, and let's give placeholder as enter first name. Perfect. Next, let's go and let's use the type. So let's use type as a text. This is the text input field, right? Next, let's use th::field attribute to point to the model object attribute. Well, here in our case, the model object is student object, right? And this student object is basically come from the Spring MVC controller. In our case, student controller. So go to student controller, and here this student model object is nothing but student DTO class. And if you go inside student DTO class, we have first name, last name, email attributes. Alright, so we are using these attributes in a create student HTML file. Okay, so in order to access these model class attributes, we're gonna use th::field attribute, and then we simply use the selection expression over here. So here is the syntax. Start within a curly braces, just pass the attribute name, that is first name. Okay, so you can go to student DTO class, you can simply copy this attribute name, first name, and you can simply paste it over here, because this th::field attribute, it is referring to the student DTO class attribute, that is first name. Well, whenever user enter the data in this text field and submit the form, then that data will be stored in this first name attribute. Okay, next we need to define the input field for last name as well. So let me quickly copy this div and let me paste it over here, and let me change accordingly. So this is a student last name, and then ID should be last name, and then name equal to last name, and then placeholder enter last name, and then here we need to pass a field as a last name. Okay, if you go to student DTO, now we have created input field to hold the last name value. Next, we need to create an input field for email as well. So let's go back to create_html file, and let me copy this div and let me paste it over here, and let me change accordingly. So this is the student email ID. Alright, and next let's give ID as a email, and then name as a email, and then placeholder enter email address, and next give type as a email, and then here we need to pass field as a email attribute. Now we have created 3 input fields: student first name, student last name, and student email ID. Next, we need to create a button to submit the form. So go to this div. After this div, let's have a button over here. Alright, and let's give Bootstrap CSS class for this button hyphen primary. Alright, and let's use a type as a submit, as this is the form, so we need to provide a type as a submit. Next, let's give button name as submit. Alright, great. Now we have defined the button for this form. Next, let's go ahead and let's run our Spring Boot application, and let's see how this create student form looks in our application. So just stop the server and start the Spring Boot application again. Now let's go to browser and let's refresh our application and go ahead and click on new student, and there we go. Well, notice here create student form, it looks quite wider, so let's make it short and let's place in the middle. Well, let's use Bootstrap grid system provided CSS classes to align this form at a middle, and let's make it a little short. So let's go to IntelliJ IDEA and go to this div. It has a container CSS class, and here let's add a Bootstrap CSS class, that is row, and then let's use column mid size 8, and let's also add a offset mid 2. Okay, now let's save the file and let's stop the server and start the Spring Boot application, and let's head over to the Chrome browser and just refresh, and there we go. Now the form looks good, right? Well, notice here create student card header. So let's align this create student card header at a center by using Bootstrap CSS class. So let's go to IntelliJ IDEA and go to this card header, and here go to H2 and let's use Bootstrap CSS class, that is text hyphen center, and stop the server and start the server again, and let's go to browser and just refresh, and there we go. Now create student header looks good. In this lecture we have designed the student create form. In next lecture we'll create a handler method to handle this create student form submission request, and we'll store this form data into a database. Well, whenever user enter student first name, last name and email and submit the form, then we need to create a handler method to handle this form submission request, and we need to store this form data into a database, right? In next lecture we'll create a handler method to handle this form submission request, and we'll store this form data into a database. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we have created create_student theme HTML page, and we have designed the create student form. Well, if you look at our application, we have designed the create student form like this. Now we need to create a handler method to handle this create student form submission request. Well, whenever user enter student first name, last name, email ID and submit the form, we need to handle this form submission request, and we need to store this form data into a MySQL database, right? So let's go and let's create a handler method to handle this create student form submission request. So let's go to IntelliJ IDEA and go to student controller. Let me write the comment over here. Handler method to handle save student form submit request. Alright, so let's type public, and then let's give return type as a string, and then let's give method name as save student. Alright, let's annotate this method with add post mapping annotation to handle HTTP post request, and let's give URL /students. Well, if you go to create_student.html file, we have given a link to the form action, that is /students, right? So now we are writing handler method to handle this URL, right? If you go to our handler method, we are passing /students, right? And in the form action also we are using same URL. It means that whenever user enter the form data and submit the form, then this handler method will get called. And one more point is, if you go back to create_student.html file, here we are using student model object to store the form data, right? Now we need this student model object in a handler method as well. For that, let's have a student DTO, and this is a student. Alright, and in order to get a form model data, let's use add model attribute annotation and then pass the reference variable, that is student. Well, this student object we are referring from the HTML form from here. Okay, so whenever user enter the data into the form and submit the form, that data will be stored in this student object, right? And this student object we are referring using add model attribute. Next, within a save student method, let's call student service, and then let's call its method create student, and then let's pass student DTO object. Alright, and if you can notice here, this create student method is not created in a student service interface. So if you can just mouse over on this create student, you will get an option to create a create student method in a student service interface. So let's go and let's click on this link, and IntelliJ IDEA will automatically create student method in a student service interface. Now let's go and let's implement this method in a student service IMPL class. We'll go to student service IMPL class and just mouse over on this class, and here you have option to implement the methods. So go ahead and click on this implement methods and just select the method that you want to implement and click on OK. Now we got a create student method. So let's go and let's provide implementation for this create student method. Well, in order to save student data into a database table, we should have a student JP entity, right? But here you can see we have a student DTO object. So let's convert student DTO object to student JP entity. Well, here let's rename this variable as a student DTO, and let's have a student JP entity object over here, and let's use student mapper. It has a map to student method and just pass student DTO object. Now we have converted student DTO to student JP entity. Next, let's call student repository. It has a save method and just pass student JP entity object. Perfect. Now we have created a create student method. It will save a student data into a database table. Next, let's head over to the student controller, and you can see here now the create student method is available in student service. Next, we need to return the view. Well, whenever user enter the form data and submit the form, next we need to redirect that user to the list students page, right? So if you look at here, we have written a handler method to handle list students request, right? So let's redirect user to this page. Okay, so here let's write a redirect statement, redirect colon, and then the handler method URL, that is students. Well, notice here the flow. Here we have written redirect statement. Well, whenever user enter the form data and submit the form, then this handler method will get called, and then the form data will be stored in a database. Next, we are redirecting user to the list students page by using this redirect statement. Well, redirect colon / student. So this is the URL, and we have written a handler method to handle this URL over here. Okay, so whenever user enter the form data and submit the form, then this handler method will get called, and this handler method will save that form data into a database, and then it will redirect that user to the list students page by using this handler method. Okay, pretty simple. Now let's go ahead and let's run our Spring Boot application and let's see how this works. So let me stop the server and let me start the Spring Boot application again, and let's go to browser. Let's go to our application and just refresh, and then let's enter the create student form data. So let's enter student first name as Vikram, last name as Jadhav, and email ID as vikram@gmail.com, and go ahead and click on submit, and there we go. A Vikram student is added to the list of students page. It means that the create student feature is working as expected. So let's add one more student. Let's say Umesh, last name as Fadtare, and then email ID as umesh@gmail.com, and then go ahead and click on submit. Perfect. So look at here, Umesh student is added in the table, and if you go to database and go to students table, select rows, and look at here, there are 2 new entries. It means that create student feature is working as expected. Okay, and if you go to create student form again, and if you click on submit and look at here, a empty entry is added. Okay, it means that we haven't added any validation to this form. That's why a empty data is stored in a database. For example, if you go to MySQL Workbench and just select rows from students database table and look at here, a blank values are inserted in the columns. Well, it is not a good idea to allow users to add a blank or empty value in the form. Okay, so basically we need to add a validation to this form. In next lecture, we'll see how to add a validation to this create student form step by step. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous couple of lectures, we have implemented create student feature. In this lecture, we are going to add a validation to this create student form. Well, if you look at our screenshot, we need to add a validation to this create student form, something like this. We'll add a validation for first name as first name should not be empty, and we will add a validation for student last name as student last name should not be empty, and we will add a validation for student email address as student email should not be empty. Okay, so we're going to basically add a validation to this create student form, something like this. Alright, so it's pretty simple. Just follow the steps that I am going to implement in this lecture. Let's head over to the IntelliJ IDEA and let's add validation to create student form step by step. So first step is we need to add the validation dependency. We'll go to pom.xml and here we have already added Spring Boot Starter Validation Dependency. Well, Spring Boot Starter Validation Dependency provides all the required validation libraries to implement the validation in a Spring Boot application. Well, if you dive into Spring Boot Starter Validation Dependency, it internally provides all the libraries. For example, it internally provides Hibernate Validator Dependency. And Hibernate Validator Dependency basically implements, Jakarta Validation API dependency. Well, Jakarta Validation API, it is a standard API provided by Java EE, and Hibernate Validator is an implementation of Jakarta Validation API. And Spring Boot Starter Validation Dependency, it internally provides all these validation libraries to implement a validation in Spring Boot application. Okay, first step is you need to add this dependency in a pom.xml. In our case, we have already added Spring Boot Starter Validation Dependency while creating our Spring Boot application. Alright. Second step is we need to add a validation annotations to model class. Well, in our case, student DTO is a model class and we are using this student DTO class, model class in our Thymeleaf HTML templates, isn't it? Hence, we need to add validation annotations to this student DTO model class. So open student DTO model class over here and here let's add a validation annotations. Well, let's use @ not empty annotation from Jakarta validation constraints package. Okay, and we can also customize the validation message by using this message attribute of this not empty annotation. Let's pass the validation error message something like student first name should not be empty. Alright, similarly let's add validation annotation to last name as well. So let's use @not empty annotation and then let's use its message attribute to provide custom validation error message. Let's say student last name should not be empty. Perfect. Now let's add a validation annotation to email as well. So let's use @not empty annotation and just use message attribute and let's say student email should not be empty. Alright, and let's use one more annotation, that is @email annotation to validate the email. Perfect. Now we have added validation annotations to student DTO model class. So this is the second step. Well, third step is we need to enable validation for this student DTO model class in a handler method. So go to student controller and within a student controller we have written a handler method to handle save student form submit request. And here we need to add a @valid annotation from Jakarta.validation package to enable validation for this student DTO model class. Well, we have added validation annotations to student DTO class attributes, right? And we need to enable validation for these annotations by using @valid annotation. Alright, so this is the third step. Fourth step is we need to use binding result class from Spring Framework library to check form validation errors and return to the UI. So let's pass binding result class as a parameter over here. So just say binding result and make sure that you choose binding result from org.springframework.validation package. Alright, and let's also pass a model class object. Alright, perfect. Here let's add a if condition to validate the errors by using binding result class object. So just call result.hasErrors. Let's say if there are any errors while validating the form, then we need to simply add a model data to the model object. So in our case the model data is student DTO object. So let's call add attribute and then key is a student and value is a student DTO class object. Perfect. Next simply return to the same view, that is create underscore student. What we have done, we have added a if condition over here and we have used hasErrors method of binding result to check the any errors while submitting the form. And let's say if there are any error, then we simply add this student DTO object to the model and we return the same view, that is create underscore student. it has a form. Okay, so this is basically a 4th step. 5th step is we need to display the error message in a create student form. So go to create student.html file, and here we have an input field. Just below input field we need to display the error message. For example, if you look at the screenshot, just below input field we need to display this error message. In order to display this error message, let's use a paragraph element over here. So let's say paragraph element, and then let's use if condition to check whether there are any errors. Then only we need to display the error message, right? So here let's use a dollar within a curly braces. We have a fields object, inbuilt object provided by Spring MVC, and it has a method called has errors. So we are checking the errors for first name. Okay, and then we need to use the bootstrap CSS class, that is text-danger. Well, in order to display the error message in a red color, we can use text-danger class. Next we need to display the validation error message. So for that, let's use errors timely attribute, and then let's use a selection expression over here, and then pass the field name, that is post name. Alright, perfect. Now we have added validation error message to this first name input field. Similarly, let's add this validation error message to last name and email. So let's go to input field of last name, and right after that paste it over here, and let's change the field, in this case last name, and here also pass last name. Perfect. So let's copy this and go to email field. Right after this input field, just paste it over here and just change from last name to email, and here also pass email. Perfect. Now we have displayed error message for each form input field. Okay, so this is the 5th step. Alright, so these are the 5 steps that we have implemented to add the validation to this create student form. Now let's go ahead and let's run the Spring Boot application, and let's see how this validation works. So let me stop the Spring Boot application and let me start the Spring Boot application. Alright, and let's go to browser and let's refresh our application and go ahead and click on submit, and there we go. Our validations are successfully applied to create student form, and you can able to see the validation error message. Student first name should not be empty, last name should not be empty, email should not be empty. Alright, so let's go and let's fill up the data. For example, let's say Meena, first name as Meena, second name is Yadav, and email ID is meena@gmail.com, and go ahead and click on submit, and there we go. Meena student is added to the table. It means that we have successfully implemented validation for this create student form. Well, notice here, if user want to create a new student, then user can use this new student link, and user can navigate to this page, and user can create the student. Alright, let's say if user come to this page and user don't want to create a student, then user need to navigate to the list students page, right? So here we haven't provided any link to navigate user to the list students page. So let's go ahead and let's add a students link in the header, so that user can go ahead and click on it, and user can navigate to the list students page. So let's head over to the IntelliJ IDEA, and let's go to create underscore students page, and here go to navbar. We have a new student link in the header. Along with this link, let's also have a students link. So let me copy and paste it over here, and let me simply change this link name, and let's view students. Perfect. And here let's change the URL, that is /students. Perfect. Now let's go ahead and let's rerun our Spring Boot application, and let's see how this works. So let me stop the server and let me start the Spring Boot application, and let's go to browser and let's refresh our application, and there we go. We got a students link in the header. Now just click on the students link, and there we go. We are able to navigate to the list students page. Okay, so this completes create student feature end to end. Alright, in next lecture onwards, we'll implement update student feature step by step. Hi everyone, welcome back. In previous couple of lectures, we have completed create student feature. Alright, now we are going to implement update student feature. Well, in this lecture, we are going to implement backend for update student feature. Well, if you look at the screenshot over here, we are going to add a edit button in a actions column correspond to each student so that user can go ahead and click on edit button and user can edit the corresponding student. Alright, so basically we will add a edit button in actions column. Once user click on this edit button, then user will navigate to this edit student page, and from here user can edit the student. Okay, so in this lecture we will add a edit button in actions column and we'll create a handler method to handle this edit student request. In next lecture, we will design edit student form and we will populate the student data in the form so that user can able to edit the student. Okay, let's go ahead and let's add edit button in actions column and let's create handler method to handle edit student request. So let's head over to the IntelliJ IDEA and let's go to students.html file and go to table. Within table we have actions column and go to here table data, and here let's add a edit button. So let's use anchor tag and let's use bootstrap CSS classes to make this anchor tag as a button. So let's say button and then button primary. Perfect. Next, let's add a link to this anchor tag using thymlib attribute, that is th:/href, and then let's use link expression to define the link @ within a curly braces /students/student ID. Alright, and then /edit. Perfect. If you can notice here, we have student ID, right? We need to pass a student ID dynamically to this URL. So here is the syntax: open and close braces. Within that, let's have a student ID variable equal to, and you can notice here we have a student object. Okay, so we can get ID from the student object. So here let's have a variable expression and student.id. Perfect. Now this ID will be assigned to this student ID and this student ID will be dynamically replaced in the URL. Okay, perfect. Next, let's go ahead and let's give a name to the link, that is edit. Alright, great. Now let's run our Spring Boot application and let's see how this edit button looks in a actions column. So let me run the Spring Boot application. Alright, and let's go to browser and let's go to students page, and there we go. You can able to see edit button is successfully added in a actions column. Next, whenever user click on this edit button, we need to write a handler method to handle edit student request. For that, let's go and let's create a handler method to handle edit student request. So let's go to IntelliJ IDEA and let's go to student controller and scroll down and go at the bottom, and here let me write the comment handler method to handle edit student request. Perfect. Just type public and the return type is string, and let's give method name as edit student. Alright, and let's go ahead and let's annotate this method with @getMapping annotation to handle HTTP GET request, and let's pass the URL, that is /students/student ID and then /edit. Well, if you go to students.html file, here we have added edit link in the actions column, and if you notice the URL over here /students/student ID edit, the same URL we are using in a handler method because we are writing a handler method to handle edit student request, isn't it? Next, we need to get the student ID value in this method. For that, we can use @path variable annotation and then just pass student ID. Alright, we need to pass this student ID to this @path variable annotation over here. And then in order to get the value of this student ID, we need to have a ID of type long over here. So let's call it as student ID. Perfect. Next, let's pass a model object to this method. Perfect. Next, within a edit student, we need to get a student object. Let's have student DTO and let's call it as student, and then let's call student service, and then let's call its method get student by ID, and just pass student ID as a parameter. Well, if you look at here, get student by ID method is not created in a student service. So let's go ahead and let's create get student by ID method in a student service interface. So go ahead and click on this method. It will create get student by ID method in a student service interface. Alright, next we need to implement this method in a student service IMPL class. So go to student service IMPL class and just mouse over on this class, and here you can see the link implement methods. So go ahead and click on this link, and here you need to choose the methods that you want to implement, and go ahead and click on OK over here, and there we go. We got a get student by ID method. Next, let's implement this method over here. First of all, we need to get a student JP entity object from the database using this student ID. So let's have a student JP entity object over here, and then let's call student repository, and it has a method that is find by ID. And if you can notice here, find by ID method returns optional of type student. Alright, so just call find by ID method and then pass student ID, and then in order to get a student object from the optional class, we need to call get method. Now we have student JP entity object in place. Next, we need to convert this student JP entity object to student DTO object. So here what I will do, I will declare student DTO object over here, and then let's use student mapper. It has map to DTO, that is map to student DTO method, and then just pass student JP entity object. Perfect. Now we have converted student JP entity object to student DTO object. And finally, let's return this student DTO object. Perfect. Now we have implemented get student by ID method. It returns a student DTO object. Next, let's go back to student controller, and here you can notice here get student by ID method is now available to student service. Next, let's add this student DTO model object to the model. So let's call model, and it has a add attribute method, and then just pass student as a key and student DTO object as a value. Alright, perfect. Now once we add data to the model, next we need to return the view. So just have a return statement over here, and let's view name as edit underscore student. Perfect. Well, this edit underscore student is basically a view name, and we haven't created edit underscore student view yet. In next lecture, we are going to create edit underscore student TimeLip template HTML view. Well, let me recap what we have done in this lecture. We have added edit button in the actions column, and next we have created handler method to handle edit student request. Alright, in next lecture, we'll create edit underscore student TimeLip HTML view, and we'll design the edit student form, and we'll populate edit student form with the student data so that user can able to edit the student. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have implemented a backend for update student feature. In this lecture, we are going to implement front end for update student feature. Well, if you look at our code, in previous lecture, we have added edit button in actions column, and we have written handler method to handle edit student request. In this lecture, we'll create a edit underscore student TimeLip HTML template, and then we'll design edit student form, and we'll populate the student data in the form so that user can able to edit the student. So let's go to templates folder, and within the templates folder, let's create a HTML file, and let's give name as edit underscore student. Perfect. Well, if you look at the screenshot over here, the edit student page, it looks same as create student page. We'll go to our application and click on this new student, and you can see this create student page. If we can compare edit student page and create student page, both page look similar, isn't it? So the only difference is in edit student page, we need to populate the student data, and we need to change the header. Okay, so instead of writing the same code, we can simply copy the code from create student page, and we can paste it in a edit student page. So let me go to create underscore student.html file, and from here I will copy the entire code and go to edit_student.html file, and I'm going to simply paste it over here, and let me change accordingly. So here we need to change the header. Right now we have create student, so let's change from create student to edit student. And apart from that, we need to change the URL for this form. Well, in case of update student operation, we need to pass a student ID in the URL, right? So go to form action over here, and here just pass student ID in the URL within a curly braces student ID, and we need to pass student ID dynamically to this student ID, right? For that, here is the syntax: open and close braces, and then just get a student ID from this student model class object. So here let's have student ID, and then let's use a variable expression, and then student dot ID. Okay, so here we have student model object, and we can get ID from this student model object, and here we are assigning that ID to this student ID variable, and this value will be replaced with this student ID. And finally, let's close this action. Alright, perfect. Now let's go and let's run our Spring Boot application, and let's see how this edit student page looks in our application. So let me stop the server and let me start the Spring Boot application again. And there we go, our Spring Boot application is up and running. Let's go to browser and go to our application and just refresh and go to students page and go ahead and click on this edit button, and there we go. You can able to see edit student page looks good, and student data is also populated in the edit student form. Alright, next we need to create a handler method to handle this edit student form request. Okay, so whenever user edit the student data and submit the form, then we need to write a handler method to handle this edit student form submission request, and we need to store this edited student data into database. Alright, so let's go to IntelliJ IDEA and let's go to student controller and go at the bottom, and here let me write the comment handler method to handle edit student form submit request. Alright, perfect. Now let's type public, and then return type of the method is string, and let's give a method name as update student. Alright, and let's go and let's annotate this method with add post mapping annotation to handle HTTP post request. Well, if you go to edit student.html file, we have provided HTTP method as a post to the form, right? That's why we need to handle this HTTP post request by using at the rate post mapping annotation over here. Alright, next let's pass the URL, that is /students/student ID. Alright, so this is the URL that we have provided in a form by using this action. Okay, you can see /student/student ID. So this is the link we are handling by using this handler method. Next, we need to get the value from this student ID by using add path variable annotation over here. So just type add path variable annotation and just pass student ID and then long student ID. Next, we need to get student model object in this handler method. Well, if you go to edit_student.html file, here we have student model class object, right? And the edited student form data is stored in this student object. So let's get this student model object in a handler method. So here let's pass student DTO object. Okay, and let's use add model attribute annotation to get the student model object. Alright, perfect. Next, we're gonna also validate the edit student form. For that, let's use binding result class over here, and then next use a model object. Perfect. Now we need to also enable the validation for this student DTO class. For that, let's use add valid annotation. Next, within the update student method, let's have a if condition to check any form related validation errors. Let's have a if condition over here, and then a result dot has errors. Let's say if there are any errors while validating the form, then we can handle that validation here within this if condition. Okay, so let's add the student model object to the model object by using add attribute over here. Student as a first parameter and student DTO object as a second parameter, and then finally we need to return to the same view, that is edit underscore student. Perfect. So if there are any errors while validating the form, then we simply add that student object to the model and we simply return to the same view. Okay, next let's add student or ID to the student DTO. For that, let's use set ID method and then just pass student ID. Okay, next let's call student service and then let's call its method, that is update student, and then just pass student DTO object. Well, notice here this update student method is not created in a student service. So let's go and let's create a update student method. So just mouse over on this update student, and here we will get an option to create a method. So go ahead and click on this link and IntelliJ IDEA will create an update student method in a student service interface. Next, let's go and let's implement this method in a student service IMPL class. So go to student service IMPL class and just mouse over on this class, and here click on implement methods, and here you will get a update student method. Next, let's implement this method. So here let's simply call student repository and then let's call save method. But this save method expect entity, right? But we have a student DTO object. So let's use student mapper, and then it has map to student method and then pass student DTO. Okay, so basically here we have converted student DTO object to student JP entity and then we have passed to save method. Okay, so this will save this student information into the database. Alright, now we have implemented update student method. Now let's go back to student controller, and here you can see update student method is available in a student service interface. Next, we need to redirect to the list students page, right? So here let's have redirect statement, redirect colon and then students. Alright, so once user edit the student information and submit the form, then we need to redirect that user to the list students page. So here we have a handler method to handle list students request, right? So we are basically redirecting this request to this handler method. Okay, and this handler method will basically return a student's view. Alright, perfect. Now let's go and let's run our Spring Boot application and let's see how this update student feature works. Alright, so our Spring Boot application is up and running. Let's go to browser and let's refresh our application. Okay, and go ahead and just edit this Ramesh student. So go ahead and click on this edit button over here, and now I'm going to edit post name, let's say Ramesh123, last name let's say Patari123, and Ramesh123@gmail.com, and click on submit. And here we got a 404 error. It means we have done some mistake in a URL. So let me see what is the mistake in the URL. So if you go to edit_student.html page, the URL is /student/student ID, and if you go to handler method, here we have given the URL student, right? Let's make it as a students. Okay, now let's save the file and let's run the Spring Boot application and let's see how it works now. Let's go to browser and let's go to our application, refresh over here and go ahead and click on edit button. So let's edit this Ramesh student. So click on this edit button and let's edit the first name from Ramesh to Ramesh123, Patari to Patari123, and email ID Ramesh123@gmail.com, and go ahead and click on submit. And there we go. Student first name is edited, last name is also edited, and email ID as well. Alright, it means that the update student feature is working as expected. Let's update one more student. So let's update this Sanjay student. So let's click on this edit button and let's say Sanjay to Ram, and let's keep last name as Jadhav, and let's update the email ID ram@gmail.com and click on submit. And here you can see, alright, Sanjay student is successfully edited. And if you want to confirm at a database level, you can go to MySQL Workbench and go to students table, select rows, and you can see Ramesh student is edited and Sanjay student is edited. Alright, it means that the update student feature is working as expected. Alright, great. In next lecture, we'll implement delete student feature. Alright, I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll implement delete student feature step by step. Well, if you look at the screenshot over here, we'll basically add a delete button in the actions column, and whenever user click on this delete button, it will delete the corresponding student. Okay, so in this lecture, we'll add a delete button in actions column, and we'll create a handler method to handle delete student request. Okay, so let's go to IntelliJ IDEA and let's add a delete button in actions column, and let's also create a handler method to handle this delete student request. So let's go to IntelliJ IDEA and let's go to students.html file, and then let's go to actions column, and here we have already a edit button. So along with the edit button, let's also add a delete button. So let's have a anchor tag over here, and let's use bootstrap CSS class to make this anchor tag as a button. So let's have a button CSS class and then button danger. Well, in order to make button in a red color, let's use button danger CSS class, and then let's add a link to this anchor tag using th:/href thymlib attribute, and then in order to define the link, let's use link expression over here. The syntax is @ within a curly braces. Let's pass the URL, that is students/student ID and then /delete. Well, here we need to pass student ID dynamically into this URL. So here is the syntax: open and close braces and then student ID equal to, let's use variable expression to access model object attribute. Well, here we have a student variable or a student model object. We can get ID from the student model object. So let's pass student over here, and it has attribute ID. Okay, now this student ID is assigned to this student ID, and this student ID value will be replaced in this URL. Okay, so this is basically a placeholder for student ID, and this student ID will be dynamically replaced with this student ID. Okay, now let's give name to the button as a delete. Okay, next let's run the Spring Boot application and let's see how this delete button looks in our application. Alright, our Spring Boot application is up and running. Let's head over to the browser and let's refresh our Spring Boot application, and there we go. Delete button looks good in a actions column. Okay, now user can use this delete button to delete the corresponding student. Alright, now we need to write a handle method to handle this delete student request, and we need to delete the student from the database table. So let's go to IntelliJ IDEA and let's go to student controller, and here let's write the handler method to handle delete student request. So let me write the comment over here: handler method to handle delete student request. Perfect. Just type public and then return type the method is string, and let's give method name as delete student. Alright, and let's annotate this method with add get mapping annotation, and then let's pass the URL /students/student ID and then /delete. Well, if you look at the delete button that just we have created in a students.html file, if you notice the URL over here, we are using /student/student ID/delete, right? So this same URL we are handling in a student controller using handler method. Okay, perfect. Now we have student ID in the URL, so let's get a value of this student ID in a handler method using add path variable annotation, and just pass this student ID to add path variable annotation. So let me copy it and paste it over here, and let's store the value of student ID in a student ID variable. Next, we need to delete a student object from the database by using this student ID. For that, let's call here student service and then delete student and then pass student ID. Alright, and if you can notice here, this delete student method is not created in a student service. Well, if you can mouse over on this delete student method, you can see the option like create method delete student in student service. So go ahead and click on this link to create a delete student method in student service. Alright, so IntelliJ IDEA will basically create this method in a student service interface. Next, we need to implement this method in a student service IMPL class. So go ahead and open student service IMPL class over here and just mouse over on it, and here just click on implement methods and just choose the method that you want to implement and click on OK. Now we got a delete student method here. Let's go and let's implement this delete student method. Within a delete student method, just call student repository, and it has a method called delete by ID. Okay, just call delete by ID and then pass student ID. That's it. Now this delete student will delete the student by this ID. Okay, now let's go back to student controller. Now you can see delete student method is available in student service. Next, once user delete the student, next we need to redirect that student to the list students page. For that, let's have a redirect statement over here. Return redirect and then colon and then method handler URL, that is students. Well, if you go to handler method, here we have written a handler method to handle list students request, right? And we simply need to redirect this request to this handler method, and this handler method will return students view. Okay, perfect. Now let's go ahead and let's run the Spring Boot application and let's see how this delete student feature works. So let me stop the server and let me start the Spring Boot application. Alright, and let's go to browser and let's refresh and let me delete the Ramesh123 student. So let me click on this delete button and there we go. Ramesh123 student is deleted, and let me delete the John student and there we go. And let me delete this Meena1 student and there we go. It means that delete student feature is working as expected, and you can also confirm from the database. Well, go to MySQL Workbench and here just go to students table, select rows, and you can notice here there are only 3 students and the rest of the students just we have deleted. Alright, it means that delete student feature is working as expected. Okay, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have implemented delete student feature. In this lecture, we'll implement view student feature. Well, if you look at the screenshot over here, we'll add a view button in the actions column, and whenever user want to view this particular student, then user can go ahead and click on this view button to view this particular student. Okay, so in this lecture, we'll add a view button in the actions column, and we'll create a handler method to handle view student request. And in next lecture, we'll design view student page and we'll display this particular student information. Okay, let's head over to the IntelliJ IDEA and let's add a view button in actions column and let's create a handler method to handle view student request. So let's go to IntelliJ IDEA and go to students.html file and go to actions column over here, and then we have already edit and delete buttons. So along with these buttons, let's also add a view button. Let's have an anchor tag over here, and then let's use Bootstrap CSS class to make this link as a button hyphen-info, and let's use type attribute th:/href to define the link for this anchor tag. And in order to define the link, we're gonna use link expression @ within a curly braces. Let's pass the URL, that is students/student ID. Alright, and then /view. Well, we need to pass student ID dynamically to this URL. So let's use the syntax over here, open and close braces, and then student ID. Well, we can get a student ID from this student model object. In order to access student model object, we can use variable expression over here, and then student model object. It has a ID attribute. Okay, now we are assigning the value of this student ID to this student ID, and this student ID value will be replaced here. Okay, now let's add a name to this anchor tag, that is view. Okay, now let's stop the Spring Boot application and let's run the Spring Boot application and let's see how the view button looks in the actions column. So let's go to browser and let's refresh our application, and there we go. view button is visible in the actions column. Okay, now once user click on this view button, then we need to create handler method to handle this view student request. Alright, so let's go to IntelliJ IDEA and let's go to student controller and just go at the bottom, and here let me write the comment handler method to handle view student request. Perfect. Let's type public and then let's give string as the return type, and let's give a method name as view student. Alright, and let's go ahead and let's annotate this method with @getMapping annotation to handle HTTP GET request, and then let's give URL /students/student ID, and then /view. Now we need to get a student ID value in a handler method. For that, let's use @path variable annotation and just pass this student ID. Alright, and then wrong student ID. Okay, now we got a student ID. Next, we need to get a student object by this student ID. For that, first let's declare a student DTO object. Alright, and let's call student service. It has a get student by ID method and just pass student ID. Okay, so here basically we are calling get student by ID method to get a student by this ID. Now we got a student DTO object. Let's store this student DTO object in a model. For that, let's pass a model object as a method parameter, and then once we got a model object, let's add a student data to the model object. So let's call add attribute method and then pass post parameter as a student and second parameter as student DTO. Once we store student DTO object in a model, next we need to return the view. So here is the return statement, return, and then let's pass the view name, that is view student. Okay, so view student is basically a view name that we are going to create in the next lecture. Alright, so let me recap what we have done in this lecture. We have added view button in a actions column. Next, we have created handler method to handle view student request, and this handler method stores this student DTO object in a model and returns view underscore student view. In next lecture, we'll create a view underscore student TimeLeap HTML view and will display this model data. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have added view button in a actions column, and we have created a handler method to handle view student request. And this handler method stores student DTO model object in a model and returns view underscore student view. Okay, in this lecture, we'll create view underscore student TimeLeap HTML view and will display the model data. So let me copy this view name and let's go to templates folder and right click on it, new, and then choose HTML file, and let's give HTML file name as view underscore student. Okay, now let's design this view student page. So first of all, let's define the XML namespace for the TimeLeap. Well, in order to use TimeLeap syntax in this HTML page, we have to define XML namespace for TimeLeap at the beginning of this HTML page. So here just type XML namespace :th and then http and then www.timeleap.org. Okay, perfect. Next, we need to add bootstrap CDN link in the header. Well, here let me add the title, that is student management system. After title, we need to add a bootstrap CSS CDN link. Well, go to create student.html file. Here we have a bootstrap CSS CDN link. So let me copy it and go to view student page, and right after this title just paste it. Okay, now we have a bootstrap CSS CDN link in this HTML page. Next, we need to add a navbar, right? Let's go to create underscore student.html file, and here we have standard bootstrap navbar code. So let me copy it and go to view underscore student.html file, and within a body just paste it. Okay, now we have added header to our view student page. Next, we need to design the card. Within a card, we will display the student information. So here, after navbar, let's have a div. This is a main div, and we'll give Bootstrap CSS class as a container. Within a container div, let's have a row. For that, let's create a div and let's give Bootstrap CSS class as a row. Within a row, let's use Bootstrap grid, CSS classes to align the card at a center. So let's use div over here, and let's have a Bootstrap CSS class that is column mid 8, and let's have an offset. Basically, we need to align the card at a center. For that, we are using offset of size 2. Next, let's create a card. For that, let's have a div, and then let's use Bootstrap CSS class as a card. Okay. Next, within a card, let's define the card header. For that, let's have a div, and let's use Bootstrap CSS class as a card header. Perfect. And let's use h2 header tag over here in order to define the heading. So let's give heading something like student details. All right, and let's align this heading at a center. For that, let's use Bootstrap CSS class text hyphen center. All right, next, once we define the card header, next we need to define the card body. Let's have a div, and let's give Bootstrap CSS class as a card body. And within a card body, let's display student first name, student last name, and student email. Let's use a paragraph element, and then here let's have a student first name text, and then let's use a strong HTML element to display the student name. So within a strong element, let's use th:\text, and then let's use a variable expression to get the student model object attribute. So in this case, first name is a student model object attribute. Well, here we are using variable expression to point to the model object attribute. The attribute name is first name. Well, if you go to student controller, within a student controller we have written a handler method, and within this handler method we have student DTO model object, and this student DTO model object we have stored in a model, and we are accessing this student DTO model object by using this variable in a view student page. Okay, so this is the student variable that is coming from the student controller. Okay, and the student DTO is a model class, and if you go inside a student DTO model class, it has attribute first name, last name, email. So we are basically accessing these attributes, okay, in a view student page. Now we have displayed student first name by using this student.firstname model attribute. Similarly, let's display student last name and email. So let's have a paragraph, and then this is a student last name, and then let's use strong HTML element, and then within that let's use th:\text attribute, and then dollar. Within a curly braces, let's have a student model object, and then its attribute, that is last name. Perfect. So now let's also display the student email. Student email address. So let's have a strong HTML element, and then let's use th:\text attribute, and then dollar within a curly braces student dot email. Perfect. Now we have displayed student first name, last name, and email. All right, great. Now let's go ahead and let's run our Spring Boot application, and let's see how this view student page looks in our application. So let me stop the server and let me start the Spring Boot application. Alright, our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let's go to browser and just refresh our application. Next, go ahead and click on this view button to view this particular student. So let me click on this view button, and there we go. View student page, displayed successfully. But you can see here the card is slightly attached to the header. So let's add some space between this card and header. So let me go to IntelliJ IDEA, and let's go to here. So after the navbar, I'm going to add one break tag. So let me add one more break tag. Okay, now we have given some space. Now let's quickly run our Spring Boot application and let's see how view student page looks. Let me refresh and there we go. Now you can able to see view student page looks good. Okay, and here we have displayed student first name, last name and email as well. Well, this is a simple student management project and it has first name, last name, email. But in real-time project, the student class may have a lot of fields. Okay, now we are only displaying the first name, last name, email. But in real-time project, your student object or student class may have a lot of fields, right? So those fields you can display in this view student page. Okay, so this view student page is pretty useful whenever you want to display a student information. It is not there in this table. In real-time project, you may have a lot of fields in a student class, and in order to show all the student field information, you can use this view student feature. Okay, so this feature is pretty useful whenever you want to display all the student details in this separate page. Okay, now we have completed end-to-end view student feature. Alright, great. I will see you in the next lecture. Hey there everyone, Ramesh here, back again with another crash course titled React.js Crash Course. In this crash course, we will learn all the fundamentals of React.js. Well, you will learn what is React.js, the component, what is component types, JSX, functional components, class components, event handling, conditional statements, JSX, and states, props. Alright, so this crash course covers all the fundamentals of React.js, and most importantly, why want to use the latest version of React.js in this crash course. Alright, and end of this crash course, I am going to provide you the PDF notes of this crash course so that you can go ahead and refer it anytime. So this is the PDF notes of this crash course. You can use it for your reference, and I am going to provide the location of this PDF notes at the end of this video. And if you are new here, don't forget to subscribe and hit notification button. Never miss the updates. Alright, do support this video, give thumbs up so that this video will reach a larger audience. Alright, so without further ado, let's kickstart this crash course. Hi everyone, welcome back. In this lecture, let us take a look into Introduction to React.js. Well, what is React.js? React.js is an open source JavaScript library for building user interfaces. Well, here in this definition, you can notice two key points. First is JavaScript library and second is building user interfaces. Well, React is a JavaScript library. It is not a framework. It is a JavaScript library, and React, it does only one thing, that is building user interfaces. So React is not concerned with other things like routing or making REST API calls. Okay, so React, it does one important thing, that is building user interfaces. Okay, so you might be wondering how we can implement the routing and making a HTTP request in a React application, right? So React.js has a good support with third-party libraries. So we can use third-party libraries in a React application to achieve all this stuff. Like we can use React Router DOM library to implement the routing. We can use Axios HTTP library to make the REST API call or HTTP request in a React application. Okay, so just remember, React.js is an open source JavaScript library for building user interfaces. Next, React.js is created and maintained by Facebook. Next, React.js is a component-based architecture, and this architecture promotes reusability. The components are reusable building blocks that encapsulates the logic and UI elements of the application. They allow developers to break down the complex UI into smaller, manageable parts. Well, in React.js, the components are building blocks and reusable, and these components allow developers to break down a complex user interface into smaller, manageable parts. For example, consider we have user interface over here, and the component-based architecture basically allows the developers to break down the user interface into smaller, manageable parts. For example, we can break this user interface into small, manageable parts called components. For example, we can have a header component, we can have a footer component, we can have a side navbar, we can have a main content component, we can have a ads component. So React provides a component-based architecture, and this architecture allows the developers to break down the user interface into smaller and manageable parts, and these parts are called components. Okay, and again, component-based architecture promotes the reusability. For example, we can reuse the existing component as many times as we want. For example, here we have a side navbar component, and we can reuse this side navbar component as a left side navbar component or right side navbar component. So one more example is ads component. So we can use this ads component to display multiple ads. Next, let us take a look into React Virtual DOM. Well, React.js uses Virtual DOM as an abstraction of the real DOM to optimize and efficiently update the user interface. So if you look at the diagram over here, so before deep dive into the React Virtual DOM, first let us understand what is real DOM. Well, DOM stands for Document Object Model, and this DOM basically represents a tree structure of your UI application. For example, whenever you load your application in a browser, then browser will create a DOM for your UI application. For example, let us say your UI has a HTML code, div, within a div, S3 element, and then form, and then spam, within a spam you display the time. Okay, so DOM basically represents a tree structure of your HTML. Now we understood what is DOM and how this DOM looks in a browser. Next, let us understand what is React Virtual DOM. Well, React creates a virtual copy of the real DOM, and it is called a virtual DOM. Okay, so in order to improve the performance of the application, React creates a virtual DOM to update only the necessary part of the DOM. Alright, now let us understand how the React Virtual DOM works. Well, initially React will create the virtual DOM. It is the virtual copy of the real DOM, the real DOM which is present in a browser. Okay, next let us say if we change something in the React application. For example, let us say we change the time, then what React will do, it will create one more virtual DOM, and this is what the updated virtual DOM. Okay, next React will compare both virtual DOMs. Okay, so React will basically compare initial virtual DOM and updated virtual DOM, and it will identify the changes. If you look at the next diagram, React compares the initial virtual DOM and updated virtual DOM, and it will identify the node that gets changed. For example, in this case the time node changed. Okay, so basically in a DOM each element represents a node. Alright, and React compares both the virtual DOMs, and it will identify the node that gets changed. So once React identified the node that gets changed, next React will update that change in an actual DOM. And if you look at here, only the node whose data changes get repainted in the actual DOM. Alright, so this is how the React Virtual DOM works. So basically React don't change the actual DOM in the browser. It maintains the virtual copy of the actual DOM, and it will identify only the necessary changes, and then it will update the actual DOM. So this will improve the performance of the application. Okay, so here are some of the React real world examples. React.js is used by numerous organizations, and it is a foundation of many popular applications and websites including Facebook, Instagram, WhatsApp, Netflix. Alright, so this is a quick introduction to React.js. In next lecture, we will create and set up React application, and we will start learning React.js fundamentals. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to create and set up our first React application. Well, in order to create and set up React application, we are going to use build tools. Well, there are two popular build tools out there to create and set up the React application, such as Create React App and Vite.js. Well, in Java, we use the build tools like Maven or Gradle to create and set up the Java projects, right? Similarly, in order to create and set up the React application, we can use the build tools like Create React App or Vite.js. Well, let us first take a look into Create React App. Well, Create React App is an official supported way to create a single page React applications. It offers a modern build setup with no configuration. Create React App is a built-on Webpack and Bubble, and it is a popular tool that enables developers to quickly set up the React application. Well, Create React App provides a pre-configured environment so that developers can focus on the coding part, not on the build setup and the configuration. Alright, and Create React App is especially useful for beginners to get started. Next, let us take a look into Vite.js. Well, Vite is a newer build tool that has gained popularity in recent years. It was created to address the limitations of existing build tools, particularly in the development phase. Well, Vite.js is built on top of Rollup Bundler, which is known for its faster build times. Vite also provides a development server that is optimized for performance. Well, nowadays React developers prefer using Vite.js as a build tool to create and set up the React applications because Vite provides a faster build times. It means we can use Vite.js to bundle or build the React application very faster. Vite also provides the development server that is optimized for the performance. It means if you change something in the React application, then development server will immediately pick up that change and it will update the DOM in a HTML. Alright, so Vite you can use to improve the development experience. Okay. Now the question is, which build tool we have to use to create and set up the React application? Well, both Create React App and Vite are excellent build tools that provide the developers with a solid foundation for building React applications. Create React App is a reliable choice for beginners to learn, while Vite is a better choice for real-world projects that require faster build times. Ultimately, the choice between two will depend on the project's requirements and the developer's preferences. Well, in this course, I am going to show you how to create and set up the React applications using both Create React App and Vite.js. So we'll begin with using Create React App tool to create and set up the React application, and in upcoming sections we'll also see how to use Vite.js to create and set up the React applications. Now let us go ahead and let us use Create React App build tool to create and set up the React application. Well, in order to create the React application, you need to install Node.js and npm. Well, if you just type Node.js in the browser and go to download page, and from here you can go ahead and download the Node.js as per your operating system, and you can install in your operating system. Next, you don't have to install the npm separately. Whenever you will install the Node.js, npm will also get installed. Okay. Next, you need a text editor. Well, in this course we are going to use Visual Studio Code IDE to build the React applications. Well, you can just type Visual Studio Code in a browser and click on the first link and click on download link over here. So from here you can go ahead and download the Visual Studio Code IDE as per your operating system, and then you can go ahead and install it. Okay, so make sure that before creating the React applications you have to install Node.js and Visual Studio Code IDE in your machine. Alright, great. Next, let us go ahead and let's create the React application using Create React App tool. Well, first of all, let's create the workspace. For example, here in my file system, I have created React workspace as a folder. Within this folder, we are going to create the React applications. Alright, next, let us open the Visual Studio Code IDE. Well, I have already installed the Visual Studio Code IDE, so here let me open it. Next, let me maximize this and go to file menu, click on open folder over here, and then go to the folder. So in my case I have created React workspace as a folder, so let me select it, click on open. Alright, perfect. Next, we are going to create the React application in this React workspace folder. So in order to create the React application, we are going to use the commands. Well, if you go to browser and in a new tab, just type Create React App, hit enter, click on the first link and click on get started over here, and you can see, so these are the couple of commands that we can use to quickly create and set up the React application using Create React App build tool. Alright, so let us execute these commands. So in order to execute these commands, we have to use the terminal, right? So let's go back to Visual Studio Code IDE here, and here we are going to use inbuilt Visual Studio Code IDE terminal. For example, go to terminal, click on new terminal, and here let us execute the command. So if you go back to browser, the command npx create react app followed by the application name. Next, let's go back to VS Code and go to terminal, and here just type the command npx followed by create react app followed by the application name. So let us give application name as React basics. Next hit enter. So this will take a couple of seconds to create and set up the React application. So let us wait a couple of seconds, and you can see the statement creating a new React app in this folder. Alright, perfect. And there we go. The React application is successfully created with the name React Basics. Well, if you go to React Workspace folder, within that React Basics is the React application name. Next, in order to run the React application, we can use the command npm start. And in order to build the React application for production, you can use the command npm run build. In order to execute the test, you can use the command npm test. In order to eject the React application, you can use npm run eject. Next, let us type these two commands to start the React application. Right now we are in a React workspace, so let us move into our React application. So here let me clear the terminal and just type the command cd react basics, next npm start, and then hit enter. And there we go. Our React application is up and running in a development server on port 3000. Next, let's go to browser. In a new tab, just type localhost 3000, and there we go. Our React application is up and running. Next, let's go back to VS Code and go to our project and go to app.js, and here let us remove all this code, and here just type h1 element and then type hello world and just save this file, and let's go back to browser, and you can see hello world is displayed in the browser. Okay, so in next lecture what we'll do, we'll understand the important files and folders of this React application. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we have created and set up the React application. In this lecture we are going to understand React application project structure. Well, if you go to VS Code and go to our React application over here, so here let us take a look into the important files and folders of our React application. Well, let us begin with package.json file. So basically package.json file contains all the dependencies and scripts required for our React application. For example, if you go to dependency section, here you can see the dependencies like React, React DOM, and in this course we are using React 18+. Alright, next here we have script section. So this script section contains all the scripts that are required to start the React application, to build the React application, to test the React application, and to eject the React application. Alright, so just remember, package.json file contains all the dependencies and scripts required for our React application. And whenever we run npm install command, then npm will refer this dependency section and it will install all these dependencies in a node_modules folder. Next we have public folder. Within the public folder we keep all the files that are accessible publicly, and within the public folder you can see the important file, that is index.html. Well, we basically create the single page React applications, right? And in single page React application we can find only one HTML file named index.html. And if you look at the index.html code over here, and especially if you look at the body contains a div with ID root. So this div is responsible to render the React component. Alright, so this div is responsible to render the React root component. And most of the time we don't change this index.html file content. We may change this header section to include the scripts and CSS files, but we don't touch the body section. Okay, so the body should contain a single div, and this div is responsible to render the React component. Next we have src folder. Within src folder all the development related stuff goes, and within src folder we have app.js file. So this app.js file contains a root component named app component. Next we have index.js file. So this index.js file is a main entry point for our React application, and if you look at the source code of this file, react DOM.create root, and then document.getElementById, and then ID root. Well, this create root method will get the div by using the ID root. Well, if you go to index.html file, it contains a div with ID root. Alright, and if you go back to again index.js, so here this react DOM.createRoot method will get the div by using this ID, that is root. Okay, and then it will render app component within that div. For example, let me repeat again. If you go to index.html file, it contains the body and body has a div with ID root. Next, this react DOM.createRoot method will get the div from this index.html by using its root ID, and then it will render this app component within that div. Okay, next we have app.css and index.css files. So these files basically contains all the CSS related stuff. Okay, so these are the important files and folders in our React application. Now let us understand the flow in our React application. Well, whenever we access the React application from the browser, then this index.html file will get served in the browser. Next, the index.js file will load into the browser. Well, if you go to src folder, go to index.js. So index.js is a main entry point for our React application, right? So once the index.html file will load into the browser, then immediately this index.js file will also load into the browser, and then this piece of code will execute. Well, if you look at the code over here, react DOM.createRoot. So this method will get the div from the index.html file by using the ID root. Next, it will render this app component within the div. Well, if you go to app component contains this HTML code. Well, don't bother about this HTML code right now. So this is basically called a JSX. We'll understand what is JSX and how we can write the JSX code in upcoming lectures. So just as of now understand, this is the app component and it returns some HTML code, and you can see the HTML code h1 hello world. So this will basically print the heading in the web page. For example, if you go to browser, and you can see hello world is displayed in the browser. Okay, and next, if you can inspect this web page, go to console. So here you can see download the React DevTools for a better development experience. Just go ahead and click on this link, and let us add this React Developer Tools extension in the Chrome browser. So next, so here I am using Chrome browser, so I am going to install this extension in a Chrome browser. But if you are using Firefox or Edge, then accordingly you can add the extension. So here just click on install for Chrome, and next click on this add to Chrome button, and then click on this add extension. Alright, perfect. Next, go to this extensions, and here you can see React Developer Tools extension is added. Alright, great. Next, let's go back to our project, and here let us inspect this page again and then refresh, and here you can see the new tab named components. So just click on this components tab. So under this tab you can see all the React components. As of now there is only one component named app component, right? And just click on this app component, and here you can see the details. So this app component is used in a source file named index.js. Next, this app component will be rendered by this method. Okay, so basically you can see all the component related information over here. Alright, so this React Developer Tools extension is pretty useful to track the components and the component tree. Okay, great. Well, notice here by looking into this components tab, we can clearly understand the React application flow. Well, whenever we access the React application using browser, then the index.html file will get served, and then this index.js file will get loaded, and this index.js file is a source for this app component. Okay, so just remember, whenever we access the React application from the browser, then the index.html file will get first served in the browser, and then index.js file will get loaded in the browser, and then this index.js file will render the app component. Okay, so this is how the flow goes in a React application. So let me summarize what we have understood in this lecture. We pretty much understood the important files and folders in the React application, and we have also installed React Developer Tools extension in a Chrome browser, and we have also understood the flow in the React application. Alright, great. In next lecture we'll take a look into the components. Well, the components are the building blocks in a React application, so you have to understand the components in order to build the React applications. Alright, so in next lecture we'll take a look into React components. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In next couple of lectures we'll take a look into what are the components in React and different types of components in React. Well, what is a component? A component is an independent, reusable code block which divides the user interface into smaller pieces. Well, let us understand with an example. Well, consider we have a user interface and we can divide this user interface into smaller components. For example, header component, footer component, side navbar component, main content component, and ads component. Alright, and finally these components will come together to create a complete user interface. And notice here I have mentioned component is a reusable. Reusable means we can use the existing component as many as times we want in a React application. For example, here we have side navbar component and we can reuse this side navbar component as a left side navbar or right side navbar. We just have to change the information and properties. The rest of the code remains same in a component. Alright. Next, the components can be nested inside other components. For example, here we have app component as a root component, and this app component is nested the other components like header component, footer component, side navbar component, and so on and so forth. Alright, so just remember components can nested other components as well. Next, in React there are two types of components, functional components and class components. In next lecture we'll take a look into what is functional component. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to take a look into functional components. Well, in React there are two types of components, functional components and React components. In this lecture we'll take a look into functional components, and in next lecture we'll take a look into class components. A functional component is basically a JavaScript function or ES6 arrow function that returns a React element. Well, here React element is nothing but a JSX code. Well, we'll understand what is JSX and how to write a JSX code in upcoming lectures. So just try to understand React element is nothing but a JSX code, and JSX allows us to write HTML code inside a JavaScript code. Next, functional components always starts with a capital letter. So this is the important naming convention. Whenever you create a functional component, make sure that the functional component should start with capital letter. Next, functional component takes props as a parameter if necessary. Well, this props is optional. If you want to pass the data from one component to another component, then we can use these props. Alright. Next, let us go ahead and let us understand about this functional component with examples. So here let's head over to the VS Code, and here go to SRC folder. Within that, let's create a new folder and let's call it as components. Next, within a components folder, let's create a new file and let's give name as welcome.js. Well, you can give the extension for this file as a JS or JSX. Well, some of the developers prefer using JS as extension and some of the developers prefer using JSX as a file extension. Well, you can use either one because React supports both, right? So here in our case, let us use JS as an extension. But in upcoming React projects, we are going to use JSX as an extension as well. Alright, hit enter. Now we have created welcome.js file. Next, within a welcome.js file, let's create a functional component named welcome. So here, look at here the syntax, function. Well, as I mentioned earlier, functional component is nothing but a JavaScript function or ES6 arrow function that returns a JSX. Okay, so here let's create a function and followed by the name welcome. And notice here again, as per the naming convention, the functional component should start with a capital letter, and I have given the capital letter W. Okay, so as this is a function, so here let us have open close braces and open close curly braces. Next, this function returns a JSX code. Well, JSX is nothing but a JavaScript extension that allows us to write a HTML code within a JavaScript code. Well, this is the JavaScript function, right? So within a JavaScript function, we can write the HTML code like this. Let us say we want to print the heading welcome Ramesh. Okay, so this is the JSX code. Well, JSX is nothing but a JavaScript extension that allows us to write HTML code within a JavaScript code. So in next upcoming lectures, we'll understand more about JSX. As of now, just understand JSX is nothing but a JavaScript extension that allows us to write HTML code within a JavaScript code. Okay, perfect. Now we have created simple functional component named welcome component. Next, in order to use this component in other components, we have to export this component. For example, here just type export default and then component name welcome. Well, just remember, in order to use this functional component in other components, we have to export this component first, like this. Okay, next let's go to app.js file and let us import this component. So go to app.js, go to app root component, go to div, and here let us remove this h1 element, and here let us use welcome component. So here just type welcome and make sure that this welcome component is imported at the top, and let us close this welcome component over here. Alright, so this is how we use the component inside other component. And notice here the important point, we have exported this welcome component using export keyword, and we have imported this welcome component in an app component using import keyword. Alright, so this is basically ES6 module feature. We can export the component using export keyword, and we can import the component using import keyword. Alright, great. Next, let us save this file and let's go back to browser, and here you can see welcome Ramesh. Alright, so this is how we can create the functional component and we can use in other components. And again, I have mentioned like component is a reusable. Reusable means we can use this component as many times as we want. For example, if you go to app component, and here we can reuse this component many times. For example, here let me use one more time and just save this file and go back to browser. You can see welcome Ramesh. Okay, so this is how the component is reusable in a React application. Alright, perfect. Next, let's go to welcome.js file. So, and if you go to presentation, a functional component is basically a JavaScript function or ES6 arrow function. Well, here we have created this functional component using JavaScript function, but we can also create this functional component using ES6 arrow function. So let us go ahead and let us rewrite this functional component using ES6 arrow function. So here, let me copy this and let me paste it over here, and let me comment out this. So here let me show you how we can convert the JavaScript function into arrow function. So in case of arrow function, the function keyword is not required, and in case of arrow function, we should have a variable const welcome and then flat arrow symbol. So this is the arrow function. Okay, next, if the arrow function contains a single statement, then we can remove the open and close curly braces and also the return keyword. For example, let us simplify this. Just remove this open and return keyword and also the close curly braces. Alright, so this is the functional component using arrow function. Alright, next let us save this file and let's go back to browser, and you can see welcome Ramesh. If you refresh, you can see the same output, welcome Ramesh. Alright, so this is how we can use the JavaScript ES6 arrow function to create the functional component. Alright, so functional component is a JavaScript function or ES6 arrow function that returns a JSX. JSX is nothing but a JavaScript extension that allows us to write HTML code within a JavaScript code. Next, in order to use this component, we have to first export it using export keyword. Next, we have to import this component using import keyword, and then we can use in the other components like this. Next, functional component takes props as a parameter if necessary. Well, here we can use props to transfer the data from one component to another component, especially from parent component to child component. For example, Here we have app component as a parent component and welcome as a child component. And here let us say we want to transfer the data from app component to welcome component. Then we can use props. So props stands for properties, and we can pass the properties from parent component to child component. For example, here go to welcome and here just type name and then give name as Ramesh. Okay, next we want to get this Ramesh in a welcome component. So go to welcome component, and in order to get the Ramesh in a welcome component, we have to use props. So here we can pass props as a parameter to this functional component. And next, in order to access these props, we can use open close curly braces. So here just remove this Ramesh and let's have open close curly braces and then type props and then name. Okay, so this is how we can use props to transfer the data from parent component to child component. Next, let's go back to app.js, go to app component. Next, here also let us use the name and let us pass the name. For example, let's say Umesh. Okay, so this is how we can use the props to dynamically pass the data from one component to another component, especially from parent component to child component. Okay, next let us save this file. Let's go back to browser, and here you can see welcome Ramesh, welcome Umesh. So here we are passing the data dynamically to the component. For this first welcome component, we are passing name as Ramesh. For this second welcome component, we are passing name as Umesh, and in a welcome component we are getting that name using props. Okay, so this is all about functional components. In next upcoming lectures, we'll understand more about props, like how we can pass the object or array and how we can get that object and array using props. We'll understand more about props in upcoming lectures. Alright, great. In next lecture, we'll take a look into class components. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have understood how to create a functional components in a React application. In this lecture, let us understand how to create class components in a React application. Well, class components are ES6 classes that return the JSX. Class components extend the component class from React library. In case of naming convention, class components always starts with a capital letter. Class component takes props if needed. Class component must have a render method for returning the JSX. Well, let us go and let us understand all these points with an example. Alright, so as per these points, let's create the class component. So let us head over to VS Code IDE over here, and look at here. I am using VS Code and browser simultaneously in the same window, so that whatever the changes I do in the React application, that will be reflected in the browser right here. Okay, so this is the good way to teach. So here I am using browser and Windows simultaneously in the same window. So in order to understand the class components, let's create a new file. So here go to src folder, go to components folder, and within that let's create a new file. Let's call it as greeting.js. Next, let me maximize this. Next, within a greeting.js file, let us create a class component. Well, as I mentioned, class components are ES6 classes that return the JSX. So here just type class and then followed by the component name greeting, and in case of naming convention, the class component should start with the capital letter, right? So you can see the G is capital over here. Next, the class component should extend the component class from the React library. So here let us have extend keyword and then React dot component, and make sure that this React should be imported from the React library. So in order to import that, let us have an import statement, import React from React library. Alright, perfect. Next, this class component should have a render method to return the JSX. So here let us have a render method, and within a render method we can have a return statement, and then we can have a JSX code. For example, here let us have h1 element, and then let us say welcome Ramesh. Okay, perfect. Now we have created a class component. Next, in order to use this class component in other components, we have to export this class component. So here export default and then component name, that is greeting. Perfect. Next, let us use this greeting component in an app component. So go to app.js file, and here let me comment out this welcome component, and here let us use greeting component. So here greeting, and make sure that greeting component is imported at the top. Alright, perfect. Next, save this file and look at here the changes in the browser. Welcome Ramesh. And if you go to the greeting component, you can see welcome Ramesh. So this is the heading displayed in a browser. Next, if I change from Ramesh to Umesh and save the file, and you can see the changes in the browser, welcome Umesh. It means we have successfully created the class component. Okay, so look at here the syntax again. Class components are ES6 classes, and class component should extend a component class from a React library, and the class component should have a render method to return the JSX code. Alright, and in order to use the greeting class component in other components, we have to export it using export keyword, and in order to import these greeting components in other component, we have to use import keyword. Next, this greeting component is reusable, so we can use this greeting component as many as times we want in the React application. For example, here let me use greeting component one more time, and you can see the changes. Welcome Umesh. Okay, next we can use props to transfer the data from parent component to child component. So in our case, app component is a parent component, greeting component is a child component, isn't it? So from app component we can pass the data to the greeting component, and we can access that data by using props. For example, here let us use name property and then pass the data, let us say Ramesh, and for this greeting component also let us use name property and then let us use name Umesh. Perfect. Next, in order to access this information, we can use props, right? So let us go back to greeting component over here, and here we are using class component, so the props will automatically available in this class component. We don't have to pass props to this render method. Okay, so here let us remove this Umesh and let us get the data dynamically by using props. And in order to access the props, we have to use open close curly braces and then this dot props. So look at here, in a class component, props will automatically available. We don't have to pass props to the render method. So just access this props and then the property name. So notice here we are using this name property in an app component to assign the data, and we are using the same property to retrieve the data from the props. Okay, so this is how we can use props to transfer the data from one component to another component, especially from parent component to child component. Next, let us quickly summarize the component types. We create a functional component using JavaScript or ES6 arrow function that returns a React element. For example, here we have welcome functional component that we have created using JavaScript function, and this welcome component returns a JSX code. Next, we can also create a functional component using ES6 arrow function like this. For example, here we have welcome functional component that is created using ES6 arrow function. And on the other hand, here we have a class component that is created using ES6 class, and whenever we create a class component, that component should extend the class component from React, and this class component should use a render method to return the JSX code. Okay, so this is how the difference between functional component and class component. Next, you may have a question like which component type is recommended to use. Well, React team recommend to use functional components to build the user interfaces, and most of the React developers prefer using ES6 arrow functions to create the functional components. Well, in this course also we are going to follow the same. We are going to use functional components to build the user interfaces. Alright, so whenever you work on React projects, make sure that you use functional components to build the user interfaces and try to use ES6 arrow functions to create the functional components. Alright, great. In next lecture, we will see how to import and export components in a React application. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into how to import and export the components in a React application. Well, here are the important points. We can export the component using export keyword, and we can import the component using import keyword. And there are two types of exports, named export and default export. We can have multiple named exports in a single file. We can have only one default export per file. We can import named export using curly braces, and we can import default export without curly braces. So let us understand these points with an example. So let us go to our VS Code IDE over here, and in order to understand importing exporting components, let's create a new file. So go to components folder, right click, new file. Let us give file name as my component.js. Within a myComponent.js file, let's create a functional component. So here just type function and let us give component name as first component. And then here let us have a return statement and then return the heading first component. Okay, and just save it. Next, in order to use this first component in other component, we have to export this first component, right? So here, let us have export. So this export is basically called a named export, okay? And if we export something like this, export default post component, so this is called a default export. Okay, if we use export default keyword, then this is called a default export, and the earlier one, that is this one, is called the named export. Okay, and within a single JS file we can have multiple named exports. For example, here let me create one more component. So let me copy this, paste it over here, and let us give name as second component and just change the content second component. Alright, just remember, within a single JavaScript file we can create a multiple functional components and we can export them using named export. But if you want to export the functional component as a default export, then you should have a single component in a single JavaScript file. Okay, for example, if you want to export this first component as a default export, then you should have only one component per file. Okay, and you should remove this named export and you should give a default export like this, export default and then the component name. Alright, just remember, if you want to export a component as a default export, then you should have only one default export component in a single file like this. Okay, perfect. Next, let us see how to import the named export and default export. So here let me undo it and let me first show you how to import the named export. So here we have created first component, second component, and we have exported these components as a named export. Next, let us see how to import these two components. So let us go to app.js file. Now let us see how to import the named exports. Well, if you go to myComponent.js file, so here we have exported first component, second component using named export. Next, let us see how to import these two named exports. So go to app.js, and in order to import the named export components, here we have to use import keyword and then open and close curly braces and then post component from my component file. Okay, so whenever you want to import the named export component, then you should have to use the open and close curly braces like this. Next, here let us use it. So here just type first component and close it and then save this file, and here you can see in a browser first component is displayed. Similarly, if you go to myComponent.js file, here we have a second component and we have exported this second component using named export. So let us see how to import this second component in a app.js file. So here go to import statement and within curly braces we have already imported post component. Along with that, let us also type second component, and here let us use it, second component. Perfect. And if you look at the browser, second component is printed. Alright, so this is how we import a named exported components in a app component like this. Okay, so make sure that you use open and close curly braces to import the named components. And let us say you want to give a different name to this component, then you can use alias over here. For example, al, and just give fc. Okay, and if you save this file, you will get the error because you have given different name to this component, right? So here, instead of first component, we have to give fc, and then if you save this file, you can take a look at the browser, first component is displayed. And again, if you want to give alias to second component, you can just type as and then sc stands for second component, and just remove this second component name and then just type the alias second component. Okay, so this is how you can change the exported component name by using alias. So this is all about how to export and import the components using named export. Next, let us see default export. So go to mycomponent.js file. Here let's create one default export component. So here function and then component name, let us say my component, and let us have a return statement, and let us print my component. Next, in order to import this component in another component, we have to export it. So far we have seen how to export the components using named export. Now we are going to see how to export the component using default export, right? So here just type export and then append default. So this is the default export. Okay, so you can prefix the component using export default like this, or you can give this default export at the end like this. Okay, so most of the developers use this kind of syntax. Okay, now we have one default export per file. Next, let us save this file and let us go to app.js file and let us see how to import the default export component. So here let us have import statement, import, and then my component from my component.js file. So notice here, while importing the default exported component, we don't have to use the open and close curly braces. But in case of named exports, we are using the curly braces to import it. Next, let us use this my component in an app component. So here go at the bottom and then just type my component and then close it, and then just save this file and take a look at the browser. You can see my component is displayed over here. Next, let us see how to give a different name to this my component. Well, in case of named exports, we have used alias to give the different name to the component, right? But in case of default export, we don't have to use the alias. We can simply change the component name itself. For example, here instead of my component, let me give my C, and then just save the file and look at here, we got the error because we have given the different name to the component while importing. So here instead of my component, just give MC and then save the file and look at here, my component is displayed in the browser. Well, as I mentioned earlier, there should be only one default export component per file. That's why while importing the default export component, we can give any name that we want, because we show that the file contains only one default export, isn't it? So this is all about the default export. When we create a full stack application using Spring Boot and React, we are going to use these named export and default export a lot. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into JSX. Well, JSX stands for JavaScript XML. JSX allows us to write HTML elements within a JavaScript code. Well, let us create an example and let's understand the JSX with all these points. So here, let me head over to the VS Code. In order to understand the JSX, let's create a new file. So go to components folder, right click on components folder, click on new file, and let's give file name as hello world.js, and within a hello world.js file, let's create a functional component. So let us use arrow function to create a functional component. So here const and then component name hello world and then parenthesis and then arrow symbol, and here we have functional component body, and this functional component return the JSX code. For example, let us say h1 hello world. Perfect. Next, in order to use this component in other component, we have to export it. So here export default and then hello world. Perfect. Next, go to app.js, and here we have app component. So within this app component, let me comment out this and just use hello world component. So here hello world and just close it, and make sure that hello world component is imported at the top, and just save this file and look at the browser. You can see hello world is printed. Next, let us understand the JSX. Well, if you go to hello world component, this hello world component returns a JSX code. Well, JSX basically allows us to write HTML elements within a JavaScript code. So this is a JavaScript code, and JSX allows us to write this HTML element within a JavaScript code. Alright, so even we can assign this HTML element to a JavaScript variable. For example, here let me create a JavaScript variable. Let us say my element equal to, and let us assign this HTML element as a value to this variable, and just return this JavaScript variable, and just save this file. And if you look at the browser, hello world is printed. Okay, so it means JSX allows us to write HTML element in the JavaScript code like this. Next, let us take a look into next point. JSX makes it easier to write and add HTML elements in a React. Well, without using JSX, we can also create the user interface in a React application. Well, React provides create element method which we can use to create the React element, but this JSX makes it easier to write and add the HTML elements in React. So React team recommended to use a JSX. Okay, so now let me demonstrate how we can create the React element using create element, and how we can replace this code with JSX. So let us go to VS Code, and here let us see how to create the React element using create element method first. So here let me comment out this and go to return statement, and here just call React, and make sure that React is imported from the React library, and this React provides create element method over here, and then we need to pass the HTML element tag name. So in our case h1, and then let us pass second parameter as a null, and then third parameter as a content of this HTML element. So the content is hello world, and just save this file, and if you take a look at the browser, you can see hello world is printed. Well, notice here this is the JSX code and this is the react.createElement code. Which one looks easier? Obviously the JSX code looks easier, right? Because using JSX we can write the code like HTML code, isn't it? But if we use react.createElement, then we have to call this createElement method on each and every HTML element. For example, let us say we want to include this h1 tag within a div, then we have to pass div, and then here we need to again call react.createElement method, and then we need to pass the tag name h1, and then second parameter null, and third parameter the content, that is hello world, and just save this file and look at the browser hello world. And next, same code we can rewrite in the JSX like this. For example, here we can just include this h1 element in a div. Alright. Okay, so if you look at the code again, using JSX we can write this much of code only, But if we use react.createElement method, then we have to write a lot of code. Okay, so this is how the JSX makes it easier to write and add the HTML element in a React. Alright, and React team recommended to use JSX approach instead of this react.createElement approach. Alright, and in this course we are going to use a JSX to create the React element or user interface. Next, let us take a look into next point. JSX will be converted into JavaScript on a browser using transpiler bubble.js. Well, React will convert a JSX into JavaScript that browser understands. Alright, so browser basically does not understand the JSX code, right? So React will convert this JSX into JavaScript using Bubble JavaScript library. So once it will convert JSX into JavaScript, then browser will load that JavaScript code in a browser. Alright, so this is how the JSX works in a React application. Next, JSX rules in a React. Well, here I have listed certain rules that we can follow while writing JSX code in a React. The component should return a single React element. Well, let us say you have multiple HTML elements in a JSX, then you have to return one parent React element. For example, so here let me go to Visual Studio Code ID and let me demonstrate that. So here let me remove this, and let us say you have multiple HTML elements in a JSX. For example, return h1, let us say title, and you have one more HTML element, let us say h2, and let us pass subtitle, and then let us say you have a paragraph, and let us call it as paragraph, and let us say you have image. Well, whenever you have multiple HTML elements in a JSX, then you have to wrap all these multiple HTML elements in a single parent HTML element. So most of the time we use div. For example, here let us wrap all these HTML elements in a div like this. Alright, so this is the important point. So whenever you have multiple HTML elements in a JSX, then make sure to wrap all those HTML elements within a single parent HTML element. So most of the time we use div or we use fragment. For example, so here instead of div we can also use the fragment. So this is the empty tag. So this is basically called a React fragment. Okay, so either you can use div or fragment. Next, let us save this file, and if you take a look at the browser, the content is not displayed in the web page. Well, whenever you have multiple HTML elements in a multiple lines, then make sure that you include all these multiple HTML elements in a parenthesis. For example, after this return statement, let us have a parenthesis, and within a parenthesis just copy and paste this code. Okay, now if you save this file and if you take a look at the browser, the content is displayed: title, subtitle, paragraph. Okay, so these are the two important points. So whenever you have multiple HTML elements in a JSX, then make sure that you wrap all these multiple HTML elements in a parent HTML element. Either you can use div or fragment. Next, if you write the HTML code in a multiple lines, then make sure that you keep this HTML code within a parenthesis. Next, let us take a look into next point. To write the HTML on multiple lines, put the HTML code inside a parenthesis. Well, this point I have already demonstrated. Next, use camel case for HTML attributes. To specify the CSS classes for an HTML element, use the class name attribute instead of class attribute. This is because class is reserved keyword in a JavaScript. Well, in order to style the HTML element in a JSX, we have to use class name attribute instead of class attribute, because the class attribute is reserved keyword in a JavaScript. Next, event handlers in a JSX are specified using camel case syntax. For example, on click instead of on click or on change instead of on change. Well, if you look at the naming convention for this event handler, on click, so this is a camel case, right? But you can see the on click, so this is the HTML attribute. But if you want to use this HTML attribute in a JSX, you have to use the naming convention as a camel case. Next, let me demonstrate these 2 points. So let us go to Visual Studio Code ID over here, and here let us first create the CSS class. So we can create a CSS class within app.css. So go to app.css, and here just type dot, and let us give the class name as title, and then within a curly braces just type color. So let us give title color as a red. Just save this, and let's go back to hello-world.js, and here in order to add the CSS class to the HTML element, we have to use class name property. For example, here go to HT1 element and just type class name, and then pass title CSS class, and then just save this file. And if you look at the browser, title is in red color. Okay, so this is how we can use class name property to add the CSS class. Alright, and if you use class attribute, this will give the error. For example, if you go to browser and here just inspect this page, right click, inspect, and if you go to console, here you can see invalid DOM property class. Did you mean class name? Alright, so browser will give hint like instead of using class, just use class name in a React. Alright, it means the class is a result keyword in JavaScript. That's why whenever we want to add a CSS class to the HTML element in a React, we have to use class name property like this. Alright, perfect. Next point is event handlers in a JSX are specified using camel case syntax. For example, on click instead of on click. So let us go to Visual Studio Code ID, and here let me remove this image, and here let me add the button, and let us add the handler by using on click attribute. Well, if you can notice here, in a plain HTML we use the attribute that is on click, and if you look at here, the on click attribute in a lowercase. Okay, and same on click attribute we want to use in a JSX, we have to use camel case. For example, here instead of on click, let us type on click, and this on click should be in a camel case. Alright, and next let us pass the event handler name. Let us say handle click. Well, in a plain HTML element, in order to specify the event handler name, we have to use the string. For example, like this. Right, but in JSX we have to include the handler name within a curly braces. For example, like this, handler click. So this is the event handler name. Next, let us use a JavaScript function to handle this handle click. So here just create one JavaScript function handle click, and then just let's have a alert statement. Let us say button clicked, and then just save this file. Alright, and let us give name to the button here. Let us say click, and then save this file. And if you take a look at the browser over here, the click button is visible in the page. Next, go ahead and click on this click button, and there we go, the alert is popped up. It says button clicked. Okay, next click on OK button. Alright, so this is how we can specify the event handler in a JSX using the on click, and the on click should be in a camel case. Okay, perfect. Next, let us take a look into next point, expressions within a curly braces. You can embed JavaScript expressions within a JSX elements by wrapping them in a curly braces. Well, JavaScript expressions can be a variable or an expression. For example, let me demonstrate this. Let's go to Visual Studio Code ID, and here let me create one JavaScript variable. Let us say const name, and let us give name Ramesh. So if you want to use this JavaScript expression in a JSX, we have to wrap this expression within a curly braces. For example, here after this paragraph, let me use one more paragraph, and in order to access this name in this HTML element, we can use open and close curly braces and just pass name. And if you save this file and if you take a look at the browser, you can see Ramesh is displayed in a web page. Alright, so this is how we can access the JavaScript expression or a variable within a JSX by using open and close curly braces. Next, let us take one more example. Let us say const and then addition 1 plus 2, and then let us use this addition in a JSX by using curly braces. For example, let us use paragraph element over here, and then within a curly braces just call addition, and then save this file. And if you take a look at the browser, you can see 3 is printed. Alright, so JSX will basically execute this expression and it will print the result like this. Alright, great. Next, let us take a look into next rule. JSX follows XML rules and therefore HTML elements must be properly closed. If an element does not have any children, you can use self-closing tag. For example, if you go to VS Code and if you go to app.js file over here, and if you look at the component, so here we are using hello world component within an app component, and this hello world component don't have any content within it. That's why we have used self-closing tab to close this hello world component like this. Okay, so make sure that whenever you use the component or any HTML element in a JSX, make sure that you close them. Alright, so these are the important rules that you have to keep in mind whenever you work with JSX in a React. So these are the JSX rules I have listed over here as per my experience. So just try to follow these rules to write the JSX code. Alright, great. In next lecture, we'll take a look into the props. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into props. Well, the props is a special keyword in React that stands for properties and is being used to pass the data from one component to another component, and mostly from parent component to child component. Alright, so props is a special keyword in React that stands for properties, and we use props to transfer the data from parent component to child component. Next, we can say props is a data carrier or means to transport data. Next, React props is an object which you get instantly when you create a React component. Well, whenever you create a React component, either functional component or class component, you will get a props empty object, and then you can store the properties in a props empty object. Alright, so let us go ahead and let's understand more about props with an example. So let us go to VS Code IDE over here. Well, in order to understand props, let us create a new file. So go to components folder over here. Within that, let's create a new file and let's give a name as student.js. Within a student.js file, let's create a functional component, and we are going to use arrow function to create a functional component. So here just type const and let us give the component name student and then parenthesis and then flat arrow symbol, and within a functional component let us write the JSX code. So here let us have a return statement and then parenthesis. Within that, let's have a div as a parent element, and within div let's have a h1 element to give the heading. So let us say student details. Alright, next let us print the student first name. So let us say student first name. As of now, let us hard code it. Let us say Ramesh, and then let us also print the student last name. Let us say Fadtare, and let us also print student email address. Let us say ramesh@gmail.com. Perfect. Next, let us export the student functional component using default export. So here just type export and then default and then followed by the component name. Perfect. Next, let us go ahead and let us use this student component in an app component. So go to app.js file over here and go to app component, and here let me comment out this hello world component, and here let us use student component and make sure that student component is imported at the top. Alright, next save this file, and if you look at the browser over here, you can see the student first name, last name and email address is printed over here. Alright, next let us go ahead and let us see how to use props to transfer the data from app component to student component. Well, as of now you can see the student component, we have hard coded the value first name, last name, email address, right? Now let us use props to transfer the data from app component to student component dynamically. Okay, so go to student over here, and here let us pass the information. So first name is the property name, and let us give value Ramesh, and then last name let us give value as a Padtare, and then email let us give value as ramesh@gmail.com. Perfect. Now we have passed the data to the student component. Next let us use props to access these property values in a student component. So let us head over to student component over here, and in order to use props we have to pass props as a parameter to this student. So here just pass props. Okay, perfect. Next let us go ahead and let us retrieve all the properties from the props. So here let us remove this hard coded value Ramesh, and let us have curly braces. Within that let us call props, and the property name is first name. Alright, so whatever the property name you have given while assigning the data, same property name you have to give. For example, if you go to app.js, you can see here we have given the property name first name. Same property name you have to use while accessing the data from the props. Okay, next let us remove this Padtare and let us use props, and then property name last name. Similarly let us do it for email as well. So within a curly braces props dot email. Perfect. Next let us save this file, and let us take a look at the browser. You can see here student first name, last name, email is printed. Next let us reuse this student component, and let us pass the different data dynamically. So go to app.js, and here let us reuse this student component and make sure to close it. Next let us pass the student data. So here first name, so let us give Umesh, and then last name let us give Padtare, and then email umesh@gmail.com. Perfect. Next save this file, and if you take a look at the browser over here, the another student, that is Umesh student, is also displayed over here. So this is how we can reuse the existing component, and just we need to pass the information. Okay, perfect. Now let us go ahead and let us see how to pass the object from parent component to child component. Now we have passed the string. Next let us see how to pass the object from app component to student component. So first of all, here let us create the object const student, and then first name let us say Ramesh, last name Padtare, and then email ramesh@gmail.com. Perfect. Next we need to transfer this student object from app component to student component. So let us see how to do that. So here first of all let us remove all this, and here let us give property name as student, and then within a curly braces just pass the object, that is student. Next let us see how to use props to get this student object in a student component. So before that let us comment out this code. Alright, perfect. Next let's go to student component over here, and here we have props. So we should get the student object from this props, right? So here in order to get the student, so here is the syntax: props dot student is the property name, and then student object has first name attribute. Next props dot student dot last name, and then props dot student dot email. Well, if you go to app.js, you can see here the property name student, and if you go to student.js, here we are using the same property name, okay, and the student object has first name, last name, email, right? So this is how we can use the syntax to retrieve the student object first name, last name, email. Next, if you save this file and if you look at the browser, you can see the Ramesh student details is displayed over here. Alright, so this is how we can pass the object from parent component to child component using props. Okay, perfect. Next, if you go to app.js file over here, so here let us pass the different student information. Let us say Sanjay, last name Jadhav, and email let us say Sanjay, and just save this file. And if you take a look at the browser, the Sanjay student details is successfully displayed. Alright, perfect. Next, let us see how to use props to transfer the array from one component to another component. So instead of passing the object, let us pass the array. So here let me comment out this, and here let me quickly create the array const, and then let us give the array name as skills, and let us provide the elements in the array. Let us say HTML, CSS, JavaScript. Perfect. Now we have array. Next, we need to pass this array to the student component using props. So here what we'll do, we'll just give property name as data, and we'll pass skills over here. Perfect. Next, let us change the student component to get this skills data using props. So go to student component, and here we have props. So let us get the array from this props. So here what I will do, I will comment out this, and I'm going to create one more paragraph element. Alright, and here let us say array data, and within a curly braces props dot data. Next, save this file, and if you take a look at the browser, you can see array data HTML, CSS, JavaScript. Alright, so this is how we can pass the array data from one component to another component. Alright, just remember, we use props to transfer the data from parent component to child component. Alright, so this is all about props. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we pretty much understood about props. In this lecture, let us take a look into destructuring props. Well, destructuring was introduced in ES6. It's a JavaScript feature that allows us to extract multiple pieces of data from an array or object and assign them to their own variables. In React, destructuring props improves code readability. Well, there are two ways to destructure props in a functional component. The first way is destructuring it in a function parameter itself. The second way is destructuring props in the function body. So let us go ahead and let us see how to destructure props with an example. So let us go to VS Code ID over here. In previous lecture, we have created student functional component to demonstrate the props. In this lecture, let us use the same student functional component to demonstrate destructuring props. So here, go to the JSX code, and here let us uncomment this, and here let us remove this student. Just keep props dot first name and props dot last name, and then props dot email. Perfect. Next, go to app.js file over here, and here just comment out this and just uncomment this. Okay, now save the file, and if you look at the browser, the Umesh student details is printed. Okay, next go to student component over here, and here let us remove this array data paragraph element, and next save this file, and if you look at the browser, the Umesh student details is displayed over here. Now let us go and let us see how to destructure these props. Well, there are two ways. First way is we can destructure these props in function parameter itself. For example, here this props contains first name, last name, email properties, right? So here we can destructure like this. So within curly braces, just pass first name, comma, last name, comma, email. So this is the syntax to destructure the props. Next, while accessing these properties, we don't have to use props. For example, here let us remove this props, just keep first name, and here remove the props, just keep last name, and here also remove props and just keep email, and then save this file. And if you take a look at the browser, you can see student details is successfully printed. Okay, so this is how we can destructure the props in a function parameter itself. Well, here destructuring allows us to extract some of the data from an array or object and assign them to their own variable. For example, here we have extracted first name, last name, email from the props, and we have assigned them to its own variable like first name, last name, email, and we are accessing these variables over here. So we can also extract only first name, last name from the props by using destructuring like this. If you save this file, and here we got email is not defined, so we can simply remove this, and you can see Umesh Padhar is printed over here. Well, notice here, even though the props object has first name, last name, email, but we are only extracting first name, last name from the props object using destructure feature like this. Alright, perfect. Next, let us say how to destructure props in a function body. So here we have destructured props in a function parameter itself. So let us see how to destructure props in a function body. So let us cut this and go to function body, and let us have a const and then paste this and then props, and then this props we should pass as a parameter to student. Perfect. Next, if you save this file and if you take a look at the browser, you can see still the student details is printed properly. Next, let us say we want to only extract the first name, last name from the props object. Then what we can do is we can simply remove this email, and here also we need to simply remove this paragraph element. Alright, so even though this props has first name, last name, email, but we are only extracting first name, last name from the props object using destructuring feature like this. So basically here we are extracting first name, last name from the props object, and we are assigning them to the separate variables, that is first name, last name, and we are accessing these variables in a JSX code like this. Alright, so this is how we can destructure the props in a functional components. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us take a look into state object and set state method in a class components. Well, the state is an inbuilt object in a React class components. In a state object, we can store property values that belong to that particular class component. When the state object changes, the class component re-renders. We use setState method to change the state object in a class component. Well, notice here we are talking about the class components, not the functional components. Alright, so we can use state inbuilt object in only class components, not in the functional components. Alright, well, let us understand about state object and set state methods with an example. So let's go to VS Code IDE over here, and here let's create a new file. So go to components folder. Within that, let's create a new file. Let's call it as employee.js. Next, within employee.js file, let us create a class component. So before that, let's first import React from React library. Alright, next let us type class. Let us give component name as employee. So this employee component should extends react.component. Okay, perfect. Next, here let us have a constructor. This constructor takes props as a parameter, and then let us have a super, and then pass these props to the super class constructor. Next, within a constructor, let us specify the state object. So here just type this dot state, and notice here whenever we create the React class component, then this state inbuilt object is immediately available. Okay, next let us choose state over here, and then within a state inbuilt object we can define the property and its values. For example, here let us say first name as a property and value as a Ramesh. Alright, perfect. Next, let us say how to access this state object and its properties in a JSX code. So after this constructor, let us have a render method, and then let us have a return statement, and then parenthesis, and then let us have a div. Perfect. So within a div, let's have a h1 element, and let's give heading something like employee details. Next, let us have a paragraph element. Next, we want to access the state object property, that is first name, right? So here is the syntax. Within a curly braces, this dot state dot first name. So this is the syntax to access the state object property. Alright, perfect. Next, in order to use this employee component in an app component, we should have to export this component, right? So here, let us use default export to export this employee class component. So just type export default and then employee. Perfect. Now we have used default export to export this employee class component. Next, let us use this employee class component in an app component. So go to app.js file over here, and let me expand this, and here let me comment out this student, and here let us use employee component. So just type employee and hit enter and just close it, and make sure that this employee component is imported at the top. Next, just save this file, and if you take a look at the browser, you can see Ramesh employee detail is printed over here. And if you go to employee component, you can see we have accessed this first name property from the state object. So this is how we can access the property from the state object. Next, we can have as many as properties and its values in a state object. For example, here let us have a last name property and its value, let us say Patare, and we can access this last name property from the state object using the same syntax. So here let us have paragraph element, and then within a curly braces, this dot state dot last name, and if you save this file and if you take a look at the browser, the further is displayed over here. Similarly, let us also have an email property, and then ramesh@gmail.com, and let us access this email property from the state object over here. So let us have a paragraph element within a curly braces, this dot state dot email. Save the file, and if you take a look at the browser, the email is displayed. Okay, so this is how we can use inbuilt state object in a class component to define the property and its values. Next, in order to access the state object, we can use the syntax this dot state dot property name. Alright, perfect. Next, let us see how to update this state object using setState method. So here, first of all, let's create one method. Let us say update employee, and then within the update employee method, let us use setState method to update the state object. So here setState, and then within the curly braces, first name. So let us update from Ramesh to Ram, and also update the last name from Padatari to Jadhav, and also update the email ram@gmail.com. Next, let us have a button, and whenever user click on that button, then this update employee method will get called. So here go to div, and after that let us have a button over here. Next, let us give name to the button. Let us say update employee. Next, let us attach the event handler to this button. For that, let us use onClick attribute. Well, this is a class component, so we have to call the event handler using arrow function. So within curly braces, just have a arrow function over here. In order to call the event handler, just type this dot, the event handler name, update employee, and then parenthesis. Next, save this file, and if you take a look at the browser, update employee button is visible. Next, let us refresh this and go ahead and click on update employee button over here, and there we go. The employee details successfully updated from Ramesh to Ram, Padatari to Jadhav, Ramesh@gmail.com to Ram@gmail.com. So notice here the code. Once user click on this update employee button, then this update employee event handler will get called, and within this update employee event handler we have used set state method to update the state object. Okay, so just remember, class component has an inbuilt state object. So within this state object we can define the properties, and in order to access the inbuilt state object we can use the syntax like this dot state dot property name, and in order to update the state object we use set state method like this. So this is all about state object and set state method. Alright, yet I will see you in the next lecture. Hi everyone, welcome back. In previous lecture we have seen how to use state object in a class component to manage the state of the component, and we have also seen how to use set state method to update the state object in a class component. Now the question is, only class components has an inbuilt state object, then how to define the state variables in a functional components? Well, the answer is hooks. So we can use state hook to define the state variables in a functional components. Alright, the use state is a hook that allows us to have a state variables in a functional components. Well, here hook is nothing but a function that allows us to use the React features in a functional components. For example, the React features like state object, lifecycle methods and other React features. So just remember, hooks are nothing but a functions that allows us to use React features such as state object, lifecycle methods in a functional components. For example, here we are using use state hook that allows us to use state variables in a functional components. So in order to use state hook in a functional component, first we need to import use state hook from the React library, and then use state hook is a function that takes initial value as a one argument and it returns the two values. One is the current state and another is a function that updates the current state. Okay, so let us understand the use state hook with an example. So let us go to VS Code IDEA over here, and here let's create a new file. So go to components folder and then let's create a new file. Let's give name as user.js. Let's expand this, and here let's create a functional component using arrow function. So just type const, let's give component name as user and then parenthesis and then arrow symbol. Perfect. Next, here let us use state hook to define the state variables. So just type use state and make sure that you import use state hook from React library. So just click on it and notice here use state hook is imported from the React library over here. And again notice here use state hook is nothing but a functional component and it is imported using named export. That's why we have imported using curly braces here. Alright, perfect. So here use state hook is nothing but a JavaScript function and it takes one argument, that is the initial value. So here let us give initial value as empty. Next, this use state hook returns an array. So here let us destructure it. So array, and the first value is the current state. So let us give state variable name as first name. Second value is the function that we can use to update this first name state variable. So here let us give the function name as set first name. So this is the syntax to use state hook. So if you can notice here, use state hook takes initial value as a first argument, and this use state hook returns an array, and the array contains exact two values. The first value is current state variable name, second value is the method that updates the current state. Okay, perfect. Next, let us write the JSX code and let us access this state variable in a JSX code. So here what I'm going to do is we're going to have a return statement and then parenthesis, and then let us have a div, let us have h1 element, and let us give heading as a employee details or user details. Perfect. After that let us have paragraph, and then here let us access the state variable using open and close curly braces and then just call first name. Okay, so look at the syntax. In order to access the state variable that is defined by useStateHook, we just have to use the syntax like this. Within a curly braces, we just need to call the state variable name like this. Okay, perfect. Next, in order to use this user component in app component, we have to export it. So here, let us use default export to export this component. So just type export and then default and then user. Perfect. Next, let's go to app.js, go to app component, and here let us comment out this employee component and let us use user component. So here user, and make sure that this user component is imported at the top. Alright, perfect. Next, let us save this file, and if you take a look at the browser, user details, and if you again go to the user.js file and go to user component, the initial value for this first name is empty. That's why nothing is displayed here. Okay, so let us give initial value as a Ramesh. Next, if you save this file and if you take a look at the browser, Ramesh is displayed over here. Okay, so this is how we can use useStateHook to define the state variable and assign the initial value to this state variable. Next, let us use useStateHook to define one more state variable. So here const and then array, let us give state variable name as last name, and then method set last name, and then use state and then pass the initial value further in. Next, in order to access this last name state variable, here let us have paragraph element within a curly braces, just pass last name. Perfect. Next, save this file, and if you take a look at the browser, further is displayed over here. Similarly, let us define one more state variable using useStateHook. So here let us copy this, paste it over here, and let us give state variable name as email, and let us give method name as set email, and here let us give initial value as ramesh@gmail.com, paragraph within a curly braces, just call email state variable, and then save this file, and if you take a look at the browser, email is printed. Okay, so this is how we can use useStateHook to define the state variables in a functional component. Next, let us see how to update the state variables using the corresponding set methods. For example, here in order to update the first name state variable, we have to use set first name method, and in order to update the last name state variable, we have to use set last name method. In order to update the email state variable, we have to use set email method. Okay, so let us go and let us see how to update these state variables using the corresponding set method. So here let us have one button. Let us give button name as update user. Next, let us attach onClick event to this button. Well, whenever user click on this update user button, then we have to create a event handler method that will handle this update user event, right? So here let us have onClick attribute, and let us pass the event handler name. Let us say update user. Next, let us add the implementation for this update user event handler. Let's create a JavaScript function and let's give name as update user. Next, within update user method, let us call set first name method to update first name state variable. So right now the first name state variable contains the initial value Ramesh. So let us update the initial value from Ramesh to Ram. So here go to update user method again and just call set first name and then pass value as a Ram. Next, just save this file. Next, let us call set last name, and then let us update the last name state variable from Padhatare to Jadhav. Next, let us call set email method and then pass ram@gmail.com. Perfect. Now we have used set first name method to update the first name state variable. We have used set last name method to update last name state variable, and we have used set email method to update email state variable. Alright, perfect. Next, save this file, and if you go to browser, here you can see update user button is visible. Next, go ahead and click on this update user button over here, and look at here, the user details are updated. Earlier it was Ramesh, now you can see Ram. Okay, and similarly the last name and email also updated. Alright, so this is how we can update the state variables using the corresponding set methods. Okay, perfect. Next, let us see one more example using use state hook. In previous example, we have passed string to the use state hook, but we can also pass the object or array to the use state hook. For example, here let us comment out this, and here let us use state hook, and let us pass initial value as an object. Okay, and then let us have property first name Ramesh, and then last name Padatare, and then email ramesh@gmail.com. Perfect. So this is how we can use state hook to pass the object. Next, this use state hook returns an array with two values. So here let us have a destructuring array, and the state variable let us give user, and the method name is set user. Next, save this file and go to return statement, go to div, and here we have used first name, last name, email state variables, but here we are not using these state variables. We are using the user object. It has first name, last name, email properties, right? So in order to access the user object properties, we have the syntax like this: user dot first name. Okay, similarly user dot last name, and then user dot email. Okay, perfect. Next, save this file, and if you go to update user method, within that we have used set first name, set last name, set email methods, right? Right now we are not using these methods, so let us comment it out. And if you take a look at the use state hook, in order to update the user object state variable, we have to use set user method. So go to update user again, and here just call set user method, and then let us have its property first name. Let us update the first name from Ramesh to Ram, and then last name property let us update from Padatari to Jadhav. So either you can use single quote or double quote, and then email ram@gmail.com. Perfect. Next, save this file, and if you take a look at the browser, Ramesh Padatare ramesh@gmail.com. So these user details successfully displayed, and along with that you can see update user button. So go ahead and click on this update user button over here, and there we go. The user details are successfully updated. So this is how we can update the user state object using set user method. Alright, so this is the example that demonstrates how to use state hook to define the user state object as a state variable. Alright, great. So this is all about using use state hook in a functional component. Alright, so just remember, we use state hook to define the state variables in a functional components. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will see how to perform event handling in a React application. Well, in React, event handling allows you to handle user interactions such as button clicks, form submissions, or mouse movements within your React application. Event handling in React follows similar pattern to standard JavaScript event handling, but with some differences. React events are written in camel case syntax, for example, on click instead of on click. So this on click is a camel case. React event handlers are written in inside a curly braces. For example, here you can see on click within a curly braces. Shoot is the event handler name instead of on click, and here we are passing shoot event handler name within a double quote, right? But in React, we typically pass the event handler's name within a curly braces like this. Alright, so let us go and let us understand how to perform event handling in React application with an example. So let us head over to VS Code ID over here, and here I am going to create a new file. Go to components folder. Within that, create a new file. Let's call it as event handling.js. Perfect. Next, let me expand this. Let me minimize this. And within a event handling.js file, let's create a functional component using arrow function. So here const, and then let's give functional component name as event handling, and then parenthesis, and then arrow symbol. Next, within a event handling functional component, let us maintain count state variable using use state hook. So here let us call use state hook from React library, and make sure that use state hook is imported at the top. Next, let us destructure it. So here const, and then let us give the state variable name as count, and then the method name set count. Next, let us give the initial value to this count state variable as 0. Okay, perfect. Now we have maintained count state variable using use state hook. Next, let us have a return statement over here, and within a return statement we are going to write the JSX code. So within a parenthesis, let's have a div as a parent element, and within a div, let us first print the heading by using h1 tag. Let us give the heading something like event handling example. Next, let us use paragraph element over here, and then let us print the current count by using count state variable. So here, in order to access the count state variable in a JSX, we have to use curly braces. So within a curly braces, just pass count state variable name here. Next, let us create a button. Let us give button name as increment, and here let us attach the onClick event. For that, let us use onClick property here, and notice here the React event should be in a camel case. Okay. Next, we need to pass the event handler name within a curly braces. For example, here let us give event handler name as handle click. Okay. So whenever user click on this increment button, then this handle click function will be triggered. So let us implement this handle click function over here. So here just type function and then handle click. Alright. Next, in order to update the count state, we have to use set count method. So here just call set count method and then increment the count by 1. So count plus 1. Alright, perfect. Next, here let's create one more button, and let us give name as reset, and let us attach onClick event to this button. So let us type onClick, and then let us pass the event handler name within a curly braces, handle reset, something like that. Next, let us implement this event handler over here. So here function and then function name handle reset, and then call set count method and then pass 0. Well, handle reset function will get triggered when reset button clicked, and this handle reset function will set the count value back to 0 by using set count method. Okay, perfect. Next, let us save this file, and here you can see we haven't exported this component yet. So let us use default export to export this event handling functional component. So here just type export default and then component name, that is event handling. Perfect. Next, let us open app.js file over here, and within app.js file, let me comment out this, and here let us use event handling component, and make sure that event handling component is imported at the top. Perfect. Just save this file, and if you take a look at the browser, you can see initially the count value is 0 and increment and reset buttons are displayed over here. Next, let us go ahead and click on increment button over here. So look at here, the count value is incremented by 1, and again if you click on increment button one more time, you can see the count value 2. Alright, and if you click on reset button, it will reset the count value back to 0. Okay, it means we have successfully handled the onClick event. Well, here in heading we have a typo, so this should be handling. Perfect. So this is how basically we perform event handling in React. Well, let me recap what we have done. We have created a functional component named event handling. Within this functional component, we have maintained count state variable using use state hook. Next, this handle click function is get called when the increment button is clicked, and this function updates count state by incrementing it by 1 using set count method, and this handle reset function set the count state value back to 0. Well, in this example we have seen on-click event handling, but in upcoming lectures we'll also take a look into form handling, and within a form handling we'll learn how to perform different events like on submit event, on change event, etc. Alright, so this is how we can perform event handling in React. And just remember the syntax. React events should be in a camel case, for example like on click, and the event handler should be passed in a curly braces like this. Okay, perfect. I will see you. Hi everyone, welcome back. In this lecture we'll take a look into conditional rendering in React application. Well, conditional rendering in React allows you to render different content or components based on certain conditions or state values. It helps you dynamically control what gets displayed in your UI based on certain conditions. Well, there are different ways to implement conditional rendering. For example, we can perform conditional rendering using if-else statement. We can implement conditional rendering using ternary operator. We can implement conditional rendering using short circuit operator. Alright, so these are the 3 different ways to implement conditional rendering, and in this lecture we will see all these different ways to implement conditional rendering. So let us begin with conditional rendering using if and else statement. So let us head over to Visual Studio Code IDE over here, and here first of all let's create a new file. Go to components folder. Within that let's create a new file named conditional rendering.js. Next, let us maximize this, and here let's create a functional component named conditional rendering. So here let us use const and then conditional rendering is the component name, and then parenthesis and then arrow symbol. Perfect. Next, within a conditional rendering functional component, let us maintain the state variable using use state hook. So here let us use state hook, and make sure that use state hook is imported at the top from React library. And then here let us perform the destructuring, like let us use the state variable name as is logged in is the state variable name, and let us use the corresponding setter function, that is set is logged in, and then let us give the initial value as a false. Okay, it means user is not logged in. Alright, perfect. Next, let us have if else statement over here. If is logged in, then we will return the JSX code. So let us have paragraph element, and let us say welcome user. Perfect. Else return please log in. Okay, perfect. Next, let us export this component by using default export default, and then component name conditional rendering. Perfect. Next, let us go to app.js file, and here go to app component, go to return statement, and here let us comment out this, and let us use conditional rendering component, and make sure that conditional rendering component is imported at the top. Okay, just save this file, and if you take a look at the browser, please login is displayed. Well, if you go back again to the conditional rendering component over here, you can see initially the is logged in state variable value is false, and if you look at the if else condition, if is logged in is true, then this functional component will return welcome user, and if is logged in state variable has a false value, then it will return please login, and that is what get displayed in a browser. Okay, so this is logged in state variable has initial value false. That's why this functional component will return please login, and this please login is printed over here. And if you pass true over here, for example, and if you save the file and if you take a look at the browser, you can see welcome user is displayed. So this is how we can use if else statement to conditionally render different content. Next, instead of returning, we can assign this HTML code to variable as well. For example, here let us say let message, and then remove this return, and then assign this part to message variable, and again here message. Next, here let us have return statement, and then let us have a div over here within a parenthesis div, and then here within a curly braces just call message, and then save this file. And if you take a look at the browser, you can see still welcome user is displayed. And if you pass the false value here, and if you save the file, and if you take a look at the browser, you can see please login is displayed. Okay, so this is how you can use if else statement to return the JavaScript variable. It contains the JSX code. Okay, next let us have button over here. So here let me add break element, and let us have a button. Let's give button name as login, and let us attach the onClick event to this button. For that, let us use onClick attribute, and let us pass the event handler name handle login. Next, let us implement this handle login event handler over here. So here just type function and then handle login, and here let us use set is logged in method to set the value to this state variable. So here let us give value as a true. It means whenever user click on this login button, then this is logged in state variable will be updated with the true value. Okay, perfect. Next, let us save this file, and if you take a look at the browser, login button is displayed over here. Next, click on this login button, you can see welcome user is displayed. Alright, so this is how we can use if else statement to conditionally or dynamically render the content based on the condition like this. Okay, perfect. Next approach is conditional rendering using ternary operator. So let us go back to VS Code over here, and let us use ternary operator to dynamically display the content. So we can use ternary operator within a JSX code itself, but if you can see the if else condition, we are using if else condition outside the JSX code. Okay, but we can use ternary operator within a JSX code itself. Alright, for example, here let us remove this, and here within a curly braces just have a ternary operator. So here is the syntax. Just call the current state variable, that is logged in, and then question mark, and then if this is logged in is true, then we'll display welcome user. So just copy this, paste it here. If is logged in false, then we'll display please login. So just copy and paste it here. Okay, so this is how we can use ternary operator to reduce some amount of code. So if we use if else, then we need to write this much of code, but if we use ternary operator, then we can write this much of code. Alright, so ternary operator is pretty useful because we can use ternary operator in a JSX code itself to render the content dynamically. Alright, so notice here the ternary operator has a syntax like the variable name, and then expression 1, and then expression 2. If the variable is true, then this expression 1 will get evaluated, and if this variable value is false, then this expression 2 will get evaluated. Okay, and in this case this is logged in variable contains true value, that's why this expression is get evaluated, and this is what displayed in a browser. Next, let us go to browser over here, and let us refresh this, and the initial value for this is logged in state variable is false. That's why you can see please login is displayed over here. Next, if you click on this login button, you can see welcome user is displayed. Alright, perfect. Next, let us take a look into next approach, conditional rendering using short circuit operator. So let's go to VS Code over here, and here just remove this, and here let us use the short circuit operator and. Okay, it means if is logged in state variable has a value true, then only this expression will get evaluated, otherwise nothing will display in the browser. For example, just save this file, and if you go to browser, just refresh, and you can see nothing is displayed because this is logged in state variable has a value false. If this is logged in variable has a value true, then only it will display this part, otherwise it won't display anything in the browser. Okay, next, if you click on login, it will display welcome user because this is logged in state variable has a value true. Okay, so this is how the short circuit operator works. Okay, so whenever you want to display something or nothing, then you can go ahead and use this short circuit operator. Alright, so these are the three different ways to implement conditional rendering in a React. Okay, perfect. I will see you in the next lecture. Hey there everyone, Ramesh here, back again with another video. In this video I am going to show you how to create a React application using Vite tool. Well, earlier we were using create a React app tool to create a React application, but alternative to create a React app, we have one more tool, that is Vite. Well, nowadays React developers prefer using Vite tool to create the React project. So in this video I am going to show you how to use Vite to create a React project. Well, Vite is a build tool that aims to provide a faster and learner development experience for modern web projects. Well, using Vite we can create the React application faster, and basically Vite bundles the React application very faster. Alright, so let's go ahead and let's see how to create a React project using Vite build tool. Well, here you can see Vite supports two templates, one is JavaScript and another is TypeScript. So using Vite we can create different applications, like we can create JavaScript vanilla project, Vue project, React project, and so on. And we can use Vue to create a different TypeScript applications like vanilla TypeScript, Vue TypeScript, React TypeScript, and so on. In this video I want to show you how to create a React application with JavaScript template using Vite tool. So let's go to Visual Studio Code IDE. So here I have created Vite workspace folder, and I have opened this Visual Studio Code IDE in this folder. Alright, next let us use Visual Studio Code IDE built-in terminal to execute the commands. So here we have a terminal, so click on new terminal over here. Next, here just type the command npm. So make sure that you have installed Node.js and npm in your machine, because in order to create the React application using Vite we have to use the npm command. So here npm followed by create and then Vite. So we are going to use a latest version of Vite, so here add latest and then followed by the project name. So here let us say Vite React app, something like that. So this is the command that we can use to create a React application using Vite build tool. Next, go ahead and hit enter, and notice here it prompts select a framework. So here we have vanilla, Vue, React. So we are going to use React. So here let us select the React and hit enter, and here we need to choose the template. So we are going to use JavaScript. So here let us select the JavaScript and hit enter, and now you can able to see here the project is created. So if you can see here, within a Vite workspace folder, Vite React app application is created. So just expand, and here you can see here this is the project structure. Next, here you can see couple of commands. So just follow these commands and just run this application. So here just type cd and then followed by the project name, that is Vite React app, and then hit enter. Now we are in a Vite React app application. Next, just type the command npm install. So just follow these three commands, okay, and then hit enter. So this will install all the dependencies for our React application. So just wait a couple of seconds. Now we have installed all the dependencies. Next, in order to run the React application, just type the command npm run dev and hit enter, and there we go. Our React application is deployed in a local development server which is running on port 5173. So just copy this URL. Now go to browser, in a new tab just paste it and hit enter, and there we go. Our React application is up and running. Next, let us go ahead and let's quickly understand the project structure for our React application. So here we have package.json file. So within a package.json file, you can see all the dependencies. For example, here you can see dependency section, and within that we have a React and React DOM dependencies. Next, here we have scripts section, and within that we have different scripts to build the React application, to run the React application, and to preview the React application. And here we have dev dependency section. Alright, and whenever we execute npm install command, then npm install command will download all the dependencies as per the dependency section, and it will create node_modules folder, and it will keep all the downloaded JavaScript dependencies within the node_modules folder. Next, we have index.html file. Well, this is the single page React application. So in this React application we have only one HTML file, that is index.html file. And if you can notice here, within this HTML file we have a body, within that we have a div with the ID root. So whatever the components that we are going to create in a React application, that components will be rendered within this div. Alright, next, expand src folder, within that we have main.jsx file. So within a main.jsx file, you can see we have react dom.create root, and here document.get element by id, and then we have passed the root as a id. Well, in index.html file you can see we have a div with id root, right? And in main.js file you can see document.get element by id, and then this is the root. So whatever the components that we are going to create in a React application, that components will be rendered within this div by using this statement. Okay, right now you can see we have only one component, that is app component. So basically app component is a root component, and we import the other components within an app component. Just remember, this statement is responsible to render the components within a div. It has id root. Next, we have app.jsx file. So this file contains an app component. So app component is basically a root component, and this is the default generated code. So we can simply remove this code and we can write our own code. Alright, next let me remove this import as well. This is the unused import. Next we have app.css file. So this file basically contains all the CSS styles. So right now we can remove all this because we are not going to use it. Next we have index.css. So this file also contains all the CSS styles. So let me remove this as well. Next we have assets folder. So within assets folder we keep all the images and other static files. Next we have a public folder. Within a public folder we can keep the static files such as images, SVG files, videos, and etc. Alright, so this is a very simple project structure of our React application. Next we have one more important file, that is vite.config.js. So within this file we can configure all the Vite related configuration. For example, right now the development server is running on port 5173, but we can configure different port as well. For example, here let us have a server section, and here we can change the port by using port attribute port 3000. Next let's go to browser, and here you can see this site can't be reached because we have changed the port. So here let me give the port 3000, and now you can see we can access the React application. So we don't have any content to display, that's why you can see the blank. Next let's create one component. So go to src folder, right click on it and new file, and let's give file name as hello world.jsx. So make sure that you provide the extension for this file as a JSX, because we are going to write a JSX code within this file. Next, here let's use a functional component to create a React component. So here export default and then function. Let's give component name as hello world. So make sure that the first letter of the component name should be a capital, and then just return some HTML code. So here h1 and then hello world. Perfect. Now we have created hello world functional component. Next, let us import this component in a app component. So go to app.jsx file and here go to return statement, and this is basically a fragment. Within a fragment, just use hello world component and make sure that you import this hello world component at the top. Alright, perfect. Next, save this file and go to browser, and here you can see hello world is displayed in a web page. So this is how we create a React application using Vite, and this is how we create a functional component in a React project, and we import and use in a app component. Alright, great. I hope you understood how to create a React application step by step using Vite build tool. Alright, so Vite is basically faster and it improves the development experience. So now onwards you can go ahead and use Vite tool to create the React application. Alright, great. I will see you in the next video. Hi everyone, welcome back. We'll start building employee management full stack project. Next, let us take a look into the requirements. In our requirement 1, we will build crude REST APIs for employee management model. Well, we want to basically build add employee, get all employees, update employee and delete employee REST APIs. Next, in our requirement 2, we will build front-end React application for employee management model. Well, in this module, the user should be able to perform these crude operations, like user should be able to add a new employee, user should be able to list all the employees, user should be able to update the existing employee, user should be able to delete existing employee. Well, this is the full stack application architecture that we are going to follow in order to develop a full stack web application using Spring Boot and React.js. Well, this full stack application architecture follows client-server model. At a client side, we will build a React front-end application. At a server side, we will build Spring Boot backend application. Well, notice here in this full stack application architecture, we are going to create a separate project for React front-end application and separate project for Spring Boot backend application. Alright, and front-end application, backend application, both are loosely coupled. Alright. So Spring Boot backend application will basically expose the REST APIs, and React front-end application will consume those REST APIs. And both applications are loosely coupled. So at a front end, we can also use different technologies to build the front-end application. For example, instead of using React.js, you can also use AngularJS or Vue.js to create the front-end application. Because both front-end application and backend applications are loosely coupled. Loosely coupled means both front-end application and backend applications are independent to each other. So you can develop front-end application using any JavaScript framework, like you can use either React.js or AngularJS or Vue.js. Okay, so this is basically a client-server model. So at a client side, you can create front-end application using any JavaScript framework. Okay. So let us take a look into some of the key components and their roles in this architecture. So let us begin with Spring Boot backend application. Well, in a Spring Boot backend application, we will create the 3-layer architecture: the controller layer, service layer, and DAO layer. The DAO layer is responsible to talk with the database, and service layer basically contains the business logic of the application, and the controller basically contains the Spring MVC controllers, which exposes the REST APIs. Next, we have a React front-end application. It consumes the REST APIs that is exposed by Spring Boot backend application. And in React front-end application, we create the components, services, router, and React is not concerned with the HTTP library. We have to use third-party HTTP library to make a REST API call. Okay, So in this project, we are going to use Axios HTTP library to make the REST API call in a React application. Okay, and we are going to use a JSON format to exchange the data between React frontend application and Spring Boot backend application. All right. So just remember, React.js is not concerned with HTTP library. We have to use the third-party HTTP library to make a REST API call in a React application. And in this project, we are going to use Axios HTTP library to make a REST API call in a React application. Alright, so overall, Spring Boot backend application exposes the REST APIs, React application consumes the REST APIs. Alright, so this is pretty much about Spring Boot React full stack application architecture. Alright, great, I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to create and set up Spring Boot project in IntelliJ IDEA. Well, first, we'll create a Spring Boot project using Spring Initializer, and then we'll import that project in IntelliJ IDEA. So let us first go ahead and create a Spring Boot project using Spring Initializer. So let us go to the browser over here. In a new tab, just type start.spring.io. This will bring up Spring Initializer. Well, Spring Initializer is a web tool that we can use to quickly create a Spring-based applications. Next, let us go ahead and fill up the project information over here. So here you can see the projects section. Here you have different projects like Gradle Groovy, Gradle Kotlin, Maven. Since we are going to use Maven, so let us select Maven as it is. Next, here you can see the different JVM languages like Java, Kotlin, Groovy. As we are going to use Java, so let us keep Java as selected over here. And then here we need to choose the Spring Boot version. So we are going to use the Spring Boot 4, which is the latest version of Spring Boot as of now. So let us select the Spring Boot 4.0.0 RC1. Don't select the snapshot. Next, let us add the project metadata over here. So here, let us give group as net.java guides. And then here, let us give artifact as EMS. EMS stands for Employee Management System. And then hyphen backend. Project name is same as artifact. So let us keep as it is. And then description, demo project for Spring Boot Employee Management System. Next, package name net.javaguides.ems. Next, keep packaging as a jar. And the configuration, keep properties selected as it is. If you are interested in YML, you can select YML as well. Next, choose Java version 25. Well, as of now, Java 25 is the long-term support release. So we are going to use Java 25. Next, go to the add dependency section over here. Just click on it. And here just search for web. Well, we are going to use Spring Web Dependency to develop the RESTful web services. So Spring Web Dependency internally provides Apache Tomcat as a default embedded container so that we can quickly run our Spring Boot application. So let us select Spring Web Dependency to develop the RESTful web services. Next, we are going to use Spring Data GPA dependency to develop the repository layer. Well, we use Spring Data GPA to reduce a lot of boilerplate code that is required to develop the repository layer or the DAO layer. Spring Data GPA internally uses Hibernate as a ORM framework for the database communication. So let us go ahead and select the Spring Data GPA dependency over here. And then as we are going to use a MySQL server, so we have to use the MySQL JDBC driver to connect our Spring Boot application to the MySQL server. So let us select MySQL driver dependency over here. Alright, so as of now, let us keep these three dependencies. Next, if you want to explore the project structure, you can go ahead and click on the explore button over here. So here, go to the pom.xml file. You can see the Spring Boot version and then Java version, and you can see the dependencies as well, and you can see the plugin as well. Okay. Next, if you expand the SRC folder, you can see this is a standard Maven project structure, and this is the entry point of our Spring Boot application. Okay. Next, go ahead and click on the close button. Next, click on the generate button to generate this project as a zip file, and you can see here the zip file is successfully downloaded. Next, open this zip file in the folder. Next, let us go ahead and extract this zip file. Next, let us open the IntelliJ IDEA and let us import the Spring Boot application. So go ahead and click on the open button over here and then go to the location where your Spring Boot application is present. In my case, it is in a downloads folder. And here I'm going to select EMS backend project. Click on select folder. Now in our Spring Boot application, we are going to use the Lombok dependency to reduce the boilerplate code. Like whenever we create a class, we need to create a getter setter methods, constructors, toString equals hash code methods, right? So instead of creating all these boilerplate code, we can use the Lombok library. So go to the browser, in a new tab, just search for Lombok Maven dependency and go ahead and click on the first link and then click on the latest version over here and then click on the dependency. It will copy to the clipboard and then go to the project, go to the pom.xml file over here and go to the dependency section over here and at the end just paste this dependency. Perfect. Next, here we have a Spring Boot Maven plugin. It internally also provides a Lombok, but it is the old. So let us exclude the Lombok from this Spring Boot Maven plugin. So here just add the configuration tag and then add the excludes tag and then add the exclude and then here just copy the group ID, artifact ID version and then paste over here. So we are basically here excluding this Lombok from this Spring Boot Maven plugin. Next, go ahead and click on this sync Maven changes icon over here. This will sync all the Maven changes. Perfect. Now we have added Lombok dependency to our Spring Boot application. Next, in order to work this Lombok in IntelliJ IDEA, we need to do a couple of settings. So go to the file and here go to the settings and then here just search for annotation and here go to the compiler section over here. Under compiler section you can see annotation processors. So we are going to use the Lombok annotations and IntelliJ IDEA have to recognize those annotations. For that we need to enable the annotation processing. So just tick mark, click on apply and then OK. So apart from this we need to also install the Lombok plugin. So for that go to the settings again and then here just search for plugins. So here go to the plugin section and here just search for Lombok. Well, I have already installed the Lombok plugin in IntelliJ IDEA, but you haven't installed, then make sure to install the Lombok plugin as well. Okay, so these are the settings we have to do in order to work Lombok in the IntelliJ IDEA. Alright, perfect. So in this lecture, what we have done, we have created a Spring Boot project using Spring Initializer, and then we have imported that Spring Boot project in IntelliJ IDEA, and then we have set up the Lombok in a Spring Boot application as well. Okay, great. In next lecture, we will configure MySQL database in our Spring Boot application. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, let us configure MySQL database in a Spring Boot application. Well, let's go to our project in IntelliJ IDEA and go to application.properties file, and within application.properties file, we are going to configure the MySQL database details. Well, before configuring MySQL database details in a Spring Boot application, let us first create a database in a MySQL Workbench. So let's go to MySQL Workbench over here, and here let us type the SQL statement, create database and then followed by database name. Let us give database name as EMS. EMS stands for Employee Management System. Next, let us go ahead and execute this SQL statement and refresh the schemas. And here you can see EMS database successfully created. Next, let's go back to our project in IntelliJ IDEA and go to application.properties file. And within this application properties file, let's configure the MySQL details. So just type the property spring.datasource.url. Next, let us give the JDBC URL that connect to the MySQL database. So here JDBC MySQL and then localhost and then the port 3306 and then followed by the database name, that is EMS. Okay, so this is the JDBC URL that we use to connect to the MySQL database. And look at here the localhost. Well, our MySQL server is running on local machine, that's why the localhost. But if your MySQL server is running on in different machine, then you can specify that machine IP address or the host name over here. Next, let us configure the database username and password. So here just type the property spring.datasource.username. Well, in my case, the MySQL database username is root, but make sure that whatever the database username you have used, you have to mention over here. Next, let's configure the password as well. Spring.datasource.password. Well, in my case, this is the password, but make sure that you replace, the password you have given while installing a MySQL server. Next, let us configure the Hibernate properties. So here, let's first configure Hibernate dilate. spring.gpa.properties.hibernate.dilate, and then let us give the value org.hibernate.dilate.mysql.dilate. Now we have configured MySQL dilate. Well, Hibernate uses this dilate to create the SQL statement based on the database that we are using. In our project, we are using MySQL database, so Hibernate will create the SQL statements that are compatible with MySQL database. Next, let's configure one more property, spring.gpa.hibernate.ddl equal to update. Well, this property is pretty useful in a development environment because this property tells Hibernate to automatically create the database tables if the tables are not existing in the database, and if there are any changes in a JP entities, then it will also tell Hibernate to update those changes in the database tables as well. Alright, great. Now we have configured MySQL details in a Spring Boot application. Next, let us go ahead and let us run the Spring Boot application and let us see whether our Spring Boot application is able to connect to the MySQL server or not. So go to main etiquette class over here, and from here let us run the Spring Boot application, and here click on enable over here, and look at here in the console there are no errors or exceptions. It means our Spring Boot application is successfully connected with MySQL database, and you can see the important information. Spring Boot by default uses Hikari data source and Hikari connection tool. And look at here the Hibernate dilate, MySQL dilate. So this is the dilate we have configured in a application.properties file. Alright, it means we have successfully configured MySQL database in a Spring Boot application. In next lecture, we'll create an employee JP entity. Alright, great, I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to create an employee JP entity. So let's go to our project in IntelliJ IDEA. And here, before creating the employee JP entity, let's quickly create a packaging structure for our Spring Boot application. So go to base package over here, right click, new, and then choose package. Let's give package name as entity. Next, let us create one more new package. Let's call it as controller. Within a controller package, we keep all the Spring MUC controllers, and within the entity package, we keep all the JP entities. Next, let's create one more package. Let's call it as repository. Within a repository package, we keep all the Spring Data JP repositories. Next, let's create one more package. Let's call it as service. Within a service package, we keep all the interface and classes that are related to service layer. Next, let's create one more package. Let's call it as DTO. Within a DTO package, we keep all the DTO classes. Next, let us create one more package. Let's call it as exception. Within exception package, we keep all the custom exceptions. Alright, so as of now, let us keep these packages. Next, go to entity package, right click on it, new, and then choose Java class. Let us give class name as employee. Alright, next, let us go ahead and let us add the instance variables to this class. So here, private long ID, and then private string first name, and then private string last name, and then private string email. Perfect. Next, let us go ahead and let us use Lombok connotations to reduce the boilerplate code. So here let us use add getter Lombok connotation to generate a getter methods for these instance variables. Next, let us use add setter Lombok connotation to generate a setter methods for these instance variables. Next, let us use add no argument constructor notation to create a no argument constructor. Next, let us use add all args constructor to create a parameterized constructor. Okay, now we have created employee Pojo class. Let us make this employee class as a JP entity by using JP annotations. So let us annotate this class with add entity annotation from jakarta.persistence package. Well, we use add entity annotation to specify a class as a JP entity. Next, let us annotate this class with add table annotation from jakarta.persistence package. Well, we use add table annotation to specify the table details. So here let us use name attribute to specify the table name. So let us view table name as employees. Perfect. Next, let us configure the primary key for this employee entity. So here let us annotate the ID field with @ID annotation. So make sure that you choose ID annotation from jakarta.persistence package. Next, let us configure the primary key generation strategy. For that, let us use @generated_value annotation. And next, @generated_value annotation has a strategy attribute. So here let us configure the primary key generation type. So here let us use identity. So this identity primary key generation strategy basically uses database auto increment feature to automatically increment the primary key. Okay. Next, let us use @column annotation to map a database table column with a class field. For example, here let us have a column mapping for this first name field. So let us annotate this first name field with @column annotation from jakarta.persistence package, and let us view the column name first_name. So this column name will be mapped with the first name field. Okay, perfect. Well, if we don't specify @column annotation, then by default JPA will give the column name as field name. Okay, but the column name like first_name makes sense. That's why here we are using @column annotation to explicitly configure the column name for this field. Okay, perfect. Next, let us annotate last name field with @column annotation, and let's view column name as last_name. Next, let us annotate email field with @column annotation, and let us view a column name as email_ID. Next, let us make this email_ID column as a not null by using the label equal to false attribute, and we can also make this email as a unique by using unique equal to true. Alright, now we have created employee JP entity. Next, let us run our Spring Boot application and let us see whether Hibernate will automatically create this employees table in a database or not. So let's go to main_entity class over here. From here, let us rerun the Spring Boot application. When look at here, there are no errors or exception in the console. It means our Spring Boot application is successfully connected to the MySQL server. So let's go to MySQL Workbench and let us refresh the schemas and expand this EMS, expand tables, and there we go. You can see employees table is successfully created. Next, right click on this employees table, select rows, and let us verify the columns ID, email_ID, first name, last name. Alright, so this looks good. So let me recap what we have done in this lecture. We have created employee JP entity and we ran the Spring Boot application, and we have seen that Hibernate is successfully created employees database table in a MySQL database. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have created employee JP entity. In this lecture, we are going to create employee repository. So let's go to our project in IntelliJ IDEA and go to repository package over here. Right click on repository package, new, and then choose Java class. Select interface. Let us give interface name as employee repository. Next, let us extend this employee repository interface from JPA repository interface and make sure that you choose JP repository interface from org.springframework.data.jpa.repository package. Well, notice here JP repository is a generic interface, so we have to pass two parameters. First parameter is the type of the entity. Second parameter is the type of the primary key. So let us select JPA repository over here and let us pass the parameters. First parameter as a type of the entity, in our case employee entity. Next, let us pass the type of the primary key, that is long. Well, if you go to employee JP entity, you can see here we have given the type to the primary key ID as a long. So this long data type we are passing to JPA repository as a second parameter. Okay, perfect. Well, once our employee repository interface extends JPA repository interface, then this employee repository will get a CRUD methods to perform CRUD database operations on this employee JP entity. Alright, so if you go to JPA repository interface source code, you can see JPA repository interface provides these methods, and again JPA repository interface extends list CRUD repository interface and list CRUD repository interface provides all these methods. And this list CRUD repository method internally extends CRUD repository interface, and this CRUD repository interface exposes CRUD methods to perform CRUD database operations. Alright, it means this JPA repository will inherit all the methods from all the extended interfaces. And again, Spring Data JPA will provide the implementation for this JPA repository interface. For example, if you click on this, you will get the implementation classes. And here, Simple JPA repository is a class that implements all the methods of JPA repository interface and its, child interfaces. So just click on Simple JPA repository class over here, and you can see Simple JPA repository class implements JPA repository implementation interface, and this interface internally extends JPA repository interface. It means Simple JPA repository indirectly implements JPA repository interface and its methods. Alright, and if you can notice here, Simple JPA repository class, it is already annotated with add repository annotation, so we don't have to annotate our repository interface with add repository annotation. For example, if you go to employee repository, we don't have to annotate this employee repository interface with add repository annotation, because the implementation class, that is Simple JPA repository class, is already annotated with add repository annotation. And here one more important point is Simple JPA repository class annotated with add transactional annotation. It means all the methods in a Simple JPA repository class are by default transactional. We don't have to use again add transactional annotation in a service layer to make the methods as a transactional. Okay. For example, if you just scroll down, you can see delete by ID method is a transactional because it is annotated with add transactional annotation, and delete method is a transactional because it is annotated with add transactional annotation. Alright. So all the public methods in a Simple JPA repository class are transactional, so we don't have to again use add transactional annotation to make these methods transactional. Alright, just remember these couple of important points, like Simple JPA repository is a class that implements JPA repository interface, and Simple JPA repository class it is already annotated with add repository annotation, so we don't have to again annotate our repository interfaces with add repository annotation. And Simple JPA repository class is annotated with add transactional annotation, so all the methods, all the public methods in a Simple JPA repositories are by default transactional. We don't have to again make those methods transactional by using add transactional annotation. Alright, perfect. So let me recap what we have done in this lecture. We have created an employee repository interface that extends JPA repository interface. So this employee repository will get CRUD methods to perform CRUD database operations on employee JPA entity. In next lecture, we will create an employee DTO and employee mapper classes. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will create an employee DTO and employee mapper classes. So let's go to our project in IntelliJ IDEA. I go to DTO package over here. Right click on DTO package, new, and then choose Java class. Let's give class name as employee DTO. Perfect. Next, let us define the instance variables for this class. So here private long ID, and then private string first name, and then private string last name, and then private string email. Next, let us annotate this class with @getter number connotation to generate a getter methods for these instance variables. Next, let us use @setter number connotation to generate a setter methods for these instance variables. Next, let us use @argument constructor and @argument constructor annotations to create a constructors for this class. Well, we use employee DTO class to transfer the data between client and server. So when we build the RESTful web services, we'll use this employee DTO as a response for REST APIs. Next, let us create an employee mapper class to map employee entity to employee DTO and employee DTO to employee entity. So whenever we build the RESTful services, then we have to convert employee DTO into employee JP entity and employee JP entity into employee DTO, right? So instead of writing the same logic in all the classes, let's create a mapper class and let's keep the common logic. So here what we'll do, we'll create a new package. Let's call it as mapper. Let's create a class let's give class name as employee mapper. And next let us create a static method, public static. Let's give return type as employee DTO, and let's give method name is map to employee DTO. And let us pass employee JP entity as a parameter to this method. And next here return new employee DTO, and let us pass the values to the constructor. So let us get all the values from employee JP entity and let us set those values to the employee DTO. So here employee dot get ID, and then employee dot get first name, employee dot get last name, employee dot get email. Perfect. Now we have created a map to employee DTO method. It will map employee JP entity into employee DTO. Similarly, let's create one more method that will map employee DTO to employee JP entity. So here public static, let us give employee JP entity as a return type. Next let us give method name as map to employee, and let us pass employee DTO as a parameter to this method. Next return object. So let us construct the object of employee JP entity, and here employee DTO dot get ID, employee DTO dot get first name, employee DTO dot get last name, employee DTO dot get email. Alright, perfect. Now we have created map to employee static method. It convert employee DTO into employee JP entity. Alright, perfect. So let me recap what we have done in this lecture. We have created employee DTO class to transfer the data between client and server. And next we have created employee mapper class to map employee entity to employee DTO and employee DTO to employee entity. Alright, great. In next lecture onwards, we will start building the RESTful web services. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we will build add employee REST API. Well, let us take a look into the development steps. First, we will create the service layer. Well, if you can see here, the controller layer depends on service layer, and the service layer depends on a repository layer. And we basically create the REST APIs in a controller layer, right? So controller layer depends on service layer. So let us first create the service layer. Well, we have already created the repository layer, so we don't have to write any methods in a repository layer as of now. So let us first create the service layer, and then we'll build the REST API in a controller layer. Okay. So create the service layer, like we'll create an employee service interface, and then we create an employee service IMP class that implements employee service interface. Next, we'll build the add employee REST API in a controller layer, and next we'll test this add employee REST API using Postman client. Okay. So let us go to our project in IntelliJ IDEA, and here let us first create the service layer. So go to service package, right click on it, new, and then choose Java class, select interface. Let us give interface name as employee service. Within employee service interface, let us define the method. So let us give method return type as employee DTO. Let us give method name as create employee, and let us pass employee DTO as a parameter to this method. Perfect. Next, let us create employee service IMP class that implements this interface and its methods. Next, go to service package, right click on this package, new, and then choose package. Let's give package as IMPL. IMPL stands for implementation. So right click on IMPL package, new, and then choose Java class. Let's give class name as employee service IMPL. Perfect. Next, this class implements employee service interface. And next, go ahead and mouse over in this class, and here you will get the option to implement the methods like the link. So go ahead and click on this implement methods link over here and select the method that you want to implement. Click on OK. Perfect. Next, let us annotate this class with @service annotation, and make sure that you choose service annotation from org.springframework.stereotype package. Well, this annotation tells the Spring container to create the Spring Bean for this class. Next, let us implement create employee method. Well, before implementing this method, let us first inject the dependencies. So here, private employee repository, where we are going to use constructor-based dependency injection to inject the dependencies, and instead of creating the constructor manually, let us use Lombok annotation. So let us annotate this class with at all argument constructor annotation. Okay, now we have injected employee repository as a dependency. Next, let us implement create employee method. So go to create employee method, and within this create employee method, first we need to convert employee DTO into employee JP entity, because we need to store the employee entity into database, isn't it? So here let's say employee equal to, let us call employee mapper class to map employee DTO to employee JP entity. So here employee mapper, it has map to employee method and then pass employee DTO. Okay, now we have converted employee DTO to employee JP entity. Next, let us save this employee JP entity into database. So for that, let us call employee repository. It has a save method and then pass employee JP entity object. Perfect. Next, this save method return the saved employee object. So let us get into a local variable. So here employee, and let us use a variable name as saved employee. Next, we need to return saved employee object back to the client. So here let us convert saved employee JP entity into employee DTO. So here let us remove this null and let us type employee mapper. It has map to employee DTO and let us pass saved employee. Perfect. Now we have implemented create employee method. Next, go to controller package over here. Right click on controller package, new and then to Java class. Let us give class name as employee controller. Next, let us annotate this employee controller class with @REST controller annotation. Well, once we annotate a class with @REST controller annotation, then this class becomes a Spring MUC REST controllers, and this class is capable to handle HTTP requests. Next, let us annotate this class with one more annotation, that is @request mapping annotation. Well, here we are using @request mapping annotation to define the base URL for all the REST APIs that we are going to build within this controller. So here let us give the base URL /API/employees. Okay, perfect. Next, within this employee controller, let us first inject the dependencies. So private employee service, and instead of creating the constructor manually, let us annotate this class with @argument constructor annotation. Okay. Next, let us build add employee REST API. So here let me write the comment, build add employee REST API. Well, creating a REST API using Spring Boot is very simple. First, we need to create a method, and then we will make that method as a REST API by using Spring annotations. So here let's first create a method, public. Let's go return type of the method as a response entity. So response entity is a generic class. We have to pass the type. So here let us pass employee DTO as a type. Next, let us give method name as create employee, and let us pass employee DTO as a parameter to this method. And next, here let us call employee service. It has create employee method and then pass employee DTO object as a parameter to this method. And this create employee method returns a saved employee. So here employee DTO, and let us give the variable name as saved employee. Next, let us have a return statement, return object of response entity. So let us pass value to the constructor. So first value as saved employee, second value as HTTP status code. So here just add HTTP status dot created. Next, let us make this method as a REST API by using Spring annotations. So here let us annotate this method with @postMapping annotation. Well, we use @postMapping annotation to map the incoming HTTP post request to this method. Next, let us use one more annotation here, that is @requestBody annotation. Well, this @requestBody annotation will extract the JSON from the HTTP request, and it will convert that JSON into employee DTO Java object. Okay, perfect. Now we have created add employee REST API. Next, let us run our Spring Boot application and let us test this REST API using Postman client. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running and an embedded template server on port 8080. Next, let's go to the posting client over here, and here let me create a new request. Let us choose HTTP post method, and let us enter the request URL HTTP localhost 8080/API/employees, and next go to the body, select raw, select content.json, and within the body we need to pass the JSON object. So here let's create a JSON object. So first name, let us give first name as Ramesh, and then last name, let us give last name as Partare, and then email, let us give email as ramesh@gmail.com. Well, if you can go to our project in IntelliJ IDEA and go to create employee REST API, and here you can see employee DTO, and if you go inside employee DTO, and this employee DTO class has the fields first name, last name, email, and if you go to Postman client, and if you can notice the JSON over here, the attributes name like first name, last name, email. So whenever you pass the JSON in the request, make sure that the JSON attributes should be same as the DTO class fields, because we are using @request_body annotation here to extract the JSON and convert that JSON into employee DTO Java class object. And in order to convert a JSON into Java object, the JSON attributes and Java object fields should be same. Okay, perfect. Next, let's go to Postman client over here. Next, go ahead and click on send button, and there we go. We got a response of the REST API, and if you can notice here the status 201 created and the saved employee object in the response. Next, let us verify whether this record is stored in a MySQL database table or not. So let's go to MySQL Workbench over here and go to employees database, just refresh, go to employees table, select rows, and there we go. Ramesh employee successfully stored in a employees table. Alright, it means we have successfully built add employee REST API. In next lecture, we will build get single employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build get employee REST API. So let's go to our project in IntelliJ IDEA, and let us first change the service layer, and then we'll change the controller layer, because the controller layer depends on service layer. So let's go to employee service interface over here. Within this interface, let us define the get employee by ID method. So here, let us give employee DTO as a return type of the method, and let us give method name as get employee by ID, and let us pass employee ID as a parameter to this method. Perfect. Now we have defined get employee by ID method in a employee service interface. Next, let us implement this method in employee service IMPL class. So let us go to employee service IMPL class over here, and just mouse over on this class, and here we have implement methods link. So go ahead and click on this link over here, and then select the method that we want to implement. Next, click on OK. Perfect. So here we can implement the get employee by ID method. Well, before implementing this method, let's go ahead and let's first create one custom exception. Well, whenever an employee with a given ID is not exist in database, then we have to throw the custom exception, isn't it? So let us go ahead and let us first create the custom exception. So go to exception package, right click, new, and choose Java class. Let us give exception name as resource not found exception. Perfect. Next, let us extend this class from runtime exception, and then let us create a parameters constructor, public resource not found exception, and then let us pass message as a parameter. Alright, and here let us call super keyword to pass this message to the super class constructor. Next, let us annotate this class with @response status annotation, and let us specify the HTTP status. So here, let us give HTTP status not found. Well, if employee with a given ID is not existing in database, then we will throw this resource not found exception, and then Spring Boot will catch this exception, and it will get the error message from the exception, and it will send the error message along with the HTTP status to the client. Next, let us go back to employee service IMPL class over here. Next, let us implement this getEmployeeById method. So here, let me maximize this. So within the getEmployeeById method, let us call employee repository. It has findById method, and notice here findById method returns optional of type employee. So let us call findById method over here and just pass employee ID. Next, optional has or else throw method. So here let us call or else throw method over here, and notice here or else throw method returns a employee object, and or else throw method takes supplier as a functional interface, and we have to pass the lambda expression implementation of this supplier functional interface. So let us call this or else throw method over here, and let us create the lambda expression. So here lambda symbol and then new resource not found exception, and let us pass the message employee is not exists with a given ID. Alright, and let us pass the ID dynamically over here. That is employee ID. Perfect. Next, let me maximize this a bit. Next, you can see the type over here exists. So let me correct it. Employee is not exist with a given ID, and then employee ID. Next, let me also break this statement. Perfect. So this or else throw method returns an employee object. So here let us take the result of this or else throw method in a local variable of type employee. Perfect. Next, if you can notice here, getEmployeeById method returns the employee DTO. So let us convert this employee JP entity into employee DTO. So go to return statement, remove this null, and let's call employee mapper over here. It has a map to employee DTO method, and then pass employee JP entity object. Perfect. Now we have implemented getEmployeeById method in a employee service IMPL class. Next, let us create the REST API that will internally call this getEmployeeById method. So here let me minimize this and go to employee controller over here, and within employee controller let us build getEmployeeById REST API. So here let me write the comment build getEmployee REST API. Well, creating a REST API using Spring Boot is very simple. We just need to create a method, and then we will convert that method into REST API by using Spring annotations. So here let us first create a method public, and then response entity as a return type. Response entity is a generic, so let us pass employee DTO as a type. And next let us give a method name as getEmployeeById. Next let us pass employee ID as a parameter to this method. Within this getEmployeeById method, let us call employee service. It has getEmployeeById method, and then pass employee ID. Perfect. So this getEmployeeById method returns employee DTO. So here let us take the result of this method in a local variable of type employee DTO. Perfect. Next let us have a return statement. Return response entity. It has a OK method. And next let us pass employee DTO as a parameter to this method. Perfect. Now we have created getEmployeeById method. Next let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add_getMapping annotation. Well, we use add_getMapping annotation to map the incoming HTTP GET request to this method. Next let us pass the ID. Well, this ID is basically called a URI template variable. Next we need to bind the value of this URI template variable to this method argument. So in order to do that, we have to use add_path_variable annotation. So here let us use add_path_variable annotation, and we need to also pass the URI template variable name here, that is ID. So notice here the URI template variable name is ID and the method argument name is employee ID. So both the variable names are different. That's why we have to pass the URI template variable name to the path variable annotation. Then only the path variable annotation will bind the value of this URI template variable to this method argument. Okay, perfect. Now we have created getEmployee REST API. Next, let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here, I want to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us go to Postman client over here and let us create a new request. And here let us choose HTTP GET method, and let us enter the request URL http localhost 8080/API/employees and then /1. Well, if you go to MySQL Workbench over here, and if you go to EMS database and employees table, you can see here we have Ramesh employee, and Ramesh employee has ID 1. So in order to retrieve this, Ramesh employee, we have to pass the ID 1 in the URL. Okay, so let us go back to Postman client, and here we have passed employee ID 1. Okay, next click on send button, and there we go. You can see the response. The REST API return the response, and the response contains the employee object in a JSON format and the status 200 OK. It means we have successfully built get employee REST API. In next lecture, we are going to build get all employees REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build get all employees REST API. So let's go to our project in IntelliJ IDEA over here. And first, we'll change the service layer, and then we'll change the controller layer, because the controller layer depends on service layer. So let us go to employee service interface over here, and within this interface, let us define the method. So let us give return type of the method as list of employee DTO. Next, let us give method name as get all employees. Alright, now we have created get all employees method in our employee service interface. Next, let us implement this method in our employee service IMPL class. Let us head over to employee service IMPL class over here, and just mouse forward in this class, click on this implement methods link. Next, let us select the method that you want to implement. Click on OK. Alright, now let us go ahead and let us implement this get all employees method over here. Within a get all employees method, let us call employee repository. It has find all method. We'll notice here there are multiple overloaded find all methods. We are going to choose the find all method. It doesn't take any method argument, and find all method returns a list of type employee JP entity. Okay, so let us select find all method over here. Next, let us take the result of this find all method in a local variable of type list. So here, let us declare list. List is a generic. Let us pass employee class as a type, and let us call it as employees. Perfect. Now we have list of employee JP entities. But if you can see here, get all employees method returns list of employee DTOs, right? So let us convert a list of employee JP entities into list of employee DTOs. So here go to return statement, remove this null, and here just call employees. So employees is a list. It has a stream method, and then stream has a map method. And notice here map method has a function as a functional interface, and we need to provide the lambda expression implementation for this functional interface. So let us select map method over here. So basically we use map method to map one object into another object. And in our case, we have to convert employee JP entity into employee DTO, right? So here, let us have a lambda expression implementation. So here, let us pass employee as a parameter, and let us have lambda symbol, and then call employee mapper. It has map to DTO method, and then pass employee object. Perfect. And finally, let us call collect method to collect the result. So here we are using list. So now let us call this collect method. It takes to list as a parameter. Now we have written a logic to convert a list of employee JPA entities into list of employee DTOs. Next, let us create the REST API that will internally call this method. So go to employee controller over here, and within employee controller, let us build get all employees REST API. So here, let me add the comment, build get all employees REST API. Well, creating REST API using Spring Boot is very simple. First, we need to create a method, and then we'll convert that method into REST API by using Spring annotations. So here, let us first create the method public response entity as a return type. Response entity is a generic, so let us pass list as a type. List is also a generic interface. Let us pass employee DTO as a type, and let us give method name as get all employees. Alright, and here let us call employee service. It has get all employees method. So get all employees method returns a list of employee DTOs. So here let us declare a local variable of type list. List is generic. Let us pass employee DTO as a type, and let us give variable name as employees. Perfect. Next, let us have return statement, return response entity, and then call its OK method, and then pass employee objects as a parameter. Perfect. Now we have created getAllEmployees method. Let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add_getMapping annotation. Well, we use add_getMapping annotation to map incoming HTTP GET request to this particular method. Alright, perfect. Now we have built getAllEmployees REST API. Next, let us rerun our Spring Boot application and let us test this REST API. So from here, I am going to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running in embedded Tomcat server on port 8080. Next, let us go to Postman client over here. And here, let me copy this URL and let me create the new request. Let us choose HTTP GET method and let us enter the URL. Localhost 8080/API/employees. Click on send button. And there we go. You can see the array contains a single JSON object. So let us insert one more employee. So go to add employee request over here and let us change the JSON. Post name, let us say Sanjay. Last name, let us say Jadhav. Email sanjay@gmail.com. Next, click on send button and there we go. We got the response and the status code 201 created. Next, let us go to getAllEmployees request over here and then click on send button and there we go. You can see here there are total 2 employees and in a response also there are 2 employees. Next, let us insert one more employee. So go to post request and here let us give first name as Tom and last name Cruz. Email tom@gmail.com. Click on send button and there we go. We got the response with the employee ID 3. Next, let us go to getAllEmployees request over here. Click on send button and there we go. You can see a Tom employee is present in a array. Okay, it means we have successfully built getAllEmployees REST API. Let us also verify the database table. So go to MySQL Workbench, go to employees table, select rows and notice here there are total 3 employees. And if you look at the response of the REST API, there are total 3 employees, 3 employee JSON objects present in the array. Okay, it means we have successfully built getAllEmployees REST API. In next lecture, we will build updateEmployee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build updateEmployee REST API. So let us go to our project in IntelliJ IDEA. Well, first we want to change the service layer and then we will change the controller layer because the controller layer depends on service layer. So let us go to employee service interface over here. Within this interface, let us define the method. So here let us give employee DTO as a return type of the method and let us give method name as updateEmployee and let us pass employee ID as a post parameter and employee DTO as a second parameter. And this employee DTO basically contains the updated employee details. Okay, so let us call it as updated employee. Okay, perfect. Now we have defined updateEmployee method in an employee service interface. Next, let us implement this method in an employee service IMPL class. So let us go to employee service IMPL class over here. Just mouse over in this class, click on this implement methods and then click on OK method. Now let us go and let's implement updateEmployee method. Within updateEmployee method, let us first add the validation like if employee with a given ID is not existing database, then we have to throw the resource not found exception, isn't it? So let us write that logic here. So just call employee repository. It has find by ID method and notice here find by ID method returns optional of type employee. So let us call find by ID method over here and then pass employee ID as a parameter and then optional has or_else_throw method. So let us call or_else_throw method over here. And notice here or_else_throw method takes supplier as a functional interface and we have to provide the lambda expression implementation for this supplier functional interface. So just call this method and then let us construct the lambda expression. So here new resource not found exception and then let us pass the custom exception message. Let us say employee 8 employees not exist with given ID and then pass employee ID dynamically. Perfect. Next, let me put the semicolon over here. Alright, and this or else throw method returns a employee object. So here let us take the result of or else throw method in a local variable of type employee. Perfect. Next, we have the updated employee object. It contains all the employee updated information. So let us set all the details from updated employee object into this employee object. Okay, so here employee dot set first name, and then updated employee dot get first name, employee dot set last name, and then updated employee dot get last name, employee dot set email, and then updated employee dot get email. Perfect. Next, let us call employee repository. It has a save method, and then pass this employee object. Okay, so here basically we have updated this employee object with first name, last name, email, and again we are saving this employee object by using save method. So basically this save method performs both save and update operation. Well, if employee object contains ID, then this save method internally perform the update operation, and if employee ID doesn't contain the primary key ID, then it will perform the insert operation. Alright, next this save method returns the updated employee object. So here let us declare the updated employee object like this. Perfect. Next, if you can see here, update employee method returns the employee DTO. So let us convert this updated employee object JP entity into employee DTO. So here go to return statement, remove this null, and then call employee mapper. It has map to employee DTO method, and then pass updated employee object as a parameter. Now we have implemented update employee method in a employee service IMPL class. Next, let us create the REST API that will internally call this update employee method. So go to employee controller over here. Within employee controller, let us build update employee REST API. So here, let me first write the comment, build update employee REST API. Let us first create a method, and then we'll convert that method into REST API by using Spring annotations. So here just type public response entity, and then pass employee DTO as a type. Let us give method name as update employee. Alright, and let us pass employee ID as a first argument and employee DTO as a second argument. So this employee DTO is nothing but updated employee information. Perfect. Next, let us call employee service. It has update employee method, and then pass employee ID as a first parameter, updated employee as a second parameter. Perfect. Next, this update employee method returns the employee DTO. So here let us have a local variable of type employee DTO. Alright, next let us have a return statement, return response entity, and then call OK method, and then pass employee DTO. Alright, now we have created update employee method. Let us make this method as a REST API by using Spring annotations. So let us annotate this method with @putMapping annotation. Well, we use @putMapping annotation to map incoming HTTP put request to this method. Next, let us pass the ID. So here is the syntax. Within a open and close curly braces, just pass the ID. So this ID is nothing but a URI template variable, and we need to bind the value of this URI template variable to the method argument. So in order to do that, we can use @path variable annotation over here. And next, let us pass the URI template variable, that is ID. Perfect. Next, we need to use one more annotation, that is @requestBody annotation. Well, this @requestBody annotation will basically extract the updated JSON from the request, and it will convert that JSON into employee DTO Java object. Okay, perfect. Now we have built update employee REST API. Next, let us rerun our Spring Boot application, and let us test this REST API using Postman client. So from here, I am going to stop and rerun the Spring Boot application. Well, notice here our Spring Boot application is up and running in an embedded Tomcat server on port 8080. Next, let us go to Postman client over here, and here let me copy this URL and let me create the new request. And here let us choose HTTP put method, and let us enter the request URL localhost 800/API/employees, and then we need to pass the employee ID that we want to update. So let us say we want to update the employee with ID 1. Alright, next let us pass the updated information in the body. So click on body, raw, content type JSON, and here we need to pass the JSON. So here let me quickly create the JSON. First new. Well, if you go to MySQL Workbench and go to employees table over here, and if you look at here, employee ID 1 has a first name Ramesh, last name Partare, email ID ramesh@gmail.com. So let us update all these 3 column values. So let us update the first name from Ramesh to Ram, last name from Partare to Jadhav, email ID ramesh@gmail.com to ram@gmail.com. Alright, so let us go back to Postman client, and here let us give the updated first name, that is Ram, and last name Jadhav, email ram@gmail.com. Next, go ahead and click on send button over here, and there we go. You can see the response. The post name is updated, last name is updated, and email is also updated. Let us verify this information in database table as well. So let us go back to MySQL Workbench, and here let us select rows from employees table. Notice here the employee ID 1, the post name is changed from Ramesh to Ram, last name is changed from Partari to Jadhav, email ID is changed from ramesh@gmail.com to ram@gmail.com. It means we have successfully built update employee REST API. Alright, great. In next lecture, we will build delete employee REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to build delete employee REST API. So let's go to our project in IntelliJ IDEA over here. Well, first we'll change the service layer, and then we'll change the controller layer, because the controller layer depends on service layer. So let us go to employee service interface over here, and within this interface, let us define the method. So let us give void as a return type of the method, and let us give method name as delete employee, and let us pass employee ID as a parameter to this method. Next, let us go ahead and let us implement this delete employee method in our employee service IMPL class. So go to employee service IMPL class over here, just mouse over this class, click on this implement methods, and choose the method that you want to implement. Click on OK. Alright. Next, let us go ahead and let us implement this delete employee method. So here, first of all, we need to add the validation, like if employee with a given ID is not exist in database, then we have to throw the resource not found exception, isn't it? So if you go to update employee method over here, here we have already written the logic. Okay. So let us copy this piece of code and go to delete employee method, and here just paste this piece of code. So here basically we are calling find by ID method, and this find by ID method returns optional. So again here we are calling or else through method of optional object, and here basically we are providing the lambda implementation of supplier functional interface. So basically if employee with a given ID is not exist in database, then this piece of code will basically throw the resource not found exception. Next, let us call employee repository. It has delete by ID method, and then pass employee ID as a parameter to this method. Okay, perfect. So this delete by ID method will basically delete the employee by ID. Alright, next, let us create delete employee REST API that will internally call this method. So go to employee controller over here. Within employee controller, let us build delete employee REST API. So here let me write the comment first. Build delete employee REST API. So first we'll create a method, and then we'll convert that method into REST API by using Spring annotations. So here just type public, and then response entity as a return type. So let us pass string as a type, and then let's give method name as delete employee. Alright, and let us pass employee ID as a parameter to this method. Perfect. Next, within our delete employee method, let us call employee service. It has delete employee method, and then pass employee ID. Next, let us have a return statement, return response entity dot OK. And let us pass the success message, that is employee deleted successfully, something like that. Perfect. Now we have created delete employee method. Let us make this method as a REST API by using Spring annotations. So here let us annotate this method with add delete mapping annotation. Well, we use add delete mapping annotation to map the incoming HTTP delete request to this method. Next, we need to pass the ID to this annotation. So here within a curly braces, just pass the ID. So this ID is nothing but a URI template variable, and we need to bind the value of this URI template variable to the method argument. So in order to do that, we can use add path variable annotation and then pass URI template variable name. Perfect. Now we have built delete employee REST API. Next, let us rerun our Spring Boot application and let us test this REST API using Postman client. So from here, I want to stop and rerun the Spring Boot application. Well, our Spring Boot application is up and running. Next, let's go to Postman client over here. And here, let me copy this link and let me create a new request. And here, let us choose HTTP delete method. And let us enter the request URL localhost 800/API/employees. And here we need to pass the employee ID that we are going to delete. For example, let us say we want to delete the employee with ID 1. Then we have to pass the employee ID 1 in the request URL. Next, if you look at the database table, employees table. So employees table has the employee with ID 1. Okay. Now we are going to basically delete the employee with ID 1 from the employees table. So let us go back to Postman client and go ahead and click on send button over here and look at here the response, employee deleted successfully and the status code 200 OK. Next, let us go to MySQL Workbench, go to employees table, select rows and look at here the employee with the ID 1 is successfully deleted from the employees table. It means the delete employee REST API is working as expected. Next, let us delete one more employee, like we are going to delete an employee with ID 3. So let us go back to Postman client and here let us pass the employee ID that we are going to delete. We are going to delete employee with ID 3. Next, click on send button and there we go. We got the response, that is success response. Next, let us go to MySQL Workbench, select rows from the employees table and there we go. You can see here the employee with ID 3 is successfully deleted from the employees table. Alright, it means the delete employee REST API is working as expected. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to create and set up React application for our employee management system. Well, in order to create the React application, we are going to use Vite.js build tool. Well, Vite.js is a build tool that aims to provide the faster development experience. For example, if you go to browser and in a new tab, just type Vite.js and go ahead and click on the first link and click on the guide tab over here. So Vite is a build tool that aims to provide a faster and learner development experience for modern web projects. And this Vite.js provides a development server to run the React applications, and it will also provides a build command to bundle the React application. Okay, so basically Vite is a build tool that aims to provide a faster and learner development experience for modern projects. And you can see here Vite supports different types of templates, like you can use JavaScript or TypeScript. In this project, we are going to use JavaScript to build the React application. Well, in order to use Vite.js build tool to create the React application, you have to install the Node.js and npm. Well, in order to install the Node.js, you can just go to official documentation download page and you can go ahead and download the Node.js as per your operating system and you can install it in your machine. Well, npm comes with Node.js, so you don't have to install npm separately. Alright, well, let us first create the workspace for this React application. So here I am going to create a folder in a desktop. You can create a folder anywhere on your file system. So here I am going to create a workspace folder in a desktop. So let me call it as full stack. Alright, within a full stack folder, we are going to create the React application. Next, let us open the Visual Studio Code ID in a full stack folder. So here, let me first open the Visual Studio Code ID over here. And here, go to File, Open Folder. and go to desktop, select full stack folder, click on open. Now we have opened Visual Studio Code ID in a full stack folder. Next, let us go ahead and let's create the React application using Vite.js. So here I am going to use the inbuilt terminal. So go to terminal, click on new terminal over here. Alright, and here let me maximize this. And here let us type the command npm create Vite@latest and then followed by the React application name. So here we are going to give the project name as EMS-frontend. Well, EMS stands for Employee Management System, and this is basically a front end. Well, if you can notice here we are using the latest version of Vite. That's why I have mentioned @latest. Okay. Next, go ahead and hit enter. I look at here, it gives the options like select the framework. Well, we are going to use React. So let us select the React and hit enter. Next, we need to select the variant. Either we can use TypeScript or JavaScript. So let us use the JavaScript. So here let us select JavaScript and hit enter. And there we go. You can see scan folding project is created under full stack folder. And if you can see here, EMS frontend, React application is created under full stack folder. Well, if you can notice here, within a fraction of seconds, the Vite.js created the React application. Alright. Next, let us use these commands to install and run the React application. Well, first of all, we need to move into our project by using this command. So here just type cd and then EMS frontend. Now we are in a EMS frontend project folder. Next, let us type npm install and hit enter. So this will install all the dependencies required for our React application. So it will take a couple of seconds. So just wait a couple of seconds and there we go. All the JavaScript libraries are installed, and if you expand EMS frontend over here, you can see node_modules folder is created, and within this folder, npm install command will keep all the downloaded JavaScript packages. Alright, perfect. Next, we need to run the command. So let me check the command npm run dev. So in order to run the React application using Vite.js, we have to run this command. So this command will run the React application in a development server. So here, let me first clear the terminal and just type npm run dev and hit enter. And notice here, the React application is up and running in a development server on port 5173. So here, let us copy this URL and go to the browser. In a new tab, just paste this URL, hit enter, and there we go. You can see Vite plus React. Okay. Next, let's go back to our project. And if you can notice the port over here, 5173. So let us change this port from 5173 to 3000. Well, Vite.js provides a configuration file named vite.config.js. So within this JS file, we can configure the development server related details. For example, here, let us create a server section. So this is basically an object, and within that, let us have a port, and let us give port 3000, and then just save this file. And notice here, as soon as we save the file, the development server port is changed from 5173 to 3000. Okay, next, if you go to browser and if you refresh here, it says this site can't be reached because we have changed the port. So here, let us view the port 3000. Hit enter, and there we go. Now you can see the React application is up and running. Okay, so this is how we can change the port of our development server. Alright, perfect. Well, let me recap what we have done in this lecture. We have created the React application using Vite.js. So basically, we have used a couple of commands like npm create Vite@latest and then followed by project name. So this is the command that we have used to create a scan folding project for our React application. Next, we have used npm install to install all the JavaScript packages or libraries for our React application. Next, we have used npm run dev command to run the React application in a development server. Alright, it's pretty simple. Just we have to use these couple of commands to create and run the React application. In next lecture, we'll understand the folder structure of our React application. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In previous lecture, we have created and set up React application. In this lecture, we are going to understand the React application project structure. Well, if you go to VS Code, here we have our React application. Next, let us understand the important files and folders of our React application. So let us begin with package.json file over here. Well, package.json file basically contains all the required dependencies and scripts required for our React application. For example, if you can go to dependence section over here, you can see the React library and its version, that is 18.2.0. React DOM is a library, its version 18.2.0. Okay, so within our dependence section, we configure all the dependencies required to our React application. Next, you can see the dev dependencies, and these are the dependencies for our development. Next, here we have scripts to run the React application, to build the React application, and to preview the React application. And here we have React application name, React application version, and the type like module. Alright. So basically in a package.json file, we configure all the dependencies and scripts required for our React application. And whenever we run the npm install command, then npm install command will install all the dependencies and scripts. Okay. Next, we have v.config.js file. So within this JS file, we can configure the plugins and development server related details. For example, here you can see plugin section. So within this plugin section, we can configure all the plugins, and within the server section, we can configure the development server related details. Alright. Next, we have an index.html file. When we use React.js to develop the single page application, and in typical React application, you can find only one HTML file named index.html file. And if you go to index.html file code over here, especially if you go to body contains a single div with ID root. When React uses this div to render the component. Next, we have node_modules folder. Well, whenever we run npm install command, then npm will create this folder and it will keep all the downloaded JavaScript libraries and packages within this folder. Next, we have public folder. Within a public folder, we can keep all the static files like images and SVGs. Next, we have a src folder. So all the development related things will go inside a src folder. So if you expand src folder, you can see here main.jsx file. Well, main.jsx file is the main entry point for a JavaScript. For example, if you go to index.html file, within index.html file, the main.jsx file is imported using script tag, right? So whenever we run the React application, then index.html file will serve in the browser, and then it will internally call this main.jsx file. It means main.jsx file is a main entry point for all the JavaScript related code. And within a main.jsx file, you can see react dom.create root and document.getElementById and then root. Well, this root is basically div ID. If you go to index.html file again, you can see here div has ID root, right? So again, if you go to main.jsx file, so here we are getting the div by div ID. And next, this react dom again call the render method to render the component in a div. Okay, so basically React DOM uses create root method to get the div by div ID, and then again it will call the render method to render this app component within that div. Just remember, this piece of code is responsible to render the top level component in a div. Next, let us move into index.css file. So this CSS file contains all the CSS related code. Next, this is the default generated CSS code, so we can simply remove this code. Next, go to app.jsx file. So this JSX file contains an app component. So app component is a base level component or a root component, and this is the auto generated code. So what we can do is we can remove this code. Okay, we can write our own code over here. Alright, so here also let me remove this code. Let me remove the imports as well. Perfect. Next, go to app.css file. So here we can configure all the application level CSS classes. Okay, so here this is the auto generated code. So let me remove this. Next, go to assets folder. Within assets folder, we can keep the static files like SVG and images. So these are the important files and folders in our React application. Next, let us understand how the flow goes whenever we run the React application. Okay. So whenever we access the React application from the browser, then index.html file will get served in a browser. And then within an index.html file, you can see script tag. Here basically imported main.jsx file, right? So next main.jsx file will get called, and within a main.jsx file, you can see here react.createRoot method. So this createRoot method will get the div by using the div id root, and then it will again call the render method to render this app component within that div. Next, within an app component, we can write the code. For example, here go to return statement, and here let me write something like heading. So here let us use h1 tag to write the heading, for example hello world. Next, let us save the file, and you don't have to restart the development server. The changes will be automatically reflected. Next, let us go to browser, and you can see here hello world heading is displayed in a web page. Okay, so this is how the flow goes whenever we run the React application. Okay, so whenever we run the React application, the index.html file will get served in the browser, and then index.html has a script main.jsx. This script will be loaded in a browser, and then this script is responsible to render the component. Okay, next, if you go to a browser, so here just inspect this page, and if you go to console over here, you can see download the React DevTools for a better development experience. So go ahead and click on this link, and from here we can download the extension. So here I am using Chrome, so let me install the extension for Chrome over here, and click on add Chrome, click on add extension. Alright, so this React developer tools is pretty useful. We can track the components. So here let me close this. Next, go back to our React application, and here let us refresh our React application, and here you can see the components. So here let me use this side, and you can see the components. So go ahead and click on components over here. Right now we have only one component, that is app component, and you can see its details like the source is main.jsx. It means the app component is imported in this source file, that is main.jsx file. Okay, next what we will do, we'll quickly create one more component, and we will import that component in this app component. So let's go back to our project, and here let me quickly create a file. Let's call it as hello world.jsx. Well, either you can use JS extension or JSX extension. Next, within a hello.jsx file, let's create one functional component. So here let us type function. Let us give component name as hello world. Alright, and let us export it. Export default hello world. Next, within a functional component, let us write the JSX code. So first of all, let us have a return statement, and then let us use h1 tag to print the heading hello world. Perfect. Now we have created a simple functional component named hello world component. Next, we have exported this hello world component as a default. So let us import this hello world component in app component. So go to app.jsx file over here. Let us remove this, and notice here this tag is basically called a fragment. Okay, so this is an empty tag basically. So this tag in React is called a fragment. Within a fragment tag, let us import hello world component. So make sure that hello world component is imported at the top. Perfect. Next, save this file, and let's go to browser and just refresh this page and go to components, and here you can see the component tree structure, app component. Within that we have a hello world component. So this is how you can track the components like the parent component and its child components. Alright, great. In next lecture, we will see how to install Bootstrap in a React application using npm. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to add a Bootstrap to our React application using NPM. Well, Bootstrap is a CSS framework that we can use to style the web pages, and basically we can create the responsive web applications. Alright, so installing Bootstrap in a React application is very simple. We just have to run the npm install command to install Bootstrap in a React application. Okay, let's go to our project in Visual Studio Code ID, and here let's open a new terminal. So go ahead and click on this plus icon over here. Next, let us go inside our project. Just type the command cd ems frontend, and in order to install the Bootstrap in a React application using npm, just type the command npm installed and then followed by Bootstrap. Next, ---- save. Well, this ---- save option will add the Bootstrap dependency entry in a package.json file. Next, let us hit enter. And there we go. Bootstrap library is installed in our React application, and you can see the Bootstrap version 5.3.0. As of now, the Bootstrap CSS library version is 5.3.0. Next, let us verify in a package.json file. So go to package.json file, and you can see the dependency section, and within that we have Bootstrap library and its version 5.3.0. It means we have successfully installed a Bootstrap using npm. Next, we need to import the appropriate CSS file in a React application. Well, if you go to node_modules folder and just search for Bootstrap folder over here, and within a Bootstrap folder we have dist. Within a dist we have CSS. Within that we have Bootstrap min.css. So this is the CSS file we have to import in order to use the Bootstrap CSS classes. Alright, so let us go ahead and let us import this bootstrap.min.css file. So go to main.jsx file. So main.jsx is the entry point. So here let us import the bootstrap.min.css file. So just type import and then Bootstrap, and then Bootstrap folder has a dist folder. Within dist folder we have CSS folder. Within that we have bootstrap.min.css file. Perfect. Now we have imported bootstrap.min.css file. Next, we are good to use Bootstrap CSS classes. So in order to test that, what we can do is we can use one of the Bootstrap CSS class. So go to hello.jsx file here, and here we have reload component. So let us display this hello world heading at a center using Bootstrap CSS class. So here go to h1 tab and just call class name property, and then pass the CSS class name, that is text center. So this is the Bootstrap CSS class that we can use to display text at a center. Next, let us save this file and let us go to browser, and notice here the hello world heading is displayed at a center. It means we have successfully installed Bootstrap CSS library in a React application. Alright, well, let me recap what we have done in this lecture. We have installed a Bootstrap library using npm install bootstrap --save command. Next, we have imported bootstrap.min.css file in a main.jsx file. Next, we have used one of the CSS class, that is text center Bootstrap CSS class, to test the Bootstrap installation in a React application. In next lecture onwards, we will start implementing list employee feature. Alright, yet I will see you in the next lecture. Hi everyone, welcome back. In next couple of lectures, we are going to implement list employee feature in a React application. Well, if you look at the screenshot over here, we are going to design the UI that looks something like this. Okay, so basically we are going to create a web page. It will display a list of employees in a table. Alright, in this lecture, we are going to create a list employee component, and in upcoming lectures, we are going to connect our React application to the REST API, and we will populate the response of the REST API in a list employee component. Alright, so in this lecture, let us focus on creating React list employee component. Well, here are the development steps. First, we will create a React functional component named a list employee component. Next, we will prefer the dummy data to display in the HTML table. Next, we will write the JSX code to display list of employees in a HTML table. Next, we will import and use list employee component in a app component. And finally, we will test all these changes. Okay, So the first step is create a React functional component named list employee component. So let us go to our project in VS Code, and here go to SRC folder. Within that, let's create a new folder and let us call it as components. Perfect. So within a components folder, let's create a file. Let us give name as list component or list employee component. Next, let us give extension as JSX. Perfect. Next, within this file, let's create a functional component named the list employee component. Well, instead of writing the same code to create the functional component, what we can do is we can use the code snippets. Well, VS Code has extension that is React code snippets. So we can use this extension to quickly create the code snippets or the templates. Okay. For example, go to extensions over here and here just search for React snippets. Alright, and you can see the extension over here, ES7 plus React Redux Reactive Native snippets. So just click on it and go ahead and install this extension. Well, this extension is pretty useful because this extension provides a commonly used code snippets. Okay, so go ahead and install it. So I have already installed, that's why you can see uninstalled. So let me quickly uninstall it. So you can see the install button over here. So go ahead and just click on it. So once you install it, you can use the React code snippets. Alright, perfect. Next, go to list employee component.jsx file. So let me close this. Alright, so here let us use React code snippets command to create the functional component. So just type React functional component export and hit enter, and there we go. You can see we got the functional component code snippet. So instead of typing the same code, what we can do is we can use this kind of code snippets to quickly create a code like this. Okay, well, notice here we are using JavaScript function to create the functional component, but we can also use JavaScript arrow function to create the functional component. Well, I prefer using arrow functions over a JavaScript function. So here let us go ahead and let us use JavaScript arrow function. So you can also use the plain JavaScript function as well. Alright, so here let me remove this and just type the command React arrow function component export. Okay, just type RAFCE. So this gives React arrow function export component like this. Okay, perfect. Next, let us take a look at the next step. Next step is prefer dummy data to display in a HTML page. Well, in HTML table, we need to display something, right? For that, let us prefer the dummy data. So let's go back to list component over here. Within a list employee component, let's create an array. So const, let us give variable name as dummy data. So this is the array. So within array, let us create a employee object. So here first name, let us give ID first, ID1, and then first name Ramesh, last name Padpare, and then email ramesh@gmail.com. Perfect. Now we have created one object in array. Next, let me copy this. Let me create few more objects. So here ID2, and then first name Ramesh, last name Padpare, email Umesh. Next ID3, and here let's give first name Rajkumar, last name Padpare, email rajkumar@gmail.com. Perfect. Now we have created a dummy data to display in the HTML table. Next, let us take a look into next step. Next step is write JSX code to display list of employees in a HTML table. So let us go and let us write the JSX code to display the dummy data in a HTML table. So let's go back to our component, and here go to return statement. So let me maximize this. So go to return statement and let us remove this. Alright, so here let us first have a page heading. Let us say list of
employees. So this is the page heading. Next, let's create the HTML table. So here table, and within table we have table header. Within a table header we have table columns. So the table column should be in a table row. Perfect. Let us give a column name as employee name or employee first name. Perfect. Next, let us give one more column name, that is employee last name. Next, let us have one more column, employee email ID. Perfect. So we can also display the ID as well. For that, let's create one more column over here. Let's call it as employee ID. Perfect. Now total we have 4 columns. Next, after table heading, let's create a table body. For that, let's have table body as table element. And next, let us have table row. Well, here we have an array. We need to iterate over array and we need to display each object in a table row, right? So for that, what we can do is we can write the JavaScript code over here. So in order to write the JavaScript code within a JSX, we need to use open and close curly braces like this. So here let us call dummy data array. It has a map method. So let us call map method over here. And notice here map method takes a callback function. So let us pass the arrow function. Well, we can use map method to iterate over an array and display each object. So here let us pass the arrow function. So we can pass the employee object as a parameter to the arrow function and then plat arrow symbol. And then here let us have a tr element, that is table row. Alright. So here let us remove this tr element because we need to iterate over an array and we need to display each row, right? Perfect. Next, each row should have a unique key. For that, let us use key attribute over here. And then within a curly braces, just pass employee.id. Alright, perfect. Next, within a table row, let us display the table data. For that, let's have a table data element. And then within a curly braces, employee.id. So this value should be populated in a employee ID table column. Next, table data element within a curly braces, employee dot first name. Next, td within a curly braces, employee dot last name. Next, td within a curly braces, employee dot email. Perfect. Now we have written a code to iterate over an array and display each object in a row. Okay, perfect. Next, let us take a look into next step. Next step is import and use list employee component in an app component. Next, let's go back to our project and go to app.jsx file. And here instead of hello world, let us import list employee component. So here, just call list employee component. Just close it and make sure that list employee component is imported at the top. Okay, so here we have unused import, so let us remove it. Perfect. So let us take a look at the next step. Next step is run and test the React application. Well, let us go back to our project and let us see our React application is running or not. So here go to the first terminal and notice here our React application is up and running. Next, let us go to browser and look at here the list of employees is displayed in the table, but the UI not looks good. So let us go and let us use Bootstrap CSS classes to style this page. Okay, so let us make this page beautiful by using Bootstrap CSS classes. So here just search for Bootstrap CSS or Bootstrap 5 container. So we are using Bootstrap 5, so just search for Bootstrap 5 container and click on the first link. So here you can see we have 3 containers: container, container payload, and custom container. So let us use this container CSS class to display this data in a container. Okay, so let us go to Visual Studio Code ID and go to list employee component and go to this div over here, and here let us use class name property and just paste this container CSS class. Okay, just save this file and let's go back to browser. And now you can see here this list of employees page, displayed in the container. Next, go to new tab and here just search for Bootstrap 5 table. Click on this first link and you can see the Bootstrap CSS class table. So let's copy this and go back to VS Code and go to table element, and here let us use class name property and just paste this table CSS class. Next, go back to browser. Let us use few more Bootstrap CSS classes. So here let us use table stripped. So let me copy this and let me paste it over here, and let us use one more CSS class, that is table bordered. Okay, so this is the table bordered. Okay, next let's go back to browser and go to our React application, and there we go. Now you can able to see the table looks good, right? And you can look at the page heading. The page heading should be displayed in a center, right? So let's go back to our code, and here let's use Bootstrap CSS class, that is text center. Let us save this file and let's go back to browser, and there we go. You can able to see list of employees table is displayed at a center. Alright, well, let me recap what we have done in this lecture. We have created a functional component named list employee component. Next, we have preferred a dummy data to display in the HTML table. Next, we have written a JSX code to display a list of employees in the HTML table. Next, we ran the React application and we have seen that a list of employees is displayed in a HTML table, and we have also used a Bootstrap CSS classes to style this list of employees page. Alright, great. In next lecture, we will connect our React application to get all employees REST API and will populate the response of that REST API in a table. So instead of displaying the dummy data, we are going to display the real data that we will get from the REST API. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to connect our React application with get all employees REST API. Well, here are the development steps. First, we'll install Axios library. Well, in order to make a REST API call in a React application, we have to use third-party HTTP library. Well, in this project, we are going to use Axios third-party library to make a REST API call in a React application. Next, we will create an employee service.js file. Next, within this employee service.js file, we are going to write a REST client code to make a REST API call using Axios API. Next, we will change list employee component to display the response of the REST API. Well, instead of displaying the dummy data, we are going to display the response of the REST API in a list employee component. And finally, we are going to test all these changes. So first step is install Axios library. So let us go to our VS Code and let us first install the Axios library. So here, go to the terminal over here. So go to second terminal, and here let me clear the terminal first. So in order to install the Axios, we have to use the command npm install and then Axios --save. So this is the command that we use to install the Axios. So just hit enter. Notice here the Axios is installed. So let us confirm. So go to package.json file and go to dependency section, and notice here the Axios library is successfully installed. Next, let us take a look into next step. Next step is create employee service.js file, and within this file, let us write the REST client code to make a REST API code using Axios API. So let us go back to VS Code and here go to SRC folder. Within that, let's create a new folder. Let's call it as services. Within a services package, let's create a new file. Let's call it as employee service.js. Next, within this employee service.js file, let us write the REST client code to make a REST API call using Axios API. So here, let me minimize this. So here, let us import Axios object from the Axios library. So once we got the Axios object, next we can call its APIs. Next, let's declare the constant. Let us give variable name as REST API base URL equal to. So here let us give the base URL for our Spring Boot project, that is http localhost 8080/API/employees. So this is the base URL for all the REST APIs for employee resource, right? Next, let us create a JavaScript function. Within that, we make get all employees REST API. So here, let us use JavaScript arrow function and let us export that function. So let us use export keyword to export the function and then const, and then let us use the variable name list employees and then flat arrow symbol within a open close braces. Let us have a return statement and then axios dot get method and then pass REST API base URL. Perfect. Now we have written a REST client code to make get all employees REST API call. Alright, and notice here this JavaScript arrow function has a body, and within the body there is only one statement, right? So we can even simplify this function. So for example, let us remove this open curly braces and return keyword and also the close curly brace. Okay, so this is the simplified version of this JavaScript arrow function. Okay, perfect. Now we have written a REST client code to make get all employees REST API. Next, let us take a look at the next step. Next step is change list employee component to display response of the REST API. So let us go to list employee component over here, and within list employee component we have a dummy data. So let us remove this dummy data. So we want to display the response of the REST API instead of dummy data. Alright. So in order to hold the response of the REST API, we have to use the state variable. And in a functional components, in order to define the state variables, we have to use state hook. Okay. So just remember, use state hook allows us to use state variables in a functional component. Alright. So in order to use state hook, we have to first import use state hook at the top. So here, let us have open close curly braces, and within that just import use state hook and make sure that you use state hook from React library. Alright. Next, use state hook is just a JavaScript function. So let us call use state hook, and use state hook takes the parameter. The parameter is the initial value of the state variable. So in this case, let us give empty array. Next, use state hook returns an array with exact two values. First is a state variable, second is a function that updates the state variable. So here const and then array. So array should have two values. First is the state variable name, for example in this case employees. Second value as a function that updates the state variable. So the function name is set employees. Okay, just remember, use state hook allows us to define the state variables in a functional components, and this is the syntax to use state hook. Okay, so use state hook is just a JavaScript function. We can pass the initial value to this use state hook, and use state hook returns an array with exact two values. First is the state variable, second is the function that updates the state variable. Next, in order to make the REST API call or the AJAX call in a React functional components, we have to use effect hook. For example, here let us call use effect and make sure that you choose use effect hook from React library, and make sure that use effect hook is imported at the top from the React library. Alright. Next, notice here use effect hook takes two parameters. First parameter is the callback function, second parameter is the dependency list. So here let us pass arrow function as a callback function, and second parameter is a dependency list. As of now there is no dependency, so let us keep empty array like this. Next, within a use effect hook, let us call list employees method from employee service, and this method has a then method, and look at here, then method takes a promise object. So let us have a promise object over here. A response is a promise object. Next, let us have an arrow function. Alright. Next, let us go ahead and let us set the response to this employees state variable. So in order to do that, we can use set employees method. So here just call set employees and then pass response dot data. Perfect. Next, let us have a catch block over here. So if there are any errors while calling the get all employees REST API, that we can catch here and we can display that error to the console. So here let us pass error object. So in order to display this, let us use arrow function over here and then console dot error and then pass error object. Perfect. Now we have written a logic to get the response of the REST API and store that data in a employees state variable. Next, scroll down and here you can see dummy data. We are not using dummy data variable. We are using employees state variable, and this employee state variable holds the response of the REST API, right? The response is basically list of employees, and here we are using map method to iterate over this employees array and display employees in a table. Next, let us save this file and let's go to browser and just refresh. And here you can see the issue blocked by CORS policy issue. Well, React application is running on port 3000 and Spring Boot application is running on port 800. Both the applications are running on different ports. That's why the browser typically gives this kind of CORS policy error. Alright. So now in order to solve this issue, what we need to do is we need to handle this kind of CORS policy issue at a Spring Boot application. So Spring Boot provides CORS origin annotation that we can use to allow React application to call the REST APIs. Alright, so let me show you how we can resolve this issue. So let's go to IntelliJ IDEA and go to employee controller over here, and let us go and let's annotate this employee controller class with CORS origin annotation. And here let us pass star. So star means all the clients can able to call the employee related REST APIs. Alright, perfect. Next, let us go and let us restart this Spring Boot application. Alright, perfect. Our Spring Boot application is up and running. Next, let's go to browser and let us refresh the React application. And there we go. You can able to see the two employees are displayed in a list of employees table. Next, let us confirm whether this data is really coming from the MySQL database or not. So let's go to MySQL Workbench, go to EMS database, go to employees table, and look at here. The employees table has two employees, Sanjay and Ramesh. And if you go to React application, you can see Sanjay and Ramesh. It means our React application is successfully connected with get all employees REST API and displayed the response of that REST API in a list of employees table. Alright, I will see you in the next lecture. Hi everyone, welcome back. In previous couple of lectures, we have implemented list employee feature. In this lecture, we are going to add header and footer to the React application. Well, you can see the screenshot over here. We are going to add header and footer like this. Okay. So in the header section, we are going to display the application name, and in the footer section, we are going to display the copyright statement. Alright. So here are the development steps. We'll create a header component as a functional component, and then we'll import and use header component in an app component. Next, we'll create a footer component as a functional component, and next we'll import and use this footer functional component in an app component. Well, the first step is create a header functional component. So let's go to our project and go to components folder. Within that, let's create a new file. Let's call it as header component.jsx. Perfect. And within header component.jsx file, let's create a header component as a functional component. So here just type the React code snippet, React arrow function component export, and hit enter. And here you can see header component is created. Next, let us design the header component. Well, here go to return statement and just remove this header component string. And here let us have header HTML element, and within that let's have a navbar, and let's add the Bootstrap CSS classes. Well, if you go to browser and just search for Bootstrap 5 navbar, click on first link and just search for the dark navbar. So here we have a dark navbar. So let me copy these Bootstrap CSS classes. So these are the standard Bootstrap CSS classes that we can use to design or style the navbar. So let me copy them and go to header component and just paste them over here. Okay, perfect. Next, within a header, we need to also display the brand name or the application name, right? So let's go back to browser. In order to display the brand name like this in a header, we have to use navbar brand CSS class. So here let me copy this anchor tag and let me go back to header component, and within this navbar just paste it, and here let us give the application name or the brand name as employee management system, and here we can give the URL something like https www.javagates.net. You can give any URL that you want. Now we have written a code to design a simple header component. Next, let us take a look into next step. Next step is import and use header component in an app component. So let's go back to our code. And next go to app.jsx file, and here let us import header component. So just above this list employee component, just import header component and make sure that header component is imported at the top. Perfect. Next, save this file and let's go to browser and go to our React application, and look at here. The header is successfully added to the React application, and employee management system project name is also displayed. And you can see the console, there is an error. Did you mean class name? Well, if you go to header component, so here we have to use the class name attribute like this. Okay. Next, save this file and let's go back to browser and just refresh this, and you can see there are no errors. Okay, now we have added header. Next, let us take a look at the next step. Next step is create a footer component as a functional component and import and use this footer component in an app component. Let us go ahead and let's create a footer component as a functional component. So let's go to our project in VS Code, go to components folder, right click, new file. Let us give file name as footer component.jsx. Perfect. Within this file, let's create a functional component named footer component. So in order to create the functional component, let's use a React code snippet command. So React have a function component export. Next, let us design the footer component. So go to return statement, and here let us remove this footer component, and within this div let us use footer HTML element. Next, let's create one custom CSS class named footer, and let us write the CSS code for this footer custom CSS class. So go to app.css file, and here let me write the code. Footer is the CSS class name. It has a position offset, bottom 0, width 100%, height 50 pixel, background color dark, text align center, color white. So this is how we basically write the custom CSS class. So dot followed by the class name, and within curly braces we define the CSS properties like this. Okay, next let us use this class name in a footer component by using class name property like this. Okay, next within a footer let's use span element to define the footer copyright statement. So here all rights reserved 2023 by JavaX, something like that. So you can write any copyright statement as per your requirement. Next, let us take a look at the next step. Next step is import and use footer component in an app component. So let's go back to our project and let us import and use this footer component in an app component. So after this list employee component, let us use and import footer component like this, and make sure that footer component is imported at the top. Next, let us save this file and let us go to browser and look at here the footer, all rights reserved 2023 by JavaX. Okay, now the header and footer looks good for our React application. Alright, yet I will see you in the next lecture. Hi everyone, welcome back. In this lecture we are going to configure routing in a React application. Well, here are the development steps. First, we're going to install React Router DOM library using npm. Well, in order to configure the routing in the React application, we are going to use React Router DOM library. Next, we need to configure the routing in an app component. Well, in our React application, app component is a root component or a base component. So we have to configure the routing in an app component. Next, configure route for least employee component and then test route for least employee component. So first step is install a React Router DOM library using npm. So let us go to our project in VS Code and let us install React Router DOM library. And here let us open a new terminal, and here let us go inside our project cd ems frontend, and then here just type the command npm install React Router DOM and then save option, hit enter. So this will take a couple of seconds, and there we go. React Router DOM library is successfully installed. Let us verify in a package.json file. So go to package.json file over here and go to a dependency section, and notice here React Router DOM library is installed, and notice here the version 6.12.1. Okay, perfect. Next, let us take a look at the next step. Configure routing in an app component. Well, let's go back to the project. Let's go to app.js file, and here we need to configure the routing. Well, in order to configure the routing, we have to use routing related components from React Router DOM library. So here let us first import routing related components. So import. So these are the named export. So within a curly braces, just type browser router. So this named export from React Router DOM library. Perfect. Now we have imported browser router. So go to return statement, and notice here we have header component, list employee component, and porter component. Well, we no need to configure the route for header component and porter component because these two components are fixed. Okay, so we are going to only configure the route for this list employee component. So here we have to use this browser router at a top level. For example, before this header components, let us use browser router component here, and let us close this here. Okay, so just enclose all the components within this browser router component. And next, this is basically a React fragment, and within a React fragment we are going to enclose browser router. Okay, perfect. Next, let us use a routes component from React Router DOM. So here go to import, and let us import routes from React Router DOM, and go to header component. After that, just call here routes. So routes is basically a container or a parent for all the individual routes. Alright, so within this routes we can define the individual routes. Alright, so here let's configure the route for list employee component. So first of all, let me remove this because we are going to configure the route for list employee component in a routes. So here just type route. So this route should be from React Router DOM. So here let us first import it. So go to import statement, and here a route component from React Router DOM. Next, this route has path property. So here we can configure the URL for the component. For example, let us configure the base URL or the root URL. Whenever user enter this URL, that is HTTP, the localhost 3000 in the browser, then the corresponding component should be rendered, right? So for that, let us use element property, and let's configure the component name. So here list employee component, and then close it. Okay, so here basically we have configured a list employee component that this route will render whenever user hit this link in the browser. Okay, next let us configure one more route. Well, let us say if user enter the URL something like this in the browser, localhost 3000/employees, then we have to display the list employee component, isn't it? So here let's configure the route for the same route, and then path/employees, and the corresponding component name, that is list employee component. Alright, so whenever user hit this link in the browser, then the list employee component will be rendered. Now we have configured the route for list employee component. So here you can see the comment. So just select it and press Ctrl / and then here also select it and Ctrl /. So this is how we can add the comment in a JSX code. Okay, perfect. Now we have configured the route for list employee component. Next, let us take a look at the next step. Next step is test the route for list employee component. So let us go to browser and go to our React application, and here notice here the site can't be reached. So let us go back to our project and go to this first terminal and look at here restarting the terminal because the connection to send process was lost. So let us rerun our React application. So just clear the terminal. Next, let us type the command cd ems frontend, and then let us run the command npm run dev. Perfect. So React application is up and running. Next, let's go to browser and just refresh and look at here the base URL localhost 3000. Well, you can use either this IP address or localhost. For example, here instead of this IP address, we can use localhost. Okay. So this is the route for list component, right? For example, if you go to app.jsx file, go to app component. So here we have configured the route for the base URL. So whenever user hit this link localhost 3000, then the corresponding component will be rendered in a browser, right? So this is what we are testing here. Localhost 3000 and the list employee component is displayed. Next, we have one more route, that is /employees. So whenever user hit this link localhost 3000 /employees in the browser, then the corresponding list employee component will be rendered, right? So let us test this. So let us go back to browser and here just type the URL localhost 3000 /employees and hit enter, and there we go. The list employee component is displayed. Alright, it means we have successfully configured the route for list employee component. Alright, so in the upcoming lectures we will be creating a lot more components and we will also configure the route for those components. Okay, so I hope you understood how to configure the route for React components. Alright, so we have to use these three important components from React Router DOM to configure the routes, and make sure that this browser router component should be at the top. And next, we need to enclose all the individual routes within a routes component. Alright, perfect. In next lecture onwards, we will start implementing add employee feature. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In next couple of lectures, we are going to implement add employee feature. In this lecture, we will focus on creating employee component as a functional component. Well, here are the development steps. We first need to create a React functional component named employee component. Next, we will add employee button in the list employee component. Next, we will configure the route for employee component, and finally, we are going to test all these changes. Well, if you look at the screenshot over here, we are going to add employee button in a list of employees page. So whenever user click on this add employee button, then user should navigate to the add employee page. Okay, so the first step is create a React functional component named employee component. So let us go to our project in Visual Studio Code ID, and here let me minimize this and go to components folder, right click, new file. Let us give file name as employee component.jsx. Next, let us use React code snippets command to create the functional component. So here just type RAFCE. So this will create React arrow function export component. Now we have created employee component as a functional component. Next, let us take a look into next step. Next step is add employee button in a list employee component. So let us go to our project again and go to list employee component over here and go to return statement, go to heading. Right after this heading, we are going to add the button. So here just type button. Next, let us use Bootstrap CSS classes to style this button. Well, if you go to browser and in new tab just type Bootstrap 5 buttons and hit enter and go ahead and click on this link and just scroll down, and here you can see the Bootstrap CSS classes button primary, and you can see the corresponding button primary. So this looks good. So let us copy these two Bootstrap CSS classes. Let's go to our project and let us add these two Bootstrap CSS classes to button. So here class name property and then paste button primary, and let us give margin bottom 2 and let us give the name of the button add employee. Alright, next, whenever user click on this add employee button, then we have to handle on click event, right? For that, here let us have on click event handler, and next we need to pass the function here. So for example, here let us give function name as add new employee. Next, let us provide the implementation for this function. So here go to return statement. Just above this return statement, let's create the JavaScript function and then add new employee. Alright, so whenever user click on this add employee button, then we have to navigate that user to the add employee component, right? So in order to navigate user from one page to another page, we can use a navigate hook. So here go to import statement, and here let us first inject use navigate hook from React router DOM. So import within the curly braces, just type use navigate. So this use navigate hook from React router DOM. Next, use navigate hook is nothing but a JavaScript function. So let us assign this JavaScript function to a constant variable. So const navigator equal to use navigate. Next, let us use this navigator in a add new employee function. So go to add new employee function, and here just call navigator and then pass the URL /add employee. Well, whenever user click on add employee button, then user should navigate to add employee page. Alright. So next, let us take a look into next step. Next step is configure the route for employee component. Well, here we have specified the URL, but we haven't configured the route for this URL yet, right? So let us go to let's configure the route for employee component. So let us go to app.jsx, and here let us type route. Let us use its path property, and let's configure the URL /add employee. Next, let us use the element property, and let us specify the component name employee component. So whenever user hit this link in the browser, for example, let me copy this, paste it over here, and let me change the URL localhost 3000 /add employee. Then the corresponding employee component will be rendered in a browser. Okay. Well, if you go to list employee component.jsx file and go to add new employee, so here we have configured the URL /add employee. So whenever user click on add employee button, then user will navigate to the add employee route, and the component for this route is employee component. Okay. So basically, whenever user click on this add employee button, then user will navigate to employee component. Next, let us take a look into next step. Next step is test the above changes. So let us go and let us test all these changes. So let's go to browser and look at here, add employee button is added to list of employees page. Next, go ahead and click on add employee button over here, and look at here, the user is navigated to employee component. And if you can look at the URL add employee. Alright. So if you can compare with the code, so go to VS Code and look at here, whenever user hit this link in the browser localhost 3000 /add employee, then the corresponding employee component will be rendered, right? And within employee component, you can see employee component text. So this is a text displayed over here. Okay, it means we have successfully created employee component as a functional component, and we have configured the route for this employee component. Alright, in next lecture, we are going to design add employee form. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we'll take a look into add employee form handling. Well, if you look at the screenshot over here, we are going to design the add employee form that looks something like this. So we'll basically create a card. Within that, we are going to create a form. Alright. So basically we are going to use Bootstrap CSS classes to design this form. And this form looks good, isn't it? Next, let us take a look into the development steps. First, we'll define the state variables such as first name, last name, email in an employee component using useStateHook. Next, we'll design add employee form using HTML and Bootstrap. Next, we'll create a JavaScript function to handle onClick event. Well, whenever users submit the add employee form, then we have to handle the submit event, right? So for that, we'll create a JavaScript function. Next, we'll test the React application. So basically, I want to print the form data to the browser console. Alright. So first step is define state variables in a employee component using useStateHook. So let us go to our project in VS Code and go to employee component over here. And here, let me minimize this. So within employee component, let us define the state variables using useStateHook. So here, let us use useStateHook to create first name state variable. So just type useState and make sure that you import useState from React library at the top. So useStateHook is nothing but a JavaScript function. So we can pass the initial values. So here, let us pass empty value and then const and then array. So here, let us give state variable name as first name and let us give the function name set first name. So here, first name is a state variable name and set first name is a function name that we use to update the first name state value. Alright, next let us define the last name state variable using useStateHook. So here const and then array, let us give state variable name as last name, set last name is a function name and then useState, let us give initial value empty. Perfect. So similarly, let us define email state variable using useStateHook. So here const and then state variable name email, set email as a function that we use to update the email state variable value and then useStateHook, let us give initial value empty. Perfect. Now we have defined the state variables like first name, last name, email using useStateHook in a employee component. So this is the first step. Let us take a look into the second step. Second step is design add employee form using HTML and Bootstrap CSS classes. So let us go to our project and go to employee component, go to return statement and here let us remove this employee component string. So we are going to display the form in a container. For that, let us use container Bootstrap CSS class over here. And next, let us create a div and let us pass the Bootstrap CSS class, that is row. Next, let us create one more div and let us give Bootstrap CSS class, that is card. Well, we are going to display the form within a card. That's why here we are using Bootstrap CSS class, that is card. Well, if you go to browser and go to new tab over here and just search for Bootstrap 5 cards, click on first link and you can see the Bootstrap CSS classes card body, right? So these are the Bootstrap CSS classes that we are going to use to create the card, and within the card we will create the form. Okay, so let's go back to VS Code and here within a card, let's first add the heading. For that, let us use h2 element and let us give heading something like add employee. Perfect. Next, let us display this add employee heading at a center by using a Bootstrap CSS class, that is text-center. Perfect. Next, after heading, let us have one more div and let's give Bootstrap CSS class name, that is card body. Next, within a card body, let's create the form. Perfect. Next, within a form, let's create a div. Alright, and let's give Bootstrap CSS class, that is form -grid. Next, let us give margin bottom 2. Perfect. So within this div, let's create the label and input element. So here label, and then let us use bootstrap CSS class for this label, that is form-label. Next, let us give name to the label, that is employee first name, or let us give only first name. Okay, so let us remove this employee from here. Next, we need to have a input text box to enter the text. For that, let's have a input element over here, and then this input element has the properties like type. Let us give text, and then let's use the placeholder. Let us say enter employee first name, and then it has a name property. Let us give name as first name, and then it has value. So let us give value as a state variable name, that is first name. Well, if you look at here, we have defined first name as a state variable using use state hook, and this state variable we are passing to the value property here. Okay, next let us use the bootstrap CSS class, that is form-control. Next, whenever user enters some value in the text box, then we have to get that value, right? So for that, we can use unchange event handling. So here, just type unchange and just pass the event handler name. Let us say handle first name. So this is the event handler name. Next, let us create a JavaScript function to get the value from this input text box. So here, let us copy this handler name. So here, go to return statement. Above this return statement, let's create a JavaScript function. Let us give name as handle first name, and here let us pass event as a parameter. Next, we can get the value from this event object by using event.target.value. For example, here let us call set first name method, and then pass event.target.value. Alright, so this is how we can get the value from the event object. Now we have used set first name method to set the value to the first name state variable. Alright, so next go to form. So here we have created the field for first name. Similarly, let us create the field for last name and email. So here let me copy this div and let me paste it over here, and let me change the content accordingly. So here instead of first name, last name, and here placeholder enter employee last name and name last name, and let us pass state variable name, that is last name. Next, unchange and the handler name handle last name. Perfect. Next, let us create a JavaScript function that will handle this unchange event. So go to return statement. Just above this return statement, let's create a JavaScript function handle last name, and then pass event object. Let us get the value from this event object. So here let us call set last name, and we can get the value from event object like event.target.value. Alright, perfect. Now we created input field for last name. Similarly, let us create it for email. So let us copy this div and let us paste it over here, and let us give label as email, and here go to input element type, let's give password. Next, placeholder enter employee email, and name let's give email, and value let us pass the state variable, that is email, and then let us give handler name, that is handle email. Alright, so let us create a JavaScript function that will handle this unchange event. So go to return statement. Just above this, let's create a JavaScript function handle email, and then pass event object, and then call set email event.target dot value. Perfect. Now we have created input field for email as well. Next, let us create the submit button. So here, let us have button. Let us give Bootstrap CSS classes such as button, button success. Perfect. Let us give button name as submit. So here, whenever users submit the form, then we have to handle the onClick event, right? So here, let us have a onClick property, and here let us pass the handler name. Let us say save employee. Okay, perfect. Next, let us take a look into next step. Next step is create a JavaScript function to handle onClick event. So let's go to our project again. So here we have specified the handler name save employee. So let us create a JavaScript function that will handle this onClick event. So let's go to return statement. Just above this return statement, let's create the JavaScript functions, and let's give name as save employee, and then let us pass event object. Next, within a save employee method, just call event object dot prevent default. So this will prevent the default activities that will happen while submitting the form. Next, here let us put the console.log. So before that, let's create the object. So const and then employee. Let us set all the fields to the object such as first name, last name, email. Next, let us print this employee object to the console. Alright, perfect. Now we have created a JavaScript function to handle form submission event handler. Next, let us take a look into next step. Next step is test the React application. Well, let us go back to our project and look at here, restarting the terminal because the connection to the self process was lost. So let us start our React application again. So here, let me clear the console, and then let us type the command cd ems frontend, and then type the command npm run dev. Perfect. Our React application is up and running. Next, let's go to browser and go ahead and click on this add employee button over here. And notice here the add employee form not looks good. So some Bootstrap CSS are missing for this add employee form. So let us go ahead and let us add some Bootstrap CSS classes to make this add employee form more, beautiful. So let's go back to our VS Code, and here go to this div, that is container, and go to row, go to card, and here let us use Bootstrap grid system related classes to align the form at a center. For example, here column mid 6. Well, the Bootstrap grid has total 12 columns, and we are using 6 columns for form. Next, we need to align the form at a center. For that, we are going to use offset to move columns to right and left. So here we are going to move the form by 3 columns from left and 3 columns from right. So here again offset mid 3. Okay, next, let us save this file and let's go back to browser, and now you can see the form is located at the center of the page. Next, here you can see the card is slightly attached to the header. So let us give some space between this form and header. So let's go back to employee component again, and here after this container, let us have some break elements. Perfect. Let us save this file. Let's go back to browser, and there we go. Now the add employee form looks good. Okay. Next, let us test this add employee form. So here, right click, inspect, and then go to console, clear the console, and here just enter at first name Ramesh, last name Fadtare, email ramesh@gmail.com. So look at here, we have given the input type as a password. That's why the text looks like this. So let's go to our project again and go to form and go to email feed over here, and here input type password. So let us change from password to text. Okay. Next, let's go to browser And now you can see email is visible, ramesh@gmail.com. Okay. Next, clear the console and go ahead and click on submit button and look at here. The employee object is printed and the employee has first name Ramesh, last name email ramesh@gmail.com. It means we have successfully done add employee form handling. Okay. Now let me show you some of the best practices that you can follow while form handling in a React application. Well, let's go to our project and go to employee component, and notice here we have written a separate handlers to handle each form input field, right? So instead of writing this much of code, what we can do is we can use JavaScript arrow function to set the values to the state variable in the input text field itself. For example, here go to first name and go to unchanged event handler. Well, notice here for this unchanged property, we are passing the complete function. We are not calling the function. Well, in JavaScript, we typically use the syntax like this to call the function, right? But here we are not using the braces over here. We are passing the function itself to this unchanged property. Okay, and this handle first name is a handler function, and this function basically set the value to the first name field. So here, if we write the arrow function, so instead of Java function, we can write the arrow function like this: const handle first name and then arrow symbol like this, isn't it? And here also for last name, we can write the arrow function const and then handle last name equal to and then arrow symbol. Next, for handle email also, we can write the arrow function like const handle email and then arrow symbol. So if you can notice the arrow functions, each arrow function body has a single statement, right? So if arrow function has a single statement in the body, we can also remove the open and close curly braces like this. Alright, so this is how we can simplify the arrow function. So here also let us remove open and close curly braces from handle last name and similarly from handle email. Perfect. Next, go to again first name field. Here we are passing the function itself, right? So instead of writing the separate arrow function like this, we can simply pass the arrow function body here itself. So let me copy this body and go to first name field and go to unchanged event handler. Here instead of this, let me paste over here. So we can also provide the arrow function to unchanged property like this. Okay, so again we can reduce this line of code as well. Similarly, let's copy this from last name and go to last name field, and instead of this handler name, let us paste this function body. And next, let us remove this line of code as well. Next, similarly, let's do it for email as well. So let's copy this body and go to email field, and here instead of passing the function name, let us pass the function body itself. Next, we can remove this line of code. So this is how we can refactor the code and we can reduce some amount of code. So this is basically the best practice we use while developing the React application. In next lecture, we will connect our React application to add employee REST API, and we'll send the add employee form details to the add employee REST API, and then add employee REST API will save those form details into a MySQL database. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to connect our React application to add employee REST API. Well, in previous lecture, we have designed add employee form, and whenever users submit this form, then our React application have to connect to add employee REST API, and then our React application will send this form information to add employee REST API, and add employee REST API internally store this form data into MySQL database. Alright, great. So let us take a look into the development steps. In an employee service, we will write the REST client code to call add employee REST API using Axios. Next, we will change employee component to call employee service method. Next, we will navigate to list employee page after form submission done. And finally, we will test all these changes. Alright, So let us head over to employee service and let us write the REST client code to call add employee REST API using Axios. So here let us head over to VS Code and go to employee service.js file, and here let us write the REST client code to call add employee REST API. So let's create the arrow function and let us export it. So export const, and then let's give the name create employee, and this is arrow function, and this arrow function takes employee object, and this employee object holds the employee form data. Next arrow symbol, and then call Axios dot post. Well, in order to send the post HTTP request, we have to use post method. Next, let us pass the URL, that is REST API base URL, and second parameter is a employee object. Perfect. Now we have written a REST client code to call add employee REST API using Axios.post method. Alright, great. Next, let us take a look into next step. Next step is change employee component to call employee service method. Well, just now we have created create employee method in a employee service. So let us call this method from the employee component. So go to employee component over here. So here we have save employee function. So within this save employee function, let us call the create employee method from employee service.js file. So here let us call create employee method from employee service, and make sure that this create employee should import it at the top. Next, this create employee expect employee object. So let us pass this employee object, and notice here this employee object contains first name, last name, email. Next, let us call then method, and then this then method expect the promise object. It contains the response. So here response, and then let us get the response using arrow function over here. So here let us print the response console.log, and then response.data. Perfect. Now we have changed employee component to call create employee method from employee service. Next, let us take a look into next step. Next step is navigate to list employees page after form submission done. Well, whenever user submit add employee form, then user have to navigate to the list of employees page, isn't it? So let us write the logic to navigate user to list employees page after form submission done. So let us go to our project again. So in order to navigate user from one page to another page, we can use navigate hook. So here let us first import use navigate hook. Import, and then use navigate hook from React router DOM library. Perfect. So use navigate hook is nothing but a JavaScript function. So we can call use navigate hook here, and then we can assign this function to a variable. So const and then navigator equal to use navigate. Okay. Next, let us go ahead and let us use this navigator within this create employee method. So after this console.log, just call navigator, and then let us pass the URL, that is /employees. And notice here this /employees will navigate to the list employee component. For example, if you go to app.jsx, and you can see the route /employees. So whenever user hit this link in the browser, then user should navigate to list employee component, isn't it? Perfect. Next, let's go back to employee component.jsx. Now we have navigated user to list of employees page whenever a user submit this add employee form. Next, let us take a look on the next step. Next step is test above changes. Next, let us go to our project and let us see our application is up and running in a development server or not. Yes, our application is up and running. Let's go to browser and just refresh. Now let us fill up the add employee form over here. So first name, let us say Tom, last name Cruz, email tom@gmail.com, and click on submit button, and there we go. You can able to see here Tom employee is added to the list of employees table. Alright, and you can see the console log here. The response is printed. The response contains ID 6. It means our React application is successfully connected with add employee REST API. Well, let us verify this data in a database as well. So let us go to MySQL workbench over here and go to EMS database, go to employees table, and look at here, top employee successfully inserted in an employees table. It means we have successfully connected our React application to add employees API, and we have stored the employee form data into a employees table. Alright, perfect. In next lecture, we will see how to validate the add employee form. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to add a validation to add employee form. Well, if you go to our React application and go to add employee page, so here we haven't added any validation to the add employee form. For example, if I click on submit, it will add a empty entry in the list of employees table, and in a database also the empty values are inserted. For example, here let me select the rows from employees table, and notice here employee ID is empty, first name is empty, last name is empty. So this is not a good idea to store the null values or empty values in a database columns. Alright, so let us go ahead and let us add the validation to add employee form so that user have to enter the data in the fields. Okay, so let us go to the presentation and look at here the screenshot. So we are going to basically add a validation that looks something like this. The first name is required, last name is required, email ID is required. Next, let us take a look into the development steps. First, we use state hook to initialize the state variables that will hold the validation errors. Next, we will write the validation function that checks the form data and returns validation errors. Next, we will validate the form on submission. Next, we will display the validation errors. And finally, we are going to test all these changes. Alright, so very simple steps. The first step is we are going to use state hook to initialize the state variables that will hold the validation errors. So let us go to our project and go to employee component over here. So let me maximize this. And here let us type use state. Make sure that you choose use state from React library, and then let us pass the initial value as an object, and the object has the attributes like first name, and let us give empty, and then last name let us keep empty, and then email let us keep empty. So these are the object attributes to hold the validation errors with respect to the state variables. Okay, next, this use state hook returns an array. So here const and then array. So let us give the state variable name as errors and the function name as set errors. Perfect. Now we have used use state hook to initialize the state variables that holds the validation errors. Next, let us take a look into next step. Next step is we will write the validation function that will checks the form data and returns the validation errors. So let us go back to our employee component over here, and here we are going to write the JavaScript function that will check the form data. So here just type function and let us give function name as validate form. Alright, next within a validate form, let us declare a flag let valid equal to true. So let us keep flag as a true initially. Next here, let us have a constant variable. So let us call it as errors copy. And here let us use the spread operator to copy the errors object into this errors copy. For example, here within a curly braces 3 dot. So this is basically a spread operator. Okay, so we use spread operator to copy object into another object, and here we are going to copy the errors object. Alright, so here look at here, this errors object is nothing but a state variable, and here we are basically copying this errors object into a separate variable, and then we'll store all the validation errors in this errors copy variable. Okay, next here let us add the if condition to validate the first name. If first name dot trim. So here basically I want to trim the string. If first name is not empty, then we'll keep this validation field as a empty. For example, here errors copy dot first name. So let us keep empty because we are not going to show any validation error. If the first name is null or empty, then in the else part, what we're going to do is we're going to add the validation error. For example, here errors copy dot first name equal to first name is required. So this is the validation error message, and then we'll set valid flag as a false. So here basically we have added if else condition, like if first name is not empty or not null, then we don't show any validation error. If first name is null or empty, then we'll show the validation error, that is first name is required. Okay, and then valid equal to false. Next, let us add if else condition for last name and email as well. So here if last name dot trim, then we don't show any validation error. So here just call errors copy dot last name equal to empty. Next, in the else part, errors copy dot last name equal to the validation error last name is required, and then set this valid flag as a false. Perfect. So similarly, let us add a condition for email as well. So here if email dot trim, then errors copy dot email equal to empty, else errors copy dot email equal to, well, here let us give a validation error, something like email is required, and then set this valid flag as a false. Perfect. And then let us set this errors copy object to state variable using set errors method. So here just call set errors method and then pass errors copy. Okay, and finally let us return this valid flag. Okay, now we have written the validation function that checks the form data and returns the validation errors. Next, let us take a look into next step. Next step is validate form on submission. So let us go to our project again, go to employee component, go to save employee method over here, and here let us add the if condition, if validate form. So notice here this validate form method returns a boolean value, either true or false. If any one of the validation fails, then this method returns a false. Alright. Next, if this validate form returns true, then only we need to execute this logic. So here let us cut this logic and paste it in this if block. Alright. So if first name, last name, email fields are not null or not empty, then this validate form returns true and this piece of code will get executed. Okay, now we have validated the form on submission. Next, let us take a look into next step. Next step is display validation errors. So let us go back to our project again and go to the form over here and go to this div. Here we have input field and here we have a class name. So basically we need to display the CSS class based on the condition. Okay, so if you go to browser, in the new tab just search for Bootstrap validation, click on this first link. So here basically we need to use validation related couple of Bootstrap CSS classes. For example, we are going to use is invalid CSS class, and then we are going to use invalid feedback. Okay, so these two CSS classes we are going to use to add the validation to the input fields. Alright, so let's go back to our project and here go to input field for this first name, and here is a class name property. So here we need to dynamically set the Bootstrap CSS class based on the validation error. If validation error is there, then we'll add is invalid CSS class, otherwise we'll add form control class. Okay, so here just remove this form control and let us write the JavaScript code to dynamically add the bootstrap CSS class. So here within a curly braces, just add the backtick symbol. So notice here this is not a single quote, this is a backtick symbol, and then form control. Next we need to add the one more bootstrap CSS class based on the validation error. If there is a validation error, then only we will add a is invalid bootstrap CSS class. For that, let us write the code here. Dollar within a curly braces, just access this errors object. It has a first name, right? So if the first name contains validation error, then what we're going to do is we're going to add a bootstrap CSS class that is hyphen invalid. Perfect. If there is a no validation error, then what we're going to do is we're going to keep empty. Alright, perfect. So here we have added a condition. So based on the validation error, we will add the bootstrap CSS class. Okay, perfect. Next, we need to show the validation error message right after the input text box. So here go to input element. After this input element, let us add the JavaScript code. So here errors dot first name. So if the first name contains the validation error message, then we're gonna display that validation error message in a div. So for that, let us add the condition and then let us have a div. Let us close this div over here, and let us add the bootstrap CSS class for this div. So class name, and let us give the bootstrap class name that is invalid feedback. Perfect. Next, let us display this validation error message. So within a curly braces, errors dot first name. Perfect. Now we have displayed the validation error message for this first name field. So similarly, let us do it for last name and email as well. So here, let me copy this class name and go to last name and go to input element, and here we have a class name. So let us remove this and paste it over here, and here let us change from first name to last name. Perfect. Next, go to first name field over here and just copy this and go to last name. After this input element, just paste it, and let us change the attribute from first name to last name, and here also change from first name to last name. Okay, now we have displayed the validation error message for last name. So let us do it for email as well. So let me copy this class name and go to email and just paste it here and just change from last name to email, and here just copy this and go to email. After this input element, just paste it and let us change from last name to email. And here also let us change from last name to email. Perfect. Now we have displayed the validation error message for all the input fields. Okay, next let us take a look at the next step. Next step is test about changes. So let us go to our project and let us say our application is up and running or not. Well, our application is up and running. Let's go to browser and let us test all the changes. So here go to our React application, and here let me refresh this add employee page and let me click on submit button. Well, notice here the error in the console. Even though we have added a validation, but our React application is calling add employee REST API. So let us see what is the issue. So go to our React application and go to employee component over here, and here go to save employee method, and look at here in a if condition we have called valid form method, right? So here basically we need to provide the open close braces like this. So in order to call the JavaScript function, this is the syntax, right? Now we have corrected the syntax. Next, let us save this file and let's go back to browser, and now let us refresh and then click on submit button, and there we go. You can able to see the validation is successfully applied to add employee form. Alright, the first name is required, last name is required, email is required. Okay, next let us fill up the form. So first name John, last name Sina, and then email john@gmail.com, and click on submit, and there we go. John employee is added to the list of employees table, and here you can see in the console the response contains the ID 14. Let us verify in a database table. So go to MySQL Workbench, go to employees table, and look at here, John employee successfully inserted in the employees table. It means we have successfully added a validation to add employee form. In next lectures, we will start implementing update employee feature in a React application. Alright, yet I will see you in the next lecture. Hi everyone, welcome back. In next couple of lectures, we are going to implement update employee feature in a React application. So in this lecture, we are going to add update button, title, and a route. So if you can see the screenshot over here, we are going to add the update button like this, and whenever user want to update the employee, then user can go ahead and click on update button. So this will navigate to the update page, and from there user can update the employee. Alright, so in this project we are going to use the employee component to perform both the operations like add employee and update employee. Alright, so instead of creating a separate component for update operation, we can use a single employee component to perform both add employee and update employee operations. Alright, so here are the development steps. First, we're going to add update button to the list employees page. For example, we're going to add the update button to list employees page like this. Next, we'll add a route for update employee in the app component. Change page title dynamically. Well, we are going to use employee component to perform both add and update operations. So dynamically, we have to change the page title. For example, if you look at here, the add employee page. So in case of add employee operation, the page title should be add employee, and in case of update employee operation, the page title should be update employee, right? So we're gonna change this page title, dynamically based on the operation. Next, we're gonna test all the changes. Okay, the first step is add update button to the list employees page. So let us go to our project in VS Code and go to list employee component and go to table and go to table heading and go to table row here, and here let us add one more column. So let us call it as actions. So within actions column, we can add the buttons like delete, update. Alright, next, correspond to these actions columns, we are going to add the button. So go to table body, go to table row, and here let us add TD element. Within a TD element, let us add the button. So here just type button, and let us give button name as update. Next, let us add bootstrap CSS classes to this button. So here let us use class name property, and let us give bootstrap CSS classes like button info. Next, whenever user click on this update button, then we have to handle the on-click event, isn't it? For that, let us have on-click event handler, and then here we need to pass the handler function name. So if you can notice here, we need to pass the employee ID to the handler function. So for that, let us use the arrow function over here. So this is the arrow function, and let us use the function name something like update employee, and then we need to pass the employee ID. So here employee dot ID. So here we have employee object, so we can get the ID from the employee object like this. Okay, perfect. Now we have added a button, and we have passed the handler function to this on-click event. Next, if you go back to browser, and if you go to employees page over here, you can see update button is added in the actions column. So whenever user click on this update button, then user should have to navigate to the update employee page. For that, we need to configure the route. Well, if you look at the development steps, second step is add a route for update employee in an app component. So let us configure the route. So let's go to VS Code, go to app.jsx file, and here let me write the comment first. So whenever user click on this link like localhost 3000 edit -employee /employee ID, then user should have to navigate to the employee component. So here just create the route and then path and then the URL edit employee, and we need to pass the employee ID dynamically. For that, here is the syntax :ID. And next, let us use element property to configure the component. So within a curly braces, just pass the component, that is employee component. Just close it. Okay. So whenever user hit this link in the browser, then user should navigate to the employee component. All right. Perfect. Next, let us go to list employee component over here. And in previous step, we have added update button, right? So whenever user click on this update button, then we have to handle this on click, event handler. So here we have written the handler name, but we haven't implemented this handler. So here let's create the JavaScript function. Let us give the function name as update employee, and it takes ID as a parameter. Next, whenever user click on this update button, user have to navigate to the update employee page, right? So here let us use navigate hook to navigate user to the update employee page. So here let us call navigator. Navigator is nothing but use navigate hook. Next, we need to pass the URL, that is edit employee, and we need to pass the employee ID in the URL. So here is the syntax backtick symbol and then /edit employee / and then we need to pass the employee dynamically. So here is the syntax $within curly braces, just pass the ID. Okay. So make sure that you add the backtick symbol, not the single quote like this. Okay. So just enclose this URL in a backtick symbols, not in a single quote. Alright, perfect. Next, let us take a look into next step. Next step is change page title dynamically. Well, this employee component supports both the operations like add employee, update employee. So let us change the page title dynamically based on the employee ID. So let us go back to employee component. And here, let us write one JavaScript function. So just type function and let's use function name as page title. So notice here, within this function, we have to write the logic like if employee ID is present in the URL, then we need to return the page title as update employee or else add employee. Alright, so let us get the employee ID from the URL by using use params hook. So here go at the top and here let us import the use params hook from React Router DOM. So here use params hook from React Router DOM library. So this use params hooks is a JavaScript function. So here just call use params hook, and this hook returns object with key value pair, and we just want key. So here const and then just add a destructuring and then pass ID. Okay, now we got the ID by using use params hook. Next, let us use this ID in a page title method. So go to page title method. Within that, let's add a if condition, and if ID is present, then we need to simply return the page title as update employee. So here we have page title. So let us copy this and go to page title method and just return update employee. In a else part, return page title as a add employee. Perfect. Next, go to this S2 element over here, just remove this, and we need to dynamically add the page title. So let us write the JavaScript code. So within a curly braces, just call this page title method. Alright, so let us remove this semicolon. Okay, perfect. Now we have added the page title dynamically based on the employee ID. Okay, perfect. Next, let us go to the development steps. The final step is test all the changes. So let us go back to our project and let us see our project is up and running or not. Well, our project is up and running in a development server. Next, let us go to browser and let us test all these changes. So go to React application in the browser and go ahead and click on this update button, and there we go. The user is successfully navigated to update employee page, and you can see the URL edit employee/2. So 2 is nothing but the employee ID. It means we have successfully added update button in a list of employees table, and we have added route to this update employee page, and we have also updated the page title dynamically based on the employee ID. Alright, good. In next lecture, what we're gonna do is we're gonna connect our React application to get employee REST API. Well, if you look at the update form, so we have to populate this update employee form with the data so that user can go ahead and update the employee details, isn't it? So in order to populate this employee form, we have to connect our React application to get employee REST API, and we'll get the response and we'll populate this form. Alright, great. I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we want to connect our React application to get employee REST API, and we need to populate the response of this REST API in a update employee form. Well, if we go to our React application, so here we have update employee form. So in order to update the employee, we have to populate that employee data in the update employee form, isn't it? So in order to do that, let us connect our React application to get employee REST API and populate the response of this REST API in a update employee form. For example, if you look at the screenshot over here, we are going to populate the update employee form with the data like first name, last name, and email like this. Alright, great. Next, let us take a look into the development steps. In the employee service, let us write the REST client code to call get employee REST API using Axios. Next, we will use effect hook to populate the employee data in the form for update operation. Next, we will test all these changes. Alright, so first step is in the employee service, let us write the REST client code to call get employee REST API using Axios. So let us go to our project and go to employee service.js file, and here let us write the REST client code to call get employee REST API. So let us create the arrow function and let us export it. So here export const, and let us give the variable name get employee, and this method takes employee ID as a parameter, and then arrow symbol, and then call Axios dot get. Well, in order to make the HTTP GET request, we can use GET method over here, and then pass REST API base URL. Next, we need to append this employee ID to this base URL. So here single quote slash and then employee ID. Perfect. Now we have written a REST client code to call get employee REST API using Axios.get method. Next, let us take a look into next step. Next step is use effect hook to populate the employee data in the form for update operation. So let us go back to our project and go to employee component over here. So let me minimize this. Next, go to employee component. Within employee component, here let's call use effect hook, and notice here use effect hook takes two parameters. First parameter is a callback function, second parameter is a dependency list. So let us call use effect hook, and let us pass first parameter as a arrow function, second parameter is a dependency list. So here let us add ID as a dependency. Okay, perfect. Next, within a use effect hook, let us write the logic like if ID is present, then we'll populate the update employee form with the response of the REST API. So here just call get employee method from employee service, and then pass employee ID as a parameter to this method, and then call then method, and then a response object, and then arrow function. So next we have to set the data from response to these state variables. For example, here we have state variables like first name, last name, email, and we have to set the data to these state variables using the respective methods. Okay, so here just call set first name method, and then pass response dot data dot first name. Similarly, let us call set last name method and then pass response dot data dot last name. Next, set email and then response dot data dot email. Perfect. Next, let us have also a catch block, catch and then error object and then arrow function, console dot error method and then pass error object. Perfect. Next, let us take a look into next step. Next step is test above changes. So let us go back to our project and look at here our applications up and running in a development server. Next, let us go to browser and here go to list of employees page and just go ahead and click on this update button, and there we go. You can able to see here the update employee form is populated with the data like first name Sanjay, last name Jadhav, email sanjay@gmail.com. Okay, now you might be wondering how this data is displayed in this input text box. Well, let me explain that. So go to VS Code IDEA again, go to employee component over here, and here we have called get employee method. It returns the response of the REST API, and here we are using set first name method to set the response, that is first name, to the state variable first name, right? And this first name we have used in the form. For example, if you go to form, go to first name field, go to input element, and here you can see value and then first name state, and this first name state basically contains the value. Okay, similarly you can go to last name and you can see the input element, value, last name, state variable, and this state variable basically contains the data. Okay, next email. So email state variable also contains the data, and this data we are basically setting over here by using the respective set method. Okay, so this is how the data will be populated in the form fields using state variables. In next lecture, we'll connect our React application to update employee REST API, and we'll send this updated form information to the update employee REST API, and then update employee REST API will update that data into a database. Alright, I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to connect our React application to update employee REST API. Well, in previous lecture, we have populated the update employee form with the data. Next, once user submit this update employee form, then we have to call update employee REST API, and then we have to send this updated employee data to the update employee REST API, and then update employee REST API will store that updated information into the database. Alright, great. So let us take a look into the development steps. First step, in an employee service, we need to write a REST client code to call update employee REST API using Axios. Next, we will change employee component dot save or update employee method to perform both add and update employee operations. And next, we will test all these changes. Alright, so let's go to employee service file, and let us write the REST client code to call update employee REST API. So let us go to our project and go to employee service.js file, and here let us write the REST client code. So let us have export and then const. Let us give variable name update employee, and let us pass the parameters. First parameter is the employee ID, second parameter is the employee object. So this employee object basically contains the updated employee information, and next arrow symbol, and then call Axios dot put. Well, in order to make the HTTP put request, we have to use put method over here, and then pass the REST API base URL. Next, let us append the employee ID to this URL. For that, let us use a concatenation operator plus, and then single quote slash plus employee ID. So this is the first parameter. Second parameter is the employee object. Perfect. Now we have written a REST client code to call update employee REST API using Axios.put method. Next, let us take a look into next step. Next step is change employee component dot save or update employee method to perform both add and update employee operations. Well, let's go to employee component over here and go to save employee method. So within a save employee method, let's write the logic. Well, this save employee method supports both add employee and update employee operations. So let us rename this save employee method from save employee to save or update employee. Next, copy this function name and go to form and go to submit button. And here we have save employee handler method name. So let us remove this and paste this save or update employee handler method name. Okay, perfect. Next, let's go back to save or update employee method over here, and here let's write the logic to support update employee operation as well. Next, within this if condition, let's add one more if condition over here. If employee ID is present in the URL, then only we'll execute the update employee logic. So here within a if condition, just call update employee method from employee service and then pass employee ID as a first parameter and then employee object as a second parameter. So here what we're going to do is we're going to cut this piece of code and we'll keep at a top, and then here the employee object is available. So just pass employee object and then call then method and then have a response object over here and then arrow function. Perfect. So here let us print the response console.log and then response.data. Perfect. So once user submit the update employee form, then user have to navigate to the list of employees page. For that, let us have a navigator and then within a single quote /employees. Perfect. So here let us also have a catch block. So catch and then error object and then arrow function console.error and then pass error object. Perfect. Next, let us have a else block. Within else block, let us keep this add employee logic. Just cut it and paste here. Perfect. And go to this create employee method, and here also we can have a catch block. So catch and then error object and then arrow function console dot just call error method and then pass error object. Perfect. Now we have updated save or update employee method to support both update employee and add employee operations. Okay, next let us take a look at the next step. Next step is test above changes. So let us go back to our project and look at here our application is up and running in a development server. Next, let's go to browser and let us test all the changes. So here go to our application and go to employees page over here and let me clear the console and let me click on update button, and here let's update the first name from Sanjay to Sanjay123, last name Jada123, Sanjay123@gmail.com. Click on submit and look at here the employee first name is updated, last name is updated and email ID is also updated. It means we have successfully connected our React application with update employee REST API, and update employee REST API stored the updated employee information into a database. Alright, so let us verify in a database as well. So go to MySQL Workbench, go to employees table and look at here the Sanjay employee. First name is updated, last name is updated and email ID is also updated. It means we have successfully implemented update employee feature. Okay, now let us add a new employee and let us update that new employee. So here click on add employee button and let us add an employee. So let us give the employee name Meena, last name Padhare, email ID meena@gmail.com. Click on submit. Now the Meena employee is added to the list. Next, let us update this Meena employee. So click on update button. Let us give first name as Meenakshi and then change the email ID meenakshi@gmail.com. Click on submit and look at here the first name is updated, email ID is also updated. It means update employee feature is working as expected. In next lecture, we'll implement delete employee feature. Alright, yet I will see you in the next lecture. Hi everyone, welcome back. In this lecture, we are going to implement delete employee feature in a React application. Well, if you look at the screenshot over here, we are going to add a delete button in actions column like this. And whenever user want to delete the particular employee, then user can go ahead and click on the corresponding employee delete button. For example, here let us say user want to delete the Ramesh employee, then user can go ahead and click on this delete button to delete this Ramesh employee. All right, great. So here let us take a look into development steps. In the employee service, we will add the REST client code to call delete employee REST API using Axios. Next, we will add a delete button to list employees table. Next, we will create a JavaScript function to handle delete button event. And finally, we are going to test all these changes. Okay, so let us go to employee service and then let us write the REST client code to call delete employee REST API using Axios. So here let's head over to VS Code. I go to employee service.js file and here let us write the REST client code. So here export const and let us give variable name delete employee and then pass the employee ID as a parameter to this method and then arrow function and then call axios dot delete. Well, in order to make HTTP delete request, we can use delete method and then pass REST API base URL. Next, we need to append this employee ID to this URL. So here let's have a concatenation operator, that is plus within a single quote slash and then employee ID. Perfect. Now we have written a REST client code to call delete employee REST API using axios.delete method. Next, let us take a look into next step. Next step is add delete button to list employees table. So let us go to our project and go to list employee component over here. And here we have a table and go to table body. And here we have already a update button. So similarly, let us add the delete button. So here let us have a button and let us give name to the button as delete and let us add the bootstrap CSS classes. So here class name property and then bootstrap CSS class name button danger. Perfect. Next, let us have a onClick event handler. For that, let us call onClick property and here we need to pass the handler function name. So we need to also pass the employee ID. So let us use the arrow function to pass the employee ID to the handler method. So arrow function and let us give the function name as remove employee and then pass employee.id. Perfect. Next, let us implement this remove employee event handler method. So just copy this method and go to return statement and just above this return statement, just create a JavaScript function and then remove employee and then pass employee ID. And here let us have a console.log just to print this employee ID. Perfect. Next, let's go to browser and look at here the delete button is added to the actions column. Next, just right click, inspect and go to console, clear the console and click on the delete button and you can see here the ID 2 is printed in a console. It means the ID is available in a remove employee method. Okay, next let us call delete employee method from employee service and make sure that this delete employee method is imported at the top. Alright, next let us pass employee ID as a parameter to this method and then call then method and then let us have a response object and then let us use arrow function. Alright, and here let's have catch block, catch error and then arrow function console dot error and then pass error object. Perfect. So here once user click on the delete button, then the corresponding employee will be deleted and then user have to navigate to the list of employees page, isn't it? Next, if you go to use effect hook, so here we have written the logic like we have called list employees method from employee service. So here what we can do is we can have this logic in a separate method. So let us cut this logic and here let's create a separate JavaScript function get all employees and then paste this logic and next go to use effect hook and here simply call this get all employees method. Okay, perfect. Now we have quickly refactored this code. So we have created a separate function and we have kept the logic over here. Next, we can call this function in a remove employee method as well. So go to remove employee method, go to this delete employee call, and here just call get all employees. Next, let's take a look into next step. Next step is test above changes. Well, let's go to our project and look at here our React application is up and running in a development server. Next, let us go to browser and let us test all these changes. So here, go to list of employees page, and let us say we want to delete the employee, that is Sanjay 123. So go ahead and click on the corresponding delete button, and there we go, the Sanjay employee is deleted. Next, let us say we want to delete the employee with ID 7. Just click on the corresponding delete button. There we go, the employee is successfully deleted. It means the delete employee feature is working as expected. Well, notice here update and delete button. So both the buttons are attached. So let us give some space between update and delete buttons. So let us go to our project and go to list employee component and go to delete button over here, and here let us add the inline style. So for that, let us call style property and then object, and then it has margin left. So let us call margin left, and let us give value as 10 pixel. Perfect. Next, let us save this file and let's go to browser, and now look at here, there's a space between update and delete buttons. Now it looks good, isn't it? So next, let us click on the delete button to delete the employee with ID 6, and there we go. It means we have successfully implemented delete employee feature. Alright, I will see you in the next lecture.